Hey everybody, we got a little crab rave to start the day. I don't know, I always ask if everyone can hear and see me. How's everyone doing? I see Kyle in the chat, Isaac and William and Aaliyah and Josh. We got an oof in the chat. What is going on? Can everyone hear and see me? There was one time I started class and people could not hear and see me, and the chat was like, Brian, Brian, loud and clear. I like that. And so that's always awesome because, like, that one time I was going on, it was like 5 minutes into the class, and everyone was like, Brian, what's going on? It's good to see you, Camden and Ethan and Skylar and Kyle and Elizabeth and Sarah and Nicole and Whitley and Cooper and Bridget and Zulon. Good to see everybody. Josh, good to see everybody here. I want to say something. I know it is Friday. It's so crazy to me since we're in online class. I don't know why people skip. I'm like, wait a minute. All you have to do is turn on your computer and at least like I think you get some points for at least being in chat. You get more points for chatting like you're doing right now. So you're getting points once again. Points might be working. Sometimes it takes like 9 minutes. Maybe we'll check right here. We'll see if points are currently on. Remember, these are kind of like start a class. We're just getting warmed up. Go get yourself some coffee. We're just going to talk about like what's going on. Stat Nation, you got it right there, Keaton. What's going on, Stat Nation? What are we called? Statters? If you know some Davey 504 right there. Does he call him that? I'm trying to think what Davey calls his people. So I know, why would you pay for a class and then skip it? And we're just like, this is just our chill time right here. So you guys are awesome. I love all the I love it. This is like a social media experience. That's the way I try to tell people. So once again, we're gonna hope Streamlabs starts doing its thing. I do want to point out once again, just in case people didn't see it last class, let me show you some of the goodness. A few cool things going on right here. Da-da-da-da-da. The I'm slowly learning more and more about my setup. I have to I actually have to turn on my Go XLR. So I think the Go XLR is working. My volumes should be good, but I can't actually play some cool sounds right now, which I'm kind of bummed about. I realized that about 3-4 minutes before I was going to go live, and I was like, oh, I want to put my sounds on the stream, but I can't. So if you didn't see this yesterday, here's something really great about the streams. Just in case people did not notice this, can we go into theater mode? Oh, cool. That looks great right there. Okay, let me bring myself back up so I can see what's going on. People probably saw this yesterday. Oof, that's okay. We got to go to main screen right here. Yeah, that's okay. Here we go. This is where we want to be. So if you go over the stream, you can see everything that was happening yesterday. I broke it into multiple parts. Oh, Josh, get ready. You'll like it, Josh. So I broke this into multiple parts right here. You can see chapter 2.1, chapter 2.2, there's the speed run I did. If you remember that from yesterday, there's 2.3, there's 2.4. And if you notice, it says everything underneath it for what we were doing. Oh, and then we'll talk about that next, William. Great thing. William's leading into a really good conversation we're about to have about that. So once again, I want to point this out when you're reviewing. If you want to go back, keep utilizing these. But yeah, I think this is a great feature that YouTube has. So you can see everything going on right there, and hopefully, I think it takes about 9 minutes. Well, we'll figure out. Let's keep doing points, and we'll eventually figure out. So that's what's going on with that. Please utilize this feature. I think it's a great way to, be like, okay, I want to go back. If you don't want to figure out where it starts, you can go down to here. Also, feel free to throw likes on videos. Feel free to put comments. I do like it when you guys throw comments, especially with things that you learned. But you can click the timestamps, and it'll bring you right to the timestamp from yesterday. There's me itching my nose. I'm just going to do that. I'm going to do all this crazy things right here. That's what happens. It's a lecture for you. So, once again, there's all these features. Streamlabs might be turning on here. We'll see. Yeah, we'll see. It probably takes 5 minutes. I do not know how long it takes, and I don't understand why. Streamlabs is working. It literally started like with Sophia, and Jose didn't get it. Oh, there it goes. Streamlabs. You got to wake up. You got to get going, Streamlabs. Guess what? Space Pen is back. Why wasn't it working yesterday? I got no idea. It just wasn't there. I don't know these things. You turn on the computer, sometimes it works, sometimes it doesn't. So Space Pen is back. We're good on Space Pen. I know Woo Elizabeth says, I agree. Space Pen, we got Space Pen. So I'm going to do something crazy that's never been done before. So you guys are getting so many points and so many people are participating live. Like it's one right there. So much enthusiasm for Space Pen because you started talking about the Titanic. It just like, I don't know if it noped out or it came back because of the Titanic. One of those two things. Thank you very much, Justin. Justin, That we'll throw in a mod with that. When you buy Space Pen, you get a free mod right there. So Justin, you're now a mod, and you brought Space Pen back. We very much appreciate that, Justin. Thank you, Justin. So here's what's going on. I'm doing something crazy that I've never done before. In mini-term, it's so important to stay on top of your work. If you get a week behind in mini-term, I was going to say mini-lab. That's another program. If you get a week behind, it's very likely you'll fail or make a grade you don't want to make. So to not get a grade behind, William, amazing job. To not get a week behind, you need to watch live every day. That's a great thing. Now, if you're not watching live, if you're watching this recording, then don't worry. Some of you, people emailed me about jobs, kids. It's all right. It's all right. You can still stay on top of the work if you make a habit of it. If you're like, okay, I got to sit down, I got to go through this. Some people watch it at like 2.0 speed or 1.5 speed. It's a great way too. Sometimes I talk a little quickly, but some people are really good at staying on top of it. One thing I want to point out, though, is that the videos usually post completely between 4 through 5 p.m. I was looking at this because they take a while for to compile on YouTube or something, but you'll go to the video and you'll see it'll be 2 hours. If you ever see that the video from the morning is 2 hours, it probably wasn't 2 hours. It's probably just that the video has not completely uploaded to YouTube or synced to YouTube yet. So when you see this 2-hour video on YouTube from the morning lecture, you'll probably hear me cut off like that midway through a sentence because the whole video is not uploaded yet. I don't understand. But just understand that the full morning video usually appears between 4 to 5 p.m. at night. That's something that's a little bit out of my control. I stop office hours about 1, so it takes another 3-4 hours. So I guess you could kind of watch the first 2 hours and then reload the video. But I just don't want anyone to think like, oh, Brian only went 2 hours this morning. I know that's a huge point of confusion. During the semester, I don't think it's been much of a problem. But since we are doing longer streams now, more than 2 hours, and also, people probably need to watch the later in the day streams. It's very important. Does the mini-term final grade get calculated with the spring or final semester, or does it stand on its own? GPA-wise, it's I don't understand quite, Hannah. I'll try to be more specific, but it's kind of its own thing. It's a grade you'll get that'll go on your GPA. Does that answer the question, Hannah? Ask more specifically, and I'll try to. It'll be its own 201, Stat 201 grade. Does that make sense? And then the last thing I wanted to say, this is so key. This is where we're getting into the big bonus for the 2,000 and 3,000 earners of points. So 3,000 is going to be a little bit ridiculous, and maybe I'll give it to the top point getters if no one gets it. But I was looking at it, and I was like, I think a lot of you, it's a new, thank you so much, Mona, right there. It's its own thing, so I think you're right, and I can look into that. But member 1,000. So, and thank you guys so much. Mona, amazing job. Thank you for helping out right there. Sometimes you know these things a little better than I do. I know stats. That's what I know. So, and Kyle confirms new semester. So what we have here is 1,000 points, which I think is super obtainable. Many of you are a third the way there. You're welcome, Sarah. I'll keep trying to do that. I'll keep trying to remember. And I almost deleted them yesterday. It was like, do you want to save? And I was like, yes, I want to save. Oops. Look at that. We've got Isaac right there with 470 points. He's already halfway to this. This right here is 2 points. That is ridiculously obtainable. Ridiculously obtainable. But guess what I'm going to do? Now there's diminishing return on this. 2,000 points. This is like where you get the rounding. Now, I do want to mention something. This is a key talk because I'm dealing with grades right now. Oh my gosh, what have I done? What have I done? That bottom one is ridiculous. That bottom one is completely ridiculous. Yeah, I like that, Isaac. That's the way it is. You should get rewarded for talking. You should interact. This is what class is all about. I like that right there. Yo, this is what class is all about. So I want to point something out, though. Something huge that I am getting emails from students about lately. I've gotten like 5 or 6 emails on this. So these are the maximum way I will... Time to go. This is the maximum amount I will be increasing your grade if you get these points. This is an absolute maximum. Does this make sense? It gets a little bit scary here, though. And this is what I want to point out, is that some people have emailed me and let's say you got 1,000 points, and your grade in the class was, let's say, a 77.96. Now, I want you to tell me what your grade would be, and this is the maximum increase you get. I know this is going to sound crazy, and you're going to be like, oh, no, come on. So 3,000 is a bit ridiculous, and I might give the 3 points to maybe the top point getters. I wanted to put something higher for you guys. I think a lot of people will get, you guys are, yep. So I think a lot of people will get the 2,000. I don't know if anyone will get the 3,000. It's quite possible. You might have to stay for office hours. Don't just stay to, I mean, don't worry. I put the 2,000 there because I think more people are going to get it. That I wanted to do a little extra for you guys. But the 3,000, I was like, well, why not? Let's go crazy. So the answer is 79.96. And what would that give you with a 79.96? What would you get? And what would you be so close to? With a 79.96, what would you have? A C+. How far are you away from the next grade level? How far? Ah, you see, some people are seeing it. A lot of people are seeing it. It's a C+. I know you're 0.04 away. But this is why I call it the maximum extra credit. So this is, if you wonder why is Brian doing this right now, I'm kind of like saving myself from a few emails, because the email I would send to you about this, I wouldn't round it. I know, Isaac, because this is what I wanted to do right here with this one, is you also get the round with this. That's why I created this for mini term right here, is like you get the 2 point and the round. So you get the round up and the 2 points. So that's why I created the 2,000, which I think a lot of people are going to get. I was like looking at it and I was like, okay, we got a lot of people at 200-300 points. So let me make this additional thing where you get the 2 points and the round. So the 2 points does not include any rounding. But then let's say this person, see, don't worry. There's always, I mean, don't worry. A lot of people, this will help. Some people, it just won't bump them up. That's the thing. It's like you were close, but you didn't get it. Thank you so much, Jared. I appreciate that. Let's do a really good scenario. Oh my gosh, this person would be so happy. Let's say this person right here has an 89.6. Now, what do they have? What do they have with their 89.6 if they got 2,000 points? What do they have with their 89.6? I love that. They're right there, Isaac, straight vibing in the YouTube classroom. What would this person have? Remember, they got the 2.5 points. I think I misspoke. So they would have a 92.1. Yep, and then make sure to do, I'll let you guys still send me the extra credit email. I'll have to put all those in this weekend. Please tell me if I don't give you your 100 points, because that's a big bump. 92.1, which is an A-. 92.1, they would have an A-. So they would have an A- right here. But let's say, I know this is, you're like, no, Brian, come on. I would seriously do this. You guys are going to hate me. I have to have a cutoff somewhere. I have to. What would this be? What grade would this be now? What grade would this be? That would be a what? Oh, an A-. Did I say, wait, no. Oh, no. Wait, I think I just misspoke. Gosh, I'm sorry. Coffee's still kicking in. Oh my gosh. I gave the person the wrong grade. That's when you email me and you say, Brian, you gave me the wrong grade. I'm very sorry about that. I'm still waking up. Coffee's still kicking in. I actually broke down and had a little coffee this morning because I was like, I need it. I've got like these Starbucks double shot things, and I don't know. I had oral surgery, so I immediately I was like, I have to have one. It's 9 a.m. I broke down, had coffee for the first time in a while. So so that would be an A. But and then this right here. This right here would be an A-. That person just barely got an A-. There's always going to be a highest A-. There's always going to be a highest B+. If those grades exist. If someone has an A-, there'll be a person with a highest A-. So there'll always be the person who just barely didn't get that A. You know, maybe. But how do you have this energy without coffee? I had to have a tiny bit of oral surgery, went to Kingsport. And so then I couldn't really have, there's so many things I can't have and couldn't have, but I had these Starbucks double shot things that were just in my refrigerator, and I was like, I gotta have one. It's 9 a.m. Gotta have my something. It's almost been 2 weeks, so I was like, probably okay. I'm probably okay. probably okay. And I looked at my like sheet that's like their advice for me, and it didn't have like don't drink coffee. And I was like, did I imagine don't drink coffee? Or do I actually not need to drink coffee? And I was like, well, they didn't say it, so let me do it. You'll be fine. Thank you. I appreciate that. So if you can't tell, I'm one of those overthinker persons. So if you get a 0 on every exam and 100 on everything else, you could still get a B. I think, Mona, we kind of calculate, maybe. That's kind of scary, isn't it? I downweighted, no, let me think. No, I think you almost could. Oh, thank you, Sarah. Yeah. No, it's a 50 on every exam. But the 50 on the exam, Jared, I think you're right. The 50 on the exam, you would get a 50 because if you make 100 on all your quizzes and if you make a 0 on your exams, then your average on the exam would be a 50. And then if you got a 50 on all your exams, no, wait a minute, then you would lose 37.5 points. Yeah, you don't want to make a 0 on your exams. You would lose, this would put you, sorry, I'm doing very quick mathematics on this. You would lose 37.5% of your grade. You would get a 63, and you could still make a D in the class. So this is the crazy thing right here. If you completely failed all the exams, what did we just figure out? I'm going to throw the pen down on the ground. And then I'm just going to pick up some orange balloons and be like, oh my gosh. Is streamed up? No, that's that button. Oh my gosh. What's going on? What did we just figure out right here? What did we just figure out? What's going on? You could make a 0 on all your exams and still pass the class. You can make a 0 on all the exams and still pass the class. Now, we don't want to do that. A little off topic since we can't use jump on exam, but should we practice on? No, I won't have you do Q1 and Q3 by hand. Great question right there. Amazing question. But so if you were to do all the work, you could fail all the exams and you could get a 0. We don't want that though. We don't want to get a D. But I mean, you're basically, you've stopped yourself from failing the class by getting these hundreds. So okay. So love the balloons. Yeah. So they yeah. Okay, so we got this all right here. We're ready to go. Space Pen is back. We got to do a little more happy music for Space Pen. Complete randomness today. You got it. That's what we do. Randomness with Brian Stevens. And that's our kind of intro. We always try to make sure we know what's going on. Great questions at the start today. Let's hop back into lecture right here. So we're going to hop over into lecture. Did I make the transition? I might have made it. Okay. Can we even get credit for this class if we get a D? It depends on your major. I would not shoot for a D. So it really depends on your major. Some majors are probably not going to accept a D. So make sure, so I would not suggest being like, I'm just going to fail the exams and do all the work. So yeah, not for business. So don't shoot for the D. But I mean, if you, if getting a D is almost ensured by doing all the work, getting a C is, usually it's C+ for neuroscience. Yeah. But so who here feels like they have a pretty good opportunity to make at least a C, probably a B, and there's a good shot at an A? That's what I would want you guys to feel from all that. It's like, okay, I should be able to get a C should be pretty easy. I can probably get that B, and the A is within range for me. So once again, what are we going to do? Do all your quizzes. And I should remind everybody right now, quick reminder, we have a note-taking quiz due tonight. I will be dropping probably, I think I said 2 of the note-taking quizzes. I'll have to look at the syllabus. Don't quote me on that. Okay, I said 2, so I got to do 2 now. But yes, set up for success. That's what I like. So turn in the note-taking quiz. Who's turned in their note-taking quiz and how long did it take you? You have to write down the 3 types of variables. I'm just going to hit the microphone. You have to write the 3 types of variables down, and then you have to put down 1 for each. 3 for each, excuse me. You have to put down like quantitative, and they have to put down height, weight, GPA. Then you have to put down categorical. You have to think up 3 categorical types. You have to put up identifiers. So quantitative, categorical, identifier, and they have to put down 3 for each. Took a half minute if you've already had the notes in class. Boom. Erica's got it right there. That's what I like. I like them to be super easy. So you'll have a few more of those. I might slightly adjust them. I think I have them all posted, but yes. Are all the quizzes due on the day they are assigned on the website? You'll see the due dates on, they're on Canvas now. Please tell me if you have any confusion. I will email you back right away, and you guys got it. And we turn in a picture of what we're in our notes. Yep, you can type them or turn in a picture. Either or is fine. Like, as long as it's clear you understand the topic. I just want to make sure you're following along. So what all should we have completed by Monday? I think I have quite a few quizzes posted, and I'll look at the pacing of it. Only expect days to be extended. Don't expect me to pull things in. And don't expect things to get pushed out. The dates I have right now are all tentative dates, like the test being on Thursday. And please email me if you have any questions. Once again, don't worry, I know I asked you guys twice in a row, but I will email you back as soon as possible. If you're wondering about anything, just email me and I'll tell you right away. I think we'll see if we get to chapter 5 today, and then I'm going to consider what to do. I might put more assignments due on Monday because chapter 5 is one of the toughest chapters on this part. 3 and 4, they're going to be super easy. So 3 and 4, I know it's like, are we really going to do 3 chapters today? Really, Brian? 3 and 4 are not bad. You'll see. You'll be like, this is easy. We got this. 5 is where it gets tough again. So, with no further ado, Brian's going to do his breathe in. He's going to go, breathe in and get ready for chapter 3. I was going to do voice effects today, but my Go XLR is not on. Okay, so I'll just have to do voice effects myself. Chapter 2 was a big one. Chapter 3, much shorter, only, I can't see, 28 slides. So chapter 3 is going to be relationships between categorical variables. So what do we have right here? Chapter 3 is going to have more graphics for us to look at right here. We've got contingency tables, side-by-side pie charts, segmented bar charts, and mosaic plots. But I want to point out something to you right now. What do you really need to know? You really need to know this, and you really need to know this. These two right here, people were mentioning Cool Beans yesterday. If you ever go to Cool Beans, you will see a contingency table hanging out with its best friend, Mosaic plots. Contingency table and Mosaic plots are graphics that basically go together. So I'm just going to give you a little introduction to these right now to tell you what they are. We'll go through the main specifics about them in a moment. A contingency table shows you the counts of the bivariate relationship between two categorical variables. Let me repeat that so you can write it down. A contingency table shows you the counts of the bivariate relationship between two categorical variables. You've got 3 main things to understand right there to take in. A contingency table shows you the counts. The counts are just how many there are in each group. Of the bivariate relationship, that means there's 2 variables being displayed on the side right now. Of 2 categorical variables. The 2 categorical variables in this case, once again going back to the Titanic, are class and survival. So I'm going to repeat that one more time for you. A contingency table shows you the counts. That's the first thing you should know. Of the bivariate relationship, second thing you should know, between 2 categorical variables, all together at once. A contingency table shows you the counts between the bivariate relationship of 2 categorical variables. Now that you know what a contingency table is, it's going to be very easy to understand what a mosaic plot is. A mosaic plot, all the way down here at the end, is simply the visual display of a contingency table. So we see a segmented bar chart, not my favorite, but here's the mosaic plot. Once again, this is the Titanic data, so all it is those counts being displayed for you in a graphic. That's why they hang out together, because you can make a contingency table and a mosaic plot and display the same sort of data. Here's a contingency table of where do you sit in your gender, 2 variables, both categorical. Where do you sit being near the back, near the front, middle, all these sections right here. I know they're numbers, but it's actually like a position in the classroom. And here is the mosaic plot also visualizing it. Now watch out, these are not numbers because gender is not a quantitative variable. Gender here is categorical, and then we have where do you sit from, I think this is front, middle, back, and this is varies. And then we can see that there's a difference between the genders, where we have some people more likely to sit in the front and some people less likely to sit right here. You got it, Coleman. Mosaic plots and contingency tables go together. That's like a huge important note for us to have throughout this lecture right here. So let's go. And if you look, that's the whole lecture. I just gave you that's the cliff notes of the whole lecture. So let's go more specific and more slowly through the notes. Now that we have kind of our mindset on the big things we should be paying attention to. So what is a contingency table? Well, we were just talking about it a moment ago. A contingency table is basically a visualization that shows you the numbers between the bivariate relationships of 2 categorical variables. Now, someone would say to me, Brian, these aren't categorical. They're numbers. I can subtract these numbers. You said it, Brian. Stop getting mad at me. They say, Brian, you said to me, if we can subtract these numbers, they're real numbers. Are there keys for Mosaic plus shows? They basically go together. Like you pretty much do the same, and the contingency table will let you kind of see what's going on inside of it. That's why you should probably use both of them. When you make them in Jump, you get both the Mosaic plot and the contingency table, because the Mosaic plot shows you the visualization, like the pretty picture of it, and the contingency table shows you the numbers, so you can actually get numeric values from it. But 203, I don't know what that means. So with this, yes, Isaac, you're totally right. I thought it was like, I didn't quite understand. You are right. Isaac said it perfectly. Nice job, Isaac. He said right here that 203 people, let's take a look right here, were in first class and were alive. So perfect job right there. All of a sudden my brain went sideways. You're right. That's what that 203 means. If you were recording data, you'd be like, okay, this person was alive and they were in first class. It's almost like we're doing what with those individuals? It's almost like we're getting a count. See how I call it count data? This I'll come to use later. But this is almost a count of how many people. And so it's within a group, meaning these are categorical variables, like how many people belong to each group. The people who were first class and were alive for their category, you're right. And it's a bivariate category. It's a category based on two variables, a bivariate category. Does that make sense to everybody here when I say bivariate? Because we have first class alive, that's a bivariate category. There's two variables. You could just do one variable right here. Nice job. I like all those yeses in chat. Remember, more you interact in chat, more points you get to that 2.5. Put yes in the chat. If you're following along, when I ask questions like that, you got it. Nice job, people in the chat. So that right there is just the people who are in first class. That's a univariate relationship, one variable being displayed. But then you can go to a bivariate and say, okay, let's talk about, we're going to go here and put another highlighter. We can get all new highlighters. We're going to go to purple highlighter. So you can go like this and get like the bivariate. So the bivariate right here would be this. And when you look at this, we would call this a cell. I highly doubt you'll ever hear that term again. I mean, from me, but I mean, you might. That's why we teach it. So we teach you a lot of things that you might hear in other classes. So that's called a cell in a contingency table. It contains the count. You'll oftentimes refer to me as calling this a count, but it is a cell. It's just like, there's a lot of ways to say things. So someone might be like, the cell in the contingency table. I just mean like, what's the count for blah, 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 blah. That's the way I would phrase it if I was talking about it. But it's a bivariate relationship. So we understand what that is. There were 673 people who were in the crew who died. Sorry, crew. Not fun time right there. Microsoft Excel class. And then what do we have right here? Okay, so this is one of my favorite definitions. It's very easy to understand. So, oh yeah, cells in Microsoft Excel, you're right. So what do we have right here? How many marginal displays are there? I want you guys to answer in the chat. So this is your time to participate. How many margins are there to this? How many margins are there to this? I want you to be thinking, because you're about to hear it. If you think it, you'll be following along. So how many margins are there to this? You got it. There's two. Amazing work. There are two margins. Let's highlight one of these margins. Here's one margin. Does everyone see how that's a margin? And then here's another margin. If I would click the right thing, here's another margin. So I guess technically we wouldn't really consider, well, I guess that is a margin too. So I should highlight it. So whoops. So technically this is a margin. And also, this is a margin. I don't want anyone to think I'm highlighting like the overlap is some sort of thing. The overlap is just that they both contain that part. So when you look at the marginal display right here, you have the marginal display of survival. Here's the best definition I can give you of margin. Get ready, have your pen out, take it down. The marginal displays are the displays in the margin of the contingency table. Margin meaning the outside kind of border. The marginal displays are the displays in the margins of the contingency table. It's such a basic definition, but it's what it is. Here's the marginal display of survival. It's just the outer border of the contingency table. And guess what? If you go to the bottom outer border, well, there's the marginal display of class. I know exactly. Where you're like, what's a marginal display? Well, it's the display in the margin. And you know it's interesting. The marginal displays display how many variables at one time. The marginal displays, be careful. Each marginal display only displays what? Be careful. One, you're right. So I want someone to tell me, and I'm going to add points to them. I want someone to tell me a marginal display is basically like a this table. A marginal display, who's going to be the person who gets it? A marginal display is basically like a what table? It's a review from yesterday. A marginal display, and it'll always have the totals. Let's see who got it. You're right, Andy. Frequency, Sarah B, nice job. Amazing job. A marginal display is the display in the margins. I'm going to add points to Sarah B right here. The marginal display is the display in the margins that displays one variable. No, don't worry. Like the more you think about it and the more you look at it, hopefully the more you're like, oh, that's what it is. Yeah, it makes sense. So we got the points added in right there. Excellent, excellent work. We just put some 20 points on there. And so there we go. Let me get everything back situated. I need a third screen where I can add points and then everything will be perfect. So, does that make sense? I know you guys did great. Remember, you're still getting points for talking and being interactive. So if you're like, man, I wasn't quick enough. Even if you see it and type it in, you'll remember it more frequently. Haha, using the words right there. But the marginal displays, when you look at it, can anyone tell me, let's go to a completely different one. What two marginal displays would you have for this frequency table? What would be a marginal display for this frequency table right here? Oh, excuse me, for this contingency table. Sorry. Frequency table is one variable. Contingency table is two variables. Like there's two variables contingent on each other. So what would be gender is one of them. Nice job, Justin, right there. Gender is one of the marginal displays, and where they sit, Claire, you're right, is the other marginal display. Because you would have a marginal display of where people sit. There's the display in the margins, and that relates to where do people sit. And then the other marginal display is the gender display right here. So that's another marginal display. Now, one thing I want to point out right here is if you actually look at the associated Mosaic plot, you can see the marginal display down here. Do you see how gender is almost a 50-50 split? So gender right here is a 50-50 split with a little more females than males. And females are 0 right there. So when you look at this, there's a little bit more females than there are to males. It's very hard to see. Maybe that makes it a little bit clearer. But that's the marginal display. Here is the marginal display for where people sit. So this is, I guess we could say, marginal display 1, and this is marginal display 2. Writing on the side is always the hardest because my mic's over there. But there's two marginal displays right there, like these are the margins here. Now, I know it does kind of flip them. I always find that confusing that it looks like this, and then it flips it like that. It's just the way graphics do. But yes, so we see the same sort of concepts, and that's why these two graphics are linked. That the contingency table is just the numbers, and then the Mosaic plot is the visualization of those numbers. That's why I'm trying to pair these two in your mind, that when you see the contingency table, you're seeing the same thing in the Mosaic plot, but a visualization of the numbers you just saw. So let's go back. There we go. Here we are with the marginal displays. So the marginal displays are just the displays in the margin. We understand what's going on right there. Now we're going to get to the confusing topic. There's only really one confusing topic today, or at least in this first lecture. The confusing thing for people a lot of times is the conditional display. I'm going to slow our minds down a little bit right here. Sorry, Kyle. We've got the conditional display right here. And the conditional display is going to be when you say something like, given this, what does this look like? Or what is the probability of this given this? Given is a keyword. I like to use given. Now, sometimes we mix up the wording a little bit. Conditional, you got it, Coleman. So it's like, given this condition, what's the probability of this? Now, let's just kind of think in our mind right here. If you look at the Titanic data, the people who were the most likely if you look at the Titanic data, the group with the most people who lived was the what group? If you look at the Titanic data, the group with the most people who lived was the what group? If you look at the Titanic data, no one said it yet. Crew, Devin, you're right. It is the crew. The crew had the most people who lived. You can compare them to first class. And the crew. So, okay, who wants? I've got 2 tickets for the Titanic. Okay, let's take a vote. We got to go back to voting right here. So, be serious. I say that, and then no one's going to be serious. Let's go to polls. Okay, you have just time traveled. Let's go here. Let's put this in. You have just time traveled. Would you like a crew or first class ticket? So option 1 is first class. And then option 2 is crew. You'll see it appear in the chat. Now, be serious. Should give extra card or something. So the more I say be serious, the less likely it is that's going to happen. So, okay, so we got the votes in. Okay, so would you want a crew or first class ticket? Would you want a crew or first class ticket? We're getting a lot of votes in. But remember, see, I'm trying to trick you. But remember, there were more people who lived in the crew. Everyone's voting first class. You guys are super serious. That's awesome. I say that. Oh, man. The more I say be serious. I think it takes a second for the votes to register. I'm going to wait till the votes change. There we go. Okay, let's close the poll. Some people might be hanging out with me in the crew. So there we go. Going down with the ship, Ben says. I like that right there. So 92%. And remember, if I'm doing a poll or something, sometimes I can't see. So if you did ask a question, I missed it. Remember, tag me in those questions. I don't know if anyone saw that. I don't know if I saw it either. The musicians, we play until the ship sinks. Weren't they doing that? Yeah, exactly. And there's a lot to do on the Titanic with gender, age, and class. Basically, you want to be a first class female baby. If you're a first class female baby, you made it off the Titanic. If you're like a 90-year-old man in crew, then you're not gonna make it off the Titanic. Your likelihood's a lot lower. There's like a multivariate relationship. You're just trying to trick us. I like that right there. So the conditional display right here. The conditional display. Oh no, so sorry to hear that. It's so cool that we have the Titanic. I'm a crew member who drives a lifeboat. Ooh, you are good. You're good to go. Like I've got life. I know how to do the lifeboats. Let's look at the conditional display right here. I'm kind of doing my own conditional displays. One thing I want you to notice right here is that a conditional display would do the following. Here's how you say a conditional display. I've got two different conditional displays on the screen right now. Let's mark them. We've got conditional display number 1 and conditional display number 2. So now, even though there are more people in the crew who survived, I want somebody to tell me the probability of somebody surviving in the crew. I'm going to throw bonus points. I'm trying to figure it out in my head right now. Who's got it first? Who's got the first person to tell me? Be watching the chat, and you can solve it out for a probability, and then let's see who gets it. What is the probability that somebody survives in the crew? I think Justin, you got it. So Justin, first person right there. Justin, nice job. I think, there we go. Justin, let me add the points to you. So let's go in. I got to find a quicker way to do these points, but nice job. Be working it, be taking these notes while I add in points to somebody. Great, great work. I can add points to all viewers. I think it might be not correct, though. So Justin, amazing work. You got those points right there. So we have that. And now I want the probability. Someone's already got it ready to go. I want the probability. Let's put this here. I want the probability that someone survived in the first class. So it's 23. Please tell me if an answer is wrong. I'm looking at it and seeing how accurate it looks. Okay, who got it? Wow, Isaac, I think, was first. Everyone's ready for that one. So what is it? Isaac, and then I think Skylar gave the more exact. So let me copy the name right here. Nice job. Be working these down. Be writing them down as I'm doing this work right here. I might ask you guys to email me. You know what I'm going to do? Okay, here's what I'm going to do. Isaac and Skylar, you have to email me and say, hey, Brian, I got those 20 points. So this is what I'm going to do. So that this is a new thing I'm doing right now. I'm going to try to give away like a few points during class where we do this. And I've already given away a lot today. But so we utilize class time as best as possible. Because once again, the Streamlabs thing is new and I want to do it as like efficiently as possible. Email me and you have to say, Brian, I got 20 points. These are worth 20 points when I do this. And then say, you know, I answered the thing here. I'll make sure it's very clear who gets those points. I'm only going to give away like 4 or 5 of them during class. Please email me as soon as possible, like when class ends, and be like Stats1 Mini. Once again, make sure to use the right titles. Makes it very easy for me to see. Then I'll add in those points for you. You got it. So I'll probably give away more later on, but I'll try to give away maybe 1 or 2 of those an hour. So remember, keep getting those points, keep watching live, keep getting as many points as you can. So we got this, just so it makes it nice and easier flow of class. So that's what we'll do right here. Okay. So we got the answer of, what was the probability? 62.4. And please tell me if any answer is wrong, especially like, Brian, wait a minute. And then did anyone put in the chat how we got this? It was, the answer for this one was 203 divided by 325. Does that make sense right there? So, and remember, email me about those. Remember right there. Remember, divide it by the total. It's like, great job. No, don't worry, you got it. Like when you get something wrong in chat, that's awesome because you're like, wait a minute, that's that one that I did incorrectly. Like, yes, I remember it now. Does anyone remember a question they raised their hand in class and got wrong? Do you remember answering something wrong in class? And then you kind of remember what the right answer is. That's usually what happens. If you answer something wrong, you're like, oh, wait, that's that thing. Oh, I remember. That's they told me this. Yes. Getting things wrong is awesome. I know that sounds crazy. Many times, exactly. You only learn by like raising your hand and being wrong. So don't worry. If you say something wrong, you've done more learning than the person who already knows. And it's good to answer if you know, but you need to answer if you're wrong, which is awesome. So I really appreciate that. It's just don't worry about being wrong. It doesn't matter. I mean, it's better to raise your hand and be wrong and then to think it and not say it, because then you don't know you're wrong. So here's the conditional displays. We have the conditional given somebody is in the crew, the probability they survived, which we calculated earlier. I think we did a more exact decimal calculation on this. The answer would be 212. Do we get points for being I should do something like that. That'd be really cool. Maybe one of these days I'll give someone points for being wrong. I mean, good way to do it. So yeah, let's do that. Let's do that. Claire, you just got points for being wrong. Claire is our archetype. She's showing us. Claire, you got 20 points right there. Great job, Claire. We had set this up beforehand. I was like, Claire, just do it. So yes, Claire gets points for that. You got it. Thank you, Keaton, right there. So I'm gonna turn down the points a little bit. I don't know. I'm gonna try to keep track of all the names I get points to. And you can only, let's do this to make sure more people get points. You can only get 20 points once during class. That's a rule too. So each class you can get 20 points, but make sure to email me those points if you got the 20 points during class, and I'll put them into your Streamlabs. So good stuff right there. And I'll try to maybe give away like 5-10 of these, because that's we'll try to make sure people watching live and getting some cool points right here. Awesome stuff. We see right here another conditional display. Can anyone tell me the conditional right here? The conditional that somebody what? This is the conditional. I like that, Claire. This is the conditional given what? What would you say? Given somebody was what? The probability of what? What is the conditional right here? It says at the top. Conditional that they live. Nice job right there. The conditional that they survived. So the conditional that they survived right here. So what is the probability of being in first class given you survive? Given the class probability of survival. Kyle, amazing job. Great note right there, Kyle. Given this thing, you have to say it as a sentence, which Kyle did. Given they were alive, what is the probability of a certain class? So this is conditional on living, and this is conditional on dying. So you can see the different probabilities associated given somebody died. And remember, this is how we talk about conditional. It's like, given this condition, what are the probabilities of this? So if you're looking at a good definition of conditional distribution, conditional distributions set, so wait, the crew had a better chance. Nope, the crew had a worse chance. Let's go way back to where we marked that. Oh, did I delete it? Here it is. The crew had a 23.9% chance of surviving, and first class had a 62.4% chance. And does everyone see how when I do these conditional distributions, I go within each of these? That's why I've got them highlighted. These are two separate conditional distributions. This is conditional distribution 1. This is conditional distribution 2. And as Mona points out, amazing job, Mona, right there. So I'm just going to do it. I'm going to do it one more time. Mona, you get 20 points. Thank you so much. And you put a comment on the video last night, which I really super appreciate. So Mona gets 20 points right there. I love it when you guys explain things to each other when you're in the chat, because sometimes I can't get to every question really quickly. But when you guys explain it, that really helps too. So Mona, amazing work. So when I call your name out, you got those points. Remember to email me, especially each day as it happens, you got those points. So we have here, right, given someone was in the crew, the probability they survived was 23.9%, doing the mathematics of 212 over 885. And then given that someone was in first class, the probability that they were alive was 62.4%. So you were more likely to be alive in first class, but there's the paradoxical thing here that more crew survived. But as Mona pointed out, there were more crew, so that's probably why more crew survived. We can't, I mean, just kind of makes logical sense. There was a lower probability, but there was a lot more of them. No, don't worry. That's right. So, no, good job right there. Don't worry. Don't worry about it. Yeah, and then I think it says right here, did it say something different? It said 28.9% of first class. Let's double check, unless we misread. Here, we're just going to do the math real quick, because First class would be 203 divided by 325, so it's 62.46, which rounds to 62.5. It's on the other slide. Can you tell me the slide number, which are a little... Let me see if it's... I want to see if there's an error on the slide. Oh, okay, good, great. No, good question right here. This is of the alive... this is given someone was alive, not given someone was in first class. Does this make sense right here? Great question. I like that we're kind of saying like what's going on right here. This is not, look at the way this is done, because the way I'm doing this right here, I'll draw on this slide. Good, Jared. I'm throwing Jared 20 points because other people were wondering that. The way I did it here is given someone was in first class, I'm gonna drop the pen multiple times today. Given someone was in first class, that slide says given someone was alive. Does that make sense right there? The way we did it just previously was given someone was in first class, what's the probability they survive? That's conditional on being in first class. The slide you just saw says given someone was alive, what's the probability they are in first class? So you see how this is given they are alive, this is given they are in first class. Does that make sense? I like that right there. Jared, great that Jared, you earned those 20 points because a lot of people are saying like, oh, I get it now. And that's what we like to see. Please ask questions when it doesn't make sense. And I'll try to make sure. I think one of the hardest things, I'm going to go back to Sarah's question here. One of the hardest things sometimes when you teach topics is, I've taught this topic for 10 years now. Oh God. So these things, it's like if someone asked you, now don't worry. Once again, I'm really bad at a lot of topics like grammar and all that stuff. If someone asked me, like, how do you do 2 + 2? I'd be like, is it 2 + 2? So it's hard for me to see sometimes where people don't understand the topics. I've often said it's easier to teach something you kind of learn more recently because you can see how it's harder to learn or where the gaps in knowledge are. So sometimes when a question is asked, my brain's just like, well, that's the way it is. So it's harder for me sometimes to remember how to learn it. And I fear sometimes I'm like, well, the better I know it, then the more distant I am away from having to learn it and understanding how people have to learn it. So I fear that sometimes. I'm like, well, isn't it just this? But Jared, you did a great job at pointing out a knowledge gap, which I really like. So I remember you said this, but I don't think it applied to me. I just downloaded the PowerPoints before oh yeah. So no, great question. Sarah, and I need to change these, or excuse me, that was Samantha, I believe. You need to go up here to the close. Let me show this again. We're gonna hop over to the other screen. At the very top, sorry that the slides are this way, there will be a close master on it. So make sure you go to the close master. Sorry, they're set up in the master view. You just go to the close master and it'll make them disappear. Sorry about that. I need to re-upload them. I'll try to get on that this weekend, but there's a close master button on them. Okay. You got to see behind the scenes right there. So I'm just showing you a PowerPoint screen. Okay, so now we understand what a contingent, perfect, got it, you're welcome, great question right there. Why not, Samantha? 20 points. I'm just going crazy on these points. It's a Friday. You know what we should do? Friday's Crazy Points Day. You heard it here. You heard it now. I know Fridays are going to be lower attendance day. Friday's Crazy Points Day. What was your good definition for a conditional display? A conditional display sets a condition for one variable and lets us look at the distribution of the other variable inside of it. A conditional display lets us look at, sets a condition for one variable, like given somebody is in the crew. So this is given somebody is in the crew, sets a condition for one variable, and lets us look at the distribution of the other variable inside of it. Does that make sense? A conditional display sets a condition on one of the variables, and then lets us look at the the other variable inside of it. So yes, and I'll make the Fridays get like even crazier. Maybe the last Friday we'll just give points to everybody. Who knows? So let me make Tyler a mod here. Tyler, you are now a mod. Okay, so. Okay, we see what's going on. Please keep asking for things you want. Could you give an example? Yeah. Like right here, we've got, let's just go to a totally different one. I know I'm hopping through slides, but I'm just trying to show you different examples. A conditional display right here. So I want someone in the chat. I want chat to give a lot of examples. I'm going to give you one, but I want you to imagine this. You ready? I'm going to say, given somebody sat near the back, what is the distribution of males and females? Do you see how I'm setting the conditional display of near the back? You could say position 1, 2, or 3, or 4. I know the other positions aren't labeled, but the conditional display I just told you is this one. And so that is the conditional display I just told you. Nice job, Nayland. So the conditional display I just said, I'm going to repeat it, and I'm going to read off other ones. I'm going to show them. So the conditional display was, given somebody sat near the back, what is the distribution of males and females? So it sets one of them, given that the person sits in the front, what is the probability they're female? So I think this is front right here, given somebody sits in the front. And then you kind of, be very clear, you kind of talk about the distribution completely of the other one. So it's like, what is the probability of male/female? Like, what is the other variable? So you can still look at, because that would be a cell. If we just narrow it down to one thing, that would be a cell inside there. Given someone is female, what is the distribution of where they sit? Nice job, Kate. So given somebody is female, that would be this one. Kate just read off this one right here. Given someone is female, what is the probability of where they sit? So, and then what Isaac said, just to be very specific, is like, given somebody sits at the front, what is the probability of them being female? That kind of narrows it down to a cell right there. And you got it, Mona, you're right. It's kind of like a dependent variable, like saying, what is the relationship? And so I want to draw this back to the Mosaic plot again, because when you look at this, your conditional distribution is easily seen right here. This is the conditional distribution of being female. Does everyone see here that female is 0? So everybody right here has a 0. So it narrows down to it'll narrow down to a condition. It narrows down to a condition, Thomas. So if you notice, this is the condition of being female. Given somebody is female, thank you very much, Zulon. So given somebody is female, and now look at the Mosaic plot. Everyone I have highlighted right here is what? I want to see in the chat, get those points, be interacting. Everybody in this Mosaic plot is what? 0 means female. Everybody in this Mosaic plot is what? Everybody in this, you got it, Kate. Nice job. Everybody here is female, just like everybody here is female. So do you see how these two are very connected? That when you look at this right here, this conditional distribution in the contingency table is connected to this conditional distribution in the Mosaic plot. That's why these two hang out at Cool Beans. They're like, hey, we're identical. Not that you'd be identical to your friends, but they're like, we do the same thing. We like the same things. We show the same data. One of us shows the numbers and one of us shows the graphical visualizations of it. So you can see right here the amounts. It's very easy to see that the smallest amount would be females who have position number 4, which I think is varies. So this right here represents this, and we go over here and we can mark this. That's the smallest amount. It's this right here. So if you notice where I've highlighted, it's the same thing. That very small 2, which is the smallest area on here, is the same thing I'm highlighting. So try to connect the similarities between these graphics, and I'm trying to just ingrain it in your head that Mosaic plots and contingency tables do the same thing. Everything you're learning about the contingency table right now, boom, Mosaic plot, same thing. So when we talk about those marginal displays, marginal display for gender, marginal display for where someone sits, marginal display for, we got our race, marginal display for gender, marginal display for where someone sits. If you look, it does flip-flop the sides. I'm always like, why does it do that? But still, you just got the 2 marginal displays, and where are they at? The marginal displays, type it in the chat, are where on these? The marginal displays are where? The Mosaic is like, you're annoying. So I should use that example. I like that, Claire, right there. It's in the margins. That's where the marginal display. And then the conditional display. And I will say this, you can really only look at, you can flip-flop them. I'll talk about that in a moment. But I love that the pens are back to normal. I'm so used to these. The conditional displays are within setting a condition. So you have to go within it, and you have to look at like everyone who is female. So you're saying the condition given someone is female. I like to use the word given when I talk about conditional displays. It's just my best way of talking about them, because you're just setting one of the variables to something. You're saying given someone is female, what is the distribution of where they sit? And there you go. It's being displayed in the contingency table, and it's being displayed in the Mosaic plot. So excellent stuff right there. I think we've kind of covered the whole lecture. So we've talked about conditional displays, and now we get to displaying contingency tables. So I'm going to mention a few things right here. Here's some super quick notes. And you got it, Hannah. Oh, and Hannah, we're going to mention something big right here. Hannah, you get 20 points. You reminded me something. After this lecture, if I don't show you a video real quick, tell me. And you still get the 20 points. But remind me, Hannah, you're going to be my reminder person to be like, Brian, you said you're going to show us a video thing. I'm like, oh, yeah, DDD. So here's how you do it in Jump, but I've got some cooler stuff. Because I know, like, I always get confused when people put instructions like this. I'm like, what do you want me to do? What do I do? Here's the contingency table in Jump with options. You got it. Thank you, Hannah. And here is a thing. These are side-by-side pie charts. I don't like them. It's just two pie charts. You get a pie chart for alive. You get a pie chart for dead. Here's your note on this slide. You ready to take the note? Side-by-side pie charts display bivariate categorical data. So side-by-side pie charts display bivariate categorical data. That's the biggest note you need. I'm not a pie chart guy. Not down with the pie charts. William, amazing job. So side-by-side pie charts display bivariate categorical data because you've got alive, you've got survival, and you've got class someone was in. Survival and class are being displayed here, which are both categorical. Side-by-side pie charts display bivariate categorical data. We've got a big concept. This is our last big concept for these notes, is that our whole goal with this, and I think it was Zulan was pointing it out earlier, is to see if two things are associated. Now, I want to point out some important wording, which actually Stat 201 was just covering during the semester, that when we look at these things, the goal is to see if there's an association between the two variables. And what do I mean by association? We want to see if they are not independent. The side-by-side would never show, not in this case, Claire, not in this case, only categorical. Pie charts are categorical, and then when we do two pie charts, it's two, like, you can see it's broken apart. We have one pie chart for the alive and one pie chart for the dead. Alive and dead are categorical, so that's categorical, and then all these things inside of here are categories. So side-by-side pie charts are two pie charts based on the different categories for each thing. So it's two categorical variables. So that's the key thing. They're both categorical. Nice job. Great clarifying question. I really appreciate it because I bet you other people are wondering it too. And if you notice, I want you to notice the dead were much more disproportionately. You can see it here. You can see the bivariate relationship. The dead were more disproportionately who? The dead were more disproportionately who? Which would tell you maybe that whether you were dead or alive depended on something, as in they're not independent. You guys got it. Nice interaction in the chat. You can see that the crew is more disproportionately higher, and things like first class have a much smaller slice of the pie. I mean, they're much bigger for alive. So you can see this disproportionate nature telling you that there's probably an association. Now, these two are synonymous words. This is probably the last big thing you need to know, is that association and not independent are basically the same thing. To say something is associated, like let's say this, your grade, Mona's right, your grade is associated with your quizzes. Does that make sense? Your grade in this class is associated with your online quizzes, which would mean your grade in this class, we could say, is dependent on your online quizzes. And dependent is the same thing as not independent, because something is either not independent or it is independent. They're synonyms. Basically, amazing job, Kyle. If you didn't get the 20 points, Kyle, you earned it right there. I like when you guys are like, they're the same word, basically. We're just trying to say the same thing, but differently. So you got it, Kate. Nice job right there. Associate equals not independent, which is the same thing as dependent. I know I'm saying the same thing like 3 times, but this is, like, I want you guys to know they're all the same thing. And you should know this because I don't know how somebody in your discipline is going to talk. They might say these two things are dependent, which means that they're associated, which means that they're not independent. They're all synonymous words. And let's put this down below. Let's put dependent. They're all basically the same thing. They're associated. They depend on each other. Thus, they're not independent. Like that right there. Making sense. Getting those points by just telling me it makes sense. Yes. And when it doesn't make sense, be like, doesn't make sense. And then I'll be like, okay, we have to teach this a different way. Okay. Another graphic I really don't care for. Segmented or stacked bar charts. Sometimes these are called stacked bar charts. Woo! Cool. Stacked bar charts. Fun stuff. Yay. Fun. Stacked bar charts are just like the side-by-side pie charts. They display bivariate categorical data. And if you can't tell, this whole lecture is about bivariate categorical data. just so you can remember, you get this first slide at the start right here, which shows you all of these. And once again, I'm going to erase these X's after I put them here. Obviously, those display categorical data, bivariate categorical, but I just don't care for those because all you need are your best friends, contingency tables, and mosaic plots. They're really, there's not like the one way to display stuff, but I mean, that's kind of the best ways, but there's other ways. And we put them in here because we don't know what you'll see in the future, and it's important to know these things. I would just say these are the best ways to display things. It's why the lecture mainly focuses on them. It's just like, hey, you could see a side-by-side pie chart. There's one slide on that. Hey, you could see a stacked or segmented bar chart. Should we still take notes? I just won't emphasize them much on the test. It's just this part of the test could be like 2 points tops. If you think about what we focused on, we focused a lot on the marginal display, the reading of the contingency table, and the association between a mosaic plot and a contingency table, and you should know how to read a mosaic plot. So this is very small points of the test, if anything. That'd be a not important part. It's like someone could probably forget those things and still get an A on the test. I wouldn't suggest it, but you just have to know they exist. That's all you need to know. Like one flashcard being like side-by-side pie charts, and then on the other side, display bivariate categorical data. It's about the only node. Stacked bar charts. Other side of the note card. Display bivariate categorical data. That's already forgotten. Like right there. So that's about the only things you need to know. And they can be called stacked or segmented. I just like to give you as much information as I can. But once again, you're really only responsible for what's in the notes. I don't know. Some people, depends on what your discipline calls them. So I just always like to give a little bit extra. Here's how to make it in jump. Cool. We're going to show that extra thing in a second right here. And once again, this is where it gets serious. I got to get serious for 10 more seconds. So what we have right here is the mosaic plot showing us, we can easily see the conditional distribution of people being alive. So there's the conditional distribution of someone being alive. Here's the conditional distribution of somebody dying on the Titanic. A little hard to see, but I'm highlighting this right here. It's kind of like modern art. I agree. And I love it. I love mosaic plots because it's very easy to see that the dead had a lot more what in it. What can you see once again right here really easily? That the dead, that does not show up. The dead had way more what in it? Black highlighter. That's not good. There's no such thing as a black highlighter. It's like a white highlighter, just like erases everything. Either one is not going to work. So, yep. The dead had way more crew in it. So, it's like I had to see what that did. So, right there, the crew had way more. The dead had way more crew in it. Given somebody died, they were way more likely to be in the crew. Given somebody was alive, they were way more likely to be in the first class. The probability of first class was higher. Now, I know I'm highlighting a cell, but I'm kind of pointing out within this that the alive had a disproportionate amount. And you could compare them. You can see the disproportionate, if you can kind of see what I'm highlighting there. I know it's yellow on yellow. Is the reason that the bar width is different? Yes. This is Kyle. I'm giving you the 20 points for asking. The bar widths at the bottom right here represent the what. So, and I see another question, but Kyle gets 20 points for asking that, and then someone's going to get 20 points for answering Kyle. So basically, my response is yes, basically, very. Candy, I'm 20 points too. Kind of, who's going to say what this is? This is I'm off the screen. I'm going to look for a very specific answer in the chat. It is kind of more people. You guys are kind of getting it. This is giving us the what display. It does show the disproportionate amount. I'm going to look for a very specific answer in the chat. That's going to be a review answer. Haven't seen it yet. I'll say your name when you get it. Hopefully I didn't miss it. Kind of. Yes, Erica got it. Erica got it right there. Erica said that's the marginal display. So you got it. Nice job, Erica, right there. Erica got the 20 points. That is the marginal display right there. It's the marginal distribution, which is identical to, I know we're going way back, but this display right here in the margins, the 711 versus 1490 is the same thing right here. So we know that there's 711 right here, and there's 1490. That's a horrible 4. Does that make sense? Now, it doesn't show us the numbers, because if we want the numbers, we have to go back to here. So it's the marginal display showing us that there were more people dead than there were alive. Yeah, exactly. Because the width of this, ooh, that has been on the test. The width of these tell you the marginal display. Now, that's not a bivariate relationship. Remember, this is just a univariate because we're only analyzing. Why do I say univariate? Because this is one variable right here. The marginal displays are just univariate displays telling you that there were more people dead on the Titanic than there were alive. More people died from the Titanic than there were alive. But then when you go inside of here, you can look to see if the two variables have some sort of dependency. The conditional displays look at dependencies. The stack bar charts in front of me. Yeah, it doesn't. It doesn't provide the information as well because you don't get the marginal displays. I would not like this as a test question, but it's like when you go, so weird. I was trying to use this one. When you go over to the Mosaic plot, you get the conditional displays because the widths on here are not marginal displays. I think I just misspoke. When you go over to the Mosaic plot, you get the marginal displays. You can see the conditional and the stacked. I don't like stacked bar charts just because they're not as good as Mosaic plots. You get a lot more with the Mosaic plots. Great stuff. And that's, I'm going to see if there's any other big things. You can flip your X and your Y. Now you can see conditional. So what is Brian highlighting right here? This is the condition that somebody is what? We'll put 1 and 2 right here. Who's going to be the first person to get 20 points on this? I'm just going crazy with the points today. Friday's crazy points day. Remember that. Not that Monday shouldn't be awesome. I don't know. We got to only do one day. Friday's crazy point day. We should do a thing like each day. Each day is unique. Be careful. Let's see here. Let me see whose answer is the first answer that's like spot on. I think Thomas. Thomas simply said crew. Thomas is right by simply saying crew. And that was the first one I highlighted right there. So, and then I think the next person who said crew in first was Justin. I think I've given Justin points today, right? So I'm going to go ahead and give Jose points too. Because Jose said crew in first. He was the second person to say crew in first. He's right. So this right here is the condition that somebody is in crew. And this is the condition that someone is in first class. Remember, you can only get the 20 points once in a class, so you can't get like 100 points a class with my extra points. Remember to email me those extra points, so that way I can give out more of them and not have to go between screens. If I had a third screen, if I had a TA, and every time I gave points, that'd be awesome. I do have a TA. Maybe I could start doing that. There we go. So what's the main takeaway from this slide? You can flip the X and the Y on the Mosaic plot. It'll still display the same thing. So you can switch the X and the Y. That's all you have to learn on this slide is that you can just change it. The math will still be the same. Like it won't change the relationship between the variables. It will just display it differently. So flipping your X and Y does not change the relationship between the two variables. It just changes the way we display them on the Mosaic because the table would still calculate all the same. It's just going to make a different Mosaic. It's all right. And that's got it. It's just another example right here with we can see. And I think I have one more thing I want to say. It really depends. Great question right there, Cooper. Cooper, 20 points to Cooper asking an amazing question. I need to turn down these points. Why not? It's first Friday. Let's just keep going crazy. So Mary, you only get it once though. So what you notice right here is that if somebody wanted to look at the class someone was in and whether or not people survived, you would simply go right here and look at crew and then look at the probability somebody survived. So if they wanted to see within each class, what is the probability of survival? But then over here, if someone wanted to look at what was the class within surviving or not surviving, it just depends on how you want to ask it. So it just depends. Like, do we want to say, given someone was in a certain class, what's the probability they survived? Or given somebody survived, which I've highlighted right now, what's the probability they were a certain class? It just changes the given. So it changes the X and the Y relationship. So it's a little bit confusing right there, I understand. And then the last thing I want to point out right here, let me do a quick example. We're going to do a speed run right now of whether or not two things are independent or dependent. So here we go. Get ready for a Stat 201 speed run. Let's do it. Did speed run? Oh, that's not a speed run button. Get ready for a Stat 201 speed run. Here we go. Oh no. Okay, so we got to do it the fun way. We got to get the cool guy. Stat 201 speed run time with Mega Man. Here we go. Check out your favorite Mega Man. I like the one doing that. I've got some other graphics. I'll use them eventually. You got to zoom. You got it. Let's fix our clock here a little bit. I accidentally sometimes grab it and then I move it outside the box just a little bit. Let's go. You guys got this. Okay, so this is a speed run on whether or not two things are independent or dependent. So be interacting a little bit in the chat during this because I'm going to tell you how to understand whether two things are independent or dependent, which is our last big thing to learn for this lecture. So here we go. Both a mosaic plot and a contingency table display bivariate categorical data. And what do I mean by that? Well, let's take two variables, for example. You could have whether you pass or fail a class and whether you took version A or B of a test. So this right here is a what. I want to start seeing it in the chat. This right here is a what. What is Brian drawing? We've got pass right here and we've got fail. Let's add some colors while people are thinking this over. We need to get a red pen. That's red enough. And we need to get a blue pen. Blue's nice and happy. So we've got here pass. And we've got here also, we've got fail, the red pen. That's not good. Okay, so I want you to think about this for a moment. It is a mosaic plot. You're right. And what do we notice right here? Passing and failing is categorical, and version A and version B is categorical because it's the people who took version A and version B. It's the people who passed and failed. Inside of this, we see a cell. These are the individuals who took version B and failed. We see a marginal display that looks like about half the class took version A and version B. And to be specific, we could also have a marginal display. I'm going to draw it on the side it's usually on. Usually, I'm going to have to do it really tiny. This is slowing down the speed run. But usually there's a little bar over here, which shows you the marginal display of passing and failing. And so it's going to look something like this. This is a very quick artistic drawing of a mosaic plot. So it looks like a little bit over half the class passed, and about half the class took version A and version B. We've got our marginal displays over here in the margin, and we've got down here our marginal display of version of test, marginal display of pass-fail, marginal display of version of test, given someone took version A, given someone took version B. So this is where you got to interact. You got to say, wait a minute, given someone took version A, would you guys like to take version A or version B? Because given someone took version A, the probability of what looks to be water. Would you rather take version A? There we go. I see in the chat. I hope we get version A. You're right. Because version A has a much higher probability of passing. Version A, you're probably going to get the A. You're probably going to pass the class. Now let's do a different example right here. We'll do a sad example. Oh no, sad example time. You ready? We hate sad examples, but let's do it. The sad example time is going to be when we draw it out like this right here. Oh no. Abandon hope. Oh no. And interestingly enough, so let's see what's going on here. People are already noticing in the chat. What do you notice down here about this? What do you notice about this one? What do you notice? That would be right there. Let's see what people are saying. Let's see what people are saying. In this one, your grade would be completely independent. We're at the halfway mark. Your grade would be completely independent of which test. Does that make sense? In the first one, your grade would depend or be associated with the test you took. In the second one, there is no association. Absolutely no association. I'm going to put, those are basically perfectly equal, but there's no association. And we would say association, more on correlation later. That's too bivariate quantitative, which we're not doing yet. But, which is a common confusion. That's why we use the word associated right here, because associated means that the two variables, in this instance, the test you took is associated with your grade. And then over here, we notice that the test you take is not associated, which is the same thing as saying they're independent. Now, I want to point out something very specific right here, and this is the last part. So we're in the bonus. We got the main part of the speedrun done in under 4 minutes. Now, people often say to me, well, how big do these gaps need to be? So how big do the gaps need to be? Well, let's kind of draw a few right here. So this right here is a super strong association. And then let's draw kind of a weaker one. Let's draw a barely existent one. And this would be barely existing. And this right here would be totally non-existent. I'll draw it completely flat. So just so we can do this last thing right here, and you can see, the bigger the gap, the stronger the association. The bigger the gap. And what am I talking about the gap? I'll make that very clear in a second. But the bigger the gap, the stronger the association. So this right here is strong, and this right here is weak. So you can see it go from strong to weak. Let's do a green pen. Green pen, there we go. So this is strong to weak right here. So the bigger the gap, the stronger the association, because there's a bigger difference between the conditional distributions. So you can see there's a stronger association between what you take as a test and your grade when the gap is bigger. So how do you know if the two variables are associated? It's actually that the conditional distributions have a bigger difference. So the bigger difference in the conditional distributions indicate a stronger relationship, where we see over here that there's no difference. And I do want to point this out. Someone might say here that there's a very weak association. Someone might say here that there's a moderate. This one would say that there's a strong association. And this would actually pretty much be non-existent because there's no differences at all. So the bigger the gap, the stronger the association. We do have a way to quantify this later on, but that is the main key to knowing whether or not two variables are independent or dependent. It's pretty much the difference in their conditional distributions. And that's got the speed run. Do you guys feel like you understand the mosaic plots pretty well and how they display the variables and what's going on right here? I hope so. Makes sense. I like this. Great job. We did an amazing job of this lecture. Like I said, this was an easier one. So are the ones in the middle just normal or no difference? These ones right here, like this is a moderate and this is a weak moderate, I would say. Like if I had to talk about those, I'd say like the first one I highlighted has a moderate association. And the second one right here has a, I might say moderate weak or weak. That's kind of where it's just words at this point. But there is a difference. I don't know if it's statistically significant. I'm not going to get into that right now. But, and yeah, thank you so much. I'm glad the speedruns help. It's kind of a fun thing. Thank you so much. I love all the ASCII art right there. Would you consider weak, moderate, independent? Really great question. That gets into p-values, and we will be doing p-values later. So not today, later. This is actually one of the final topics. Why not? Let's show it. Let's explain it. Okay, so this is the bonus. This is like the bonus. All right, behind the scenes. What if the widths are super different? Great question. So here, I'll show you guys inside of Jump, which kind of leads into the other topic. Okay, so let's open up Jump. Jump 15 is now on my computer. Let's go here, and I'm going to show you guys how to make the graphics. And then remember, I think Kate's going to remind me. Oh, no, don't worry. I'll tell you how to understand p-values a lot easier. So I'm not going to go too specific on them today. Let's do the same thing we just did with right here with test version. And then we have pass-fail. My goal with p-values is that people completely understand them. And I know that sounds crazy, but we will go over p-values a good bit to where if you're in another class and someone mentions p-values, you'll hopefully be able to explain it to them. Microlab flashbacks. And so we've got test version A, B, B. Say, why, Brian, did you put two of them? Because we have pass, fail, as in these are the people who took A and passed. Let's say there's 90 people, 10 people, 90 people, 10 people. Can anyone see here? I want you to just think about this before I make the graphic. Look at this. Do you think these two will come out independent or dependent? Look at the people who took A, which I've now highlighted the conditional A, and here's the conditional B. You're right. There's no association here because there's 90 and 90. So will the mosaic plot be flat across, or will it look very like this? How will the mosaic plot look? Will it look flat or completely like lopsided? How will it look? It'll look no association, independent. You're right, and it'll be flat. You are right. Nice job in the chat. So here's how you make it. This is one way to make it. You go to fit y by x, which is your bivariate. Nice job on all those points. Interaction. Great job. And then we go to, we're going to see if somebody passed or failed, because we're going to say, why do people pass or fail? Maybe it's their test version that explains it. The best way to remember X and Y, in my opinion, is to say, why do people pass and fail the test? Maybe their test version explains it, that the X explains why something is happening. The frequency is going to go down here into frequency, and we're going to click OK. Now, I know that this is blue, which means quantitative, but it's actually just the counts. We're analyzing two categorical variables right here. So when we get the mosaic plot, it's perfectly flat. Now, what we have going on right here, I'm going to lightly explain. There's the mosaic and the contingency table. I'm going to bring this just down to the counts. I don't want to show you it yet, though. So for anyone who knows what a p-value is, The p-value is the probability of our results or results more extreme happening by random chance variation given that the null is true. I just said a lot. We're not going to go into p-value right now too much because that'd be a good 30-minute discussion. The first time I teach it, we go in great detail and we do it multiple times throughout the semester. But this is maybe some help for people to remember later on. So this is kind of a secret p-value talk. It's the probability of our results or results more extreme happening by random chance variation given that the null is true. But the way I say that right now is not going to help you out. But I want us to think about something. I want to tell you what the null hypothesis is for this. The null hypothesis is that the two variables are independent. Now, I want you to tell me, if the test someone took and their grade are independent, is this what you would expect to see? Did everyone hear what I said? If somebody's test version is independent of their grade, is this what you would expect to see? We're saying yes. Because think about this. It looks like they're independent. Because what do we mean by independent? The test you took would not determine your grade. That's what independent means. So don't overthink this. You said this is what I expect to see. Do you think that would mean that the p-value is high or low because this is what you expect to see? Do you think the p-value is going to be high or low because this is what you expect to see? This is what you expected. Think about probabilities. This is what you expected. It's going to be a high p-value. And it's actually the highest p-value. The p-value for this is going to be 1. I haven't seen it yet, but I can tell you the p-value is 1. There's the p-value. The p-value is 1 because this is what we would expect given they're independent. Let me slow down again. The p-value is the probability of our results. Do you see how this is our results? Or results more extreme. Ignore that part for the moment. Given the null is true. The p-value is the probability of our results or results more extreme happening by random chance given the null is true. The part to focus on right here is that the p-value is the probability of observing what we did given the null is true. And what did Brian say the null is for this, which is our literal last lecture of the class? The null is that the two things are what of each other? That they're independent. So would you expect to see this if they are independent? Put a yes or no in the chat. Would you expect to see a graphic like this if the two things are independent? You would. And this is actually the most likely thing to see. So let's do this. What's going to happen to the p-value? I want people to tell me what's going to happen to the p-value. I've done some secret stuff inside of here. Oh, we need that open. We don't need the... There we go. Now we got the full thing displayed. Cool. Let me do this. Cool. What is going to happen to the p-value as they become more and more dependent? So what's going to happen to the p-value here? We're going to set the screen nice and nice. What's going to happen to the p-value here as they become more and more dependent? Because it's going to be less likely to see. As they become more and more dependent, the p-value is going to start to do what? It's going to get smaller because it'd be less likely to see that. So let's have more people fail the test who took version B. So now watch the p-value right here. Do you see the p-value is getting water? The p-value is getting smaller. Oh no, my head's blocking it. The p-value is getting smaller right here as they're becoming more dependent. And actually, the p-value is now statistically significant. Let's make it even crazier right here where we go 70 people pass and 30 people fail. And do you see how the distribution is now changing? So now we have here that it's even more significant. So the p-value is going down because this is less likely to see if they are independent. But if we got them super close, let's say it was something like this. Now, if you look, the p-value here is really high. Do you see how there is this little gap? It might be hard to see, but there's a little tiny gap because there's a very small difference, which means these differences, if you've heard of p-values before, first person to answer this gets 20 points. It's the one thing I said, the p-value right here tells us that the difference we observe between these two distributions are likely due to what? The p-values we observe are likely due to what? Who's going to get the 20 points? They're likely due to what? I'm looking for a two-phrase word, or you could say the one word. The differences there are likely due to what? The high p-value means that the differences are likely due to what? I'll drop a hint. You ready? First person to say it gets it. Here's your hint. Who's going to get it? The p-value right there tells us that the difference we observe are likely just due to what? I'll take Cooper saying that right there. And Nadai right there gets it. So she said the full thing, random chance, because it's the probability of our results or results from our stream happening by random chance, given that the null is true. So you guys got it. It's probably just that it's just random chance that we got these differences. Because maybe we would get a difference like this right here. If you look at this, this is going to be it might even be, oh no, what did I do? Oh, that's ridiculous. That would not happen by random chance. That difference right here, the low p-value tells you that these differences we observe are not happening. They're just almost impossible by random chance. Does that make sense? That the difference, like for this amount of people to fail version B is basically impossible by random chance, given that these are independent. Does that make sense to say it that way? Like for this amount of people to fail version B, that there's no association between these, that they're independent, is basically impossible by random chance. But then when you look at this right here, and you do this distribution, and you get this one, these differences, because someone said to me, Brian, version B, more people failed version B. So when you look at this, is it true that more people failed version B? Is it true that more people failed version B? And someone says to me, Brian, I took version B. That's not fair. More people failed version B. I'd be like, well, yeah. And they'd be like, well, that's not fair for me to take. I'd be like, okay, calm down. Don't talk to me that way. I mean, you can tell me if you think something's not fair, but don't be mean to me. But I'd say to you, well, I ran the statistical analysis, and it looks like the differences we observe between the tests are likely just due to random chance. Like, I don't think there is a difference. The differences you're seeing are just by random chance. Imagine this. Imagine if your friend were to run a mile 10 times, and their time was, let's say on average, let's say your friend were to run a mile and they ran it 10 times. So we have 10 observations and they ran it in 5:25. Now that's a pretty good time from 10 samples. Like that's pretty good. I mean, it's not like, yeah, it's good. It's like, especially we talk about running before, like high school times. You're like a freshman, man. You're doing really well. Going to get under that 5-minute mile. 4-minute. You're going to be like, what is his name? I can't remember his name. You're going to help me out if you remember his name. Alan Webb, that's his name. He ran a 4-minute mile in high school. That's amazing. College, good to run a 4-minute mile. Like these are top tier runners. But imagine if you run a mile, you run 10 miles and you run in 5:26. Now your friend goes to you and they say like, aha, I'm so much faster than you. Is it true that your friend is faster than you? It is true. But the difference is, and I didn't run the statistical test, but the differences between you and your friend, let's just do an assumption right here, might be due to what? Not significant. That's what not significant means. Probably due to random chance. Like, if you were to run miles other times, there's probably no difference between you. Now, we can't say there isn't a difference, but we don't have a significant difference that is unlikely due to random chance. Now, let's say you stop training. Oh, no, you super train. You become Alan Webb, and you run a 3:59 mile, and you do it repeatedly. You're like super Alan Webb. So now look at these. Now when we look at it, if these two people who ran 10 miles, you out-trained your friend right there, these differences right now, the p-value would be very what? The p-value between these would most likely, and I didn't run the statistical test, it's kind of a theory thing, these differences are unlikely due to random chance. It's likely that the runner, we could say, the time is dependent on the runner. We'll talk more about these tests later on, but somebody's time that we observed would be dependent on their runner. It's kind of the same idea we just did, that X is dependent on Y. We're measuring Y is dependent on X, somebody's time is the Y we're measuring, and the runner might explain time. So you could literally, this is my last thing right here, and we've literally covered the end of the class right now. I like to set these things for you to know later on, because we'll be there very quickly, especially mini-term. But we could get somebody's times right here, and we could have runner number 1 and runner number 2. And Brian just do side-by-side box plots right here, and we could even put the mean, sometimes the mean. This is our next lecture. It's a good way of talking about it. And if you look right here, this would be time, and this would be this. And this is a bivariate display of categorical quantitative. So maybe to make it easier so you don't think that's numeric, I'll put runner A and runner B. And so we're literally verging into the next lecture here. We've done it. We've brought a topic into the next lecture that we can see right here, that side-by-side box plots. Yeah, this is the next lecture. Side-by-side box plots are bivariate displays of quantitative data. Now, a singular box plot, one box plot displays what kind of variable? Can anyone tell me in the chat for 20 points? One box plot will display a what kind of variable? One box plot will display a what type of variable? One box plot will display a what type of variable? For 20 points, who's got it first? Who's going to be first? I'll take univariate right there. I'll take that from Jared, but I want it is correct. One box plot is univariate, and Justin gets it right there. Quantitative right there, quantitative. So one box plot is going to display quantitative. I'm going to give 20 points to Nayland also. He also said quantitative. And I don't know. I think Justin already has the 20 points. So I'm going to give it to Nayland also, who I know I haven't given 20 points to. So Nayland, you got it also. Great job. So one box plot is a univariate quantitative display. Side-by-side box plots is a bivariate quantitative display. The box plots are quantitative, and the side-by-side nature of it is multiple categories. So important notes right here, like mini notes. Don't worry, I go through all these things in the slides, is kind of setting the pace, because guess what? We're going to put a note right here. We're hopping back to the slides. It is now time for displays for comparing groups. Now, I want to take a quick poll. Who feels like they understand p-values a little bit better? Like maybe you've heard it in another class or you've never heard it. Who feels like maybe they understand p-values a little bit? We will go over it. Good, I'm glad to hear that. Once again, we will go in more in depth. We'll do it again. We'll do it slowly. But I kind of just put it out there, and I did it for like 15 minutes. So I'm glad to hear that. We'll talk more about it. We'll go more slowly. I won't say the p-values probability of our results from our stream happening about random chance variation, given that the null is true. That's my third time saying it ever. I said it 3 times today. So it's my third time saying it. Little introduction. That's the goal of those things. I don't expect you to understand p-values comprehensively right now. We'll talk about them slowly each time. And then please ask questions when you don't understand it. You have to hear things like 2 or 3 times, easily maybe 4 or 5 times. But the more you hear it, the more we practice it. Every time we do it, we'll kind of do it in context. And that's what we want. Nice job, Ben. Over 400 points. Not 100% confident. We will get you there, Hunter. We will get you to understanding it better. So that was just a mini thing on p-values. I'm not going to go too much more in depth on them right now because they will be more important a week or 2 from now. But right now, my problem with p-values is that I could never get statistically significant numbers in my experiments. Yeah. So that tells you what? That Jared's results were most likely due to random chance. And that way he doesn't have a real relationship between what he's looking at or something that we think is unlikely by random chance. So it's like, we don't think that X and Y have an association or correlation. Oh, and the last thing I was going to mention, sorry, we got to hop back here. We're hopping back to the screen. I clicked the wrong button. I clicked the right button. I didn't press the button long enough. I kind of tapped it really quickly. Let me show this. Gotta go to YouTube, Stat201, UTK. Okay, so I posted some videos recently. And let's go to the videos tab on my video screen right here. Here's my last thing that we have is I'm posting these new videos. It's actually making people unsubscribe to the channel. Fun right there, right? But people get the notifications like Stat201 posting a lot of videos. So these new videos right here are, and please give me advice on them. If you're like, Brian, you went too quickly, don't worry, you can even put that in the comments. I'll probably still like it. But these videos right here are how to do things very quickly using jump or using R. So I'm going to try to make new videos that are 1-minute tutorials where I basically do it nice and quickly. And thank you, Samantha, so very much. And if you guys want, if you watch one of these videos, throw a like on them. It's gonna break the universe if I do that. Just like, but throw a like on the videos, throw a comment on the videos. But each day I'm trying to challenge myself to put out 4 new videos. I know they only say that they're a minute, but I record them like 10 times and then I do a little bit of editing and then I've got to make the title card. I'm not saying they take a while, but I try to put out a really quick quality video. It's jump mostly for our project at the end of the year, and for homework too. So Aaliyah, email me immediately and I'll try to help you out. Do you have videos on RStudio? Yep, I'm doing some of those videos too. You can see them right there, the RStudio videos. There's my audio sync test right there. So literally, that's what I was like, all the videos is me clapping and they're unlisted videos, my audio sync tests. So please ask for videos if you're like, hey, Brian, you don't have a video on this, all that stuff right there. So thank you so much. They do have ads on them just because I want these. If they have ads, they go out to more people. YouTube's more likely to advertise them. And I want to start using Python. So Isaac, keep sending me emails. We'll keep talking about this. I've got Jupyter on my other computer. and I'm still figuring out how to use it. So hopefully, Isaac, this is the summer I learn how to use Python. And exactly, so Kyle, a big thing right there. Thank you, Kyle, because my goal, we've made $35 so far. If these videos start gaining traction, especially like the R videos, because a lot more people use R than Jump. Not like Jump is bad. It's just that you have to pay for Jump. And so Tristan, what it was is each time I did one of those syncs, I tried to resync it better. And on the first sync was way off. The second sync was a little bit off, and the third sync was perfect. It's like a 1-minute video of me just like clapping like that. And then I downloaded the video and looked at how many frames it was off. So that way, if you watch the first class, you will see there's a little bit of disconnect. So all that good stuff right there. So I wanted it to be synced as best as I could. So I went in and put the delay in Streamlabs and got it down. The second one I was kind of happy with, and then I was like, I can sync it better. I was like, oh. So I was just downloading videos and looking at frames and syncing it. So, and that's how you do it. It's like, that's why they have the clapboard, so they can make sure when it literally hits, that's when you should hear the audio. So you get the sync perfect. So, and then the top part of it's color correction, I believe. So, yay, cool stuff. Learn how to do videos. So all that good stuff. We are ready to go. And so we do our deep breath. Time for the lecture. You wonder why I do that? I know where then I start the video. Okay, another short one right here. Don't worry. Should be easy Friday, fun Fridays right here. And let's do Chapter 4, Understanding and Comparing Distributions. So we have displays for comparing groups. Well, what can we do here? What do we got? Well, we've got here the speeds in the Hopkins Forest. This was collected in 2011 through April through September, spring and October and March, and all this good stuff right here. Friday, we love it. So let's take a look. Well, what do we have right here? First person to tell me the shape of this. Any sort of stuff dealing with the shape gets 20 points. You got this. First person, 20 points. Who's got it? Thank you very much, Gracie. Who's got telling me stuff on shape? I'm going to try to remember. If I have already given points, you can still answer. Skewed to the right. William, you are right. William got some points right there. It is skewed to the right. It's uni. Who's going to say unimodal first? I've already said it, but who says it first? Unimodal right there. Jared got the points for unimodal. You're right. I'm going to look for one more thing because we've talked about the, who says we need one more thing for the shape. Who's got it? Who's got the last thing for shape? Who's got it? There's one more thing we could talk about with this. I don't see it yet. Hopefully, what do we see? What do we see? We need one more thing. You already got your points, Jared. Then I'm giving the points to a random person. Matthew Glenn gets it right there. Matthew Glenn, you get the 20 points. Thank you, Jared, for that right there. Don't worry if you get it. You can still say it. Just say, I got my points. Still answer. Still getting those points for talking. And Outliers, Nayland. We already get points to Nayland, though. So we're going to give random points right here to Taylor Dennis. Taylor Dennis, because we gave points to Nayland already. Great job. That's what I wanted to hear, is that this is a unimodal right skew distribution with outliers and a very small gap. That's maybe, I don't know how many observations that is. Now, I want you to say, Brian, the proper center, or you have to say the proper center would be this to get your 20 points. The proper center, if you can't tell, we are reviewing right now. The proper center would be the what? You have to say the full thing. You have to say the proper center would be this. Boom. Claire right there. I think we've given points to Claire. So Tyler got them. Tyler. And Claire, if you didn't get them, you still have those 20 points. But Tyler definitely got it. He knows the proper center is the median. Get ready because the proper center, the proper spread is the what? Who's got the proper spread? The proper spread is the what? These two are paired together. It's review questions from yesterday. You got to say the whole full thing. The proper spread is the what? You have to say the proper spread. Oh, people are already saying it. I'm going to get the first person who says the proper spread is the what. The proper spread is the IQR. Claire got it. And Keaton, I think Keaton got it. I'm going to throw it to Morgan right there in case we haven't. Morgan and Keaton also got those 20 points just to make sure I've given it to someone who hasn't given it because I don't know if I've given the points to Keaton, but Morgan, you got it. And Keaton, you got it. You got it right there. Nice job. We know what the proper spread and the proper center are. Now, why were those? Great job, everybody. Remember, you're getting points for chatting if you didn't get the points right there. If you didn't get the 20 points, you're still getting points for chatting because you get 5 points for chatting. So you got a fourth of those points anyways. You're still getting points. Why? Why is it the median and the IQR? Because it is a skewed right distribution. This is a review from yesterday. It is a skewed right distribution, meaning that we should use the median and the IQR. Now, it is not normal, but if it had been normal, which can be represented by, it is not normal though. This is just a what if scenario. Space Pen's coming back because normal's awesome. If it looked normal like that, then it would be the mean and it would be the standard deviation. So if it was normal, it'd be the mean and standard deviation, but it's not. Probably the most important thing about the shape is the skewness to it. So since it is skewed, it is unimodal. It is skewed right to the high, left to the low, whatever way that tail goes. So we can draw. Oh, that's insane. I had it selected. So we go right here and we do this. We draw our little monster dude. And here's our monster dude. His eye's not going away today. We got regular pens back. So much happier about that. And so you see right here, all this good stuff. So we see that it is skewed to the right. And so this indicates that we use the median and IQR. If it was normal, we'd use mean for center, and spread would be standard deviation. Will we be allowed to have scratch paper on the exams? You totally will. Is lagging for you? Hopefully it's working fine. Everyone, so if it ever starts lagging, people please tell me. We did have one YouTube video crash one time and it was rare. I've streamed maybe 100, not 100. I've streamed like 80 times. Turn down the quality. Thank you so much, Jared. If you haven't got 20 points, 20 points. Love it when people help each other out. It's working okay? Good job. Click and unclick live. You got it. You guys are awesome. Thank you for helping people out with doing this. Describe the shape for each. One of them's a little bit more symmetric. So here's what we have right here. Awesome. Usually when there's a major problem, well, this one's more uniform. That one's a little more uniform. It's still skewed right, but the mode's not as clear. This one is definitely a lot more. If you look at this guy, this dude versus this dude right here, this one right, graph number 1 is more skewed to the right. Thank you so much, Gracie. So with this right here, you can see there's more skew to the first one. It's got just a bigger tail. And once again, we can numerically measure these. I'm not going to put on the test like it'd be like a written answer, but I'd probably say that the first one has a stronger skewness. Can you form graphic? That's the issue on this one. It's a weird one. Rarely is anything perfectly uniform. It's just that the mode here is not as clear. There's a larger modal area, and then the skew with the outlier kind of pertains to this area. So, it's really hard to describe this one in like one sentence. It's like there's a strong modal area between 0 and 3, where we see the skew take on between 3 and 6. The right skew mainly is there. And then we see 7. At 7, we see the outlier, or around 7. That's below 7. It could be 6.99999 because the bin widths here are 0.5. So that number right here, I don't know how many observations. There might be a few observations. No, this is me being like analyzing way more in depth than you would. It's still unimodal right skew. It's just that the skew is less apparent. I'm just being pedantic. I'm going into too much detail. I would never have you guys do that. It's still right skew. Put it this way. Here's a test question. Graphic number 1, would you use median for center, or would you use mean for center? Median or mean? Median or mean? Graphic number 1, would you use median or mean? Median or mean? Median, you're right, median. Graphic number 2, would you use median or mean for center? Would you use median or mean? Let me change it. Graphic number 2, would you use IQR or standard deviation for spread? Would you use IQR? I think I tricked people. Oh no, I did want to do this because I wanted to clarify, because I thought I could trick people. I'm going to call that skewed to the right, and I'm going to call that skewed to the right. So because I called these skewed to the right, they will both use median and IQR. Now, when you use median, you must use median and IQR because those two go together. And just if you're wondering, think about it. This is based on the 50th percentile, and this is based on the distance of the 25th and the 75th percentile. So why do they go together? They're both percentile based. So median is percentile based and IQR is percentile based, because the median is the 50th percentile, which might be somewhere around here, and the IQR is a percentile based there. The median on this might be about here, and the IQR might be this range right here. They're both percentile based. No worries on that oof right there. But so they're both median and IQR. And that's why oftentimes I ask questions, because I think I can trick people. I'm going to call them both skewed, and since I define them both as skewed to the right, doesn't matter which way the skew goes, I'm going to still use median and IQR. Just to review on the previous slide, if I say that they're skewed, then I'm going to use median and IQR. I defined both of these as skewed, so the proper measure for center is median, and the proper measure for spread is IQR. If I had defined them as normal, then the proper measure of center would be mean, and the proper measure of spread would be standard deviation. And if I ever misspeak, please correct me, because I'm oftentimes bouncing topics a lot. I'll hear it sometimes in my playback in my head. Anyone else got that automatic rewind? So here we are. We can report all of this. You can if you want. Sometimes, because usually software will report all these, but it is true that for these, we should be looking at the medians and IQR due to the skewness. And if you look also, take a look. The mean is higher than the median. That's something we mentioned yesterday. This can be a test question a lot of times. This is a good note. Take this note. The mean will follow the skew. The mean will follow the skew, which means if it's pulled to the high side, it's skewed to the right. If the mean goes to the right, which this mean is to the right, it's skewed to the high side. The mean follows the skew. So if the mean and median are on top of each other, you probably have a symmetric distribution. But if the mean is to the right of it, which this is, it's to the high side, you have right skew. If the mean is to the left skew, the mean is being pulled down, so it's skewed to the left. The mean follows the skew. Great job. Kyle, I'm throwing Kyle 20 points if he doesn't have it already. I love when you guys put those notes in the chat, reinforcing those behaviors. So, yeah. Great question right there, Josh. The median will be larger. So, Josh, you get 20 points. And if someone answers Josh's question, the median will be larger than the mean when it is skewed what way? The median will be larger than the mean when it is skewed what way? The median will be larger than the mean when it's Claire right there. And I think Elizabeth and I don't know if again, Elizabeth, Claire, and Christina all have the 20 points. They're the first three to answer because I'm making sure we're getting some new people in those. So the median would be here, and the skew is going to pull the mean down. Now the median is higher than the mean because the mean got pulled to the low side. The mean follows the skew. So if you had a distribution that looked like this, then the mean is going to go below the median because the mean is going to follow the skew of it. Great questions. Good review stuff. This is review. We like to do review in class. Okay. So use histograms to compare distributions. Cool. So let's look at two machines right here. Here's our two machines. We've got machine A and we've got machine B. And now you'll notice, I'm going to delete these. Boop. Now, these machines are printing money. Now, I want you to look at these two machines right here. And if you look at it, wow. Machine 1 is printing like this much money a day. It's kind of, I don't know, that's the median or the mean, somewhere around there. Oh, there it is. That is the median. Because in a box plot, which we will be talking about shortly here, this line right here, oh, look, wait a minute. It looks to me like the median for machine 1 is a little bit higher. They're both skewed to the left because actually the diamond right here is the mean, and the diamonds are a little bit below the median, so they are skewed to the left. Great job right there. It's a little bit of review, and it's a little bit of new stuff. It's like using the old concepts to talk about new stuff. That's why we go so slowly in Chapter 2, because you should know that both of these histograms are displaying quantitative data. Both of these histograms are displaying quantitative, and now we have a bivariate display right here of two machines. So, but why would you want machine 2 over machine 1? If these are printing money, which is a weird machine, or these are your salaries, we could say, so we're not doing anything illegal there. But if these are your salaries, why would you want a salary from machine 2 instead of machine 1? Well, Brian's showing you that isn't machine 2 lower than machine 1? Is it? The trick, I think people are seeing it. The trick is that. And it would be the axis on the bottom. Great job right there, William. It's the axis on the bottom is totally different. So what do we want to do? We want to put them on a common axis. So let's actually do that. When you put them on the common axis, it's very easy to see. So these are the same graphics. Like these are the exact same machines. Nothing's changed. They're the same machines. It's just that they're now on the same common axis. So if you notice right here, the axis on the bottom has a same common horizontal axis. And now you can see that these differences between the two machines where here's the median here and here's the median here. The median is this line right here. It's easier to draw on these because they're bigger. The mean is the center of the diamond. I know it's very, So the mean is the center of the diamond. Not a lot of box plots do that. Jump shows you that. Box plots don't have to show you the mean. More on box plots in a moment. But the mean is the center of the diamond, which is to the left of the median, which is the line in the middle of the box plot. More on box plots in a moment. But if you'll notice right here, we have another key concept that let's just talk about a singular histogram and a singular box plot. Here's a big note that you need to take right now. A singular histogram, which that's the histogram, or a singular box plot display what kind of data. First person gets 20 points in the chat, big points on Friday. Even as we get closer, points are going to keep going out to people. I'm going to try to get new people every time. A singular box plot or a singular histogram. I'll take that from Kyle right there. Univariate. Devin, there we go. Cooper said quantitative. That's what I want to hear also. It's univariate quantitative. You guys are right. So, and Kate said univariate quantitative. So Kate definitely gets points. She does not have them yet. Remember, you can only get the 20 points once, and it's one of those big points day. So we see right here that a histogram displays univariate quantitative. We see right here that a box plot displays univariate quantitative. That's a big note we need to take, that histograms and box plots display univariate quantitative variables. Now, when you look at this, this is actually bivariate because we're displaying by machine. We're displaying machine as a categorical variable right here. And then you have the quantitative analysis of its output right here. So you've got basically just broken apart, like one histogram for the machine 1, one histogram for the machine 2. So histograms are still displaying quantitative data. It's just that you're making 2 of them and you're doing it by the machine. So that's why it's a bivariate display right here. We're displaying stacked histograms. And you definitely want to put the same scale on them. So now you're saying, Brian, what's going on with those box plots? Well, don't worry. I got you. I got you on those box plots. I got you, fam, right here. So what are these box plots and what is the 5-number summary? Box plots and 5-number summaries go together hand in hand. They're buddies too. They hang out. We got so many things that hang out in statistics. They're all friends. Everything's friends in statistics. So box plots and 5-number summaries are going to be the 5-number summary is displayed in a box plot. So what is the 5-number summary? We did this yesterday and we drew out a great graphic. Let's do a little mini version of it. The 5-number summary can be remembered the following way. Here's your tip for remembering the 5-number summary. Draw 4 quarters. How much is a quarter worth in the chat? Quick 20 points right here. How much is a quarter worth? I can't remember. I forget these things. How much is a quarter worth? 25 cents. Olivia got those points right there. You're right. Quarters worth 25 cents. You know that. Everyone knows that. Getting those. People are getting some crazy Streamlab points right now. Remember, interacting live gets you those Streamlab points. So here we go. Come right there a little bit. We're going to draw 5 lines. 5 lines. Space Pen's coming to the rescue because I forgot. We're drawing 5 lines right here between these. And now we can do this. The lowest number representing 0% of the data, the highest one, 50, 75, and then 100. And then this is the lowest, making it the min. This is the highest, making it the max. This is the median. I'm just going to abbreviate. This is when you're at 3/4 of the data. This is where you're at 1/4 of the data. So that is a very, very quick way to remember. And then this is a review from yesterday right now. We're going to do it in green because green looks like we're doing something right. And we're going to go right here. And this is the what. Brian has now just highlighted the what of his data. The green box contains the what. The green box contains the what. 20 points, who's got it? The green box contains the IQR. Hannah, you got it right there. Hannah, you are right. Nice job. We'll try to give out as many points as we can. Remember, if you got the points, you can say, I already got them. I'll pick like a random person at all times. If we someone's like, I already got my points, you start tagging me up. Brian, she got it. Like, make sure that person tags me and say, Brian, I already got my points. My gosh, William, amazing job. So that is the IQR right there because it's the interquarters. What is the IQR? It is the literal interquarters. The IQR represents 50% of the data. The middle 50% is contained in the IQR. The middle, you already got them. Then the points go out to Maya right there. Maya got the points. Thank you, Hannah. Maya, you got some points right there. Great job. Random person gets it when we do that. So here is, wait, why are we using, I'll answer this one, but I'm just trying to think. Why would I use the 5-number summary on this? Oh, wait a minute. This is extremely skewed to the right. We talked about this earlier. This is extremely skewed to the right. There's his eye. And so it's extremely right skew. So we need the median and the IQR here. The median and the IQR will be used. extremely right skew. We got to use the median in IQR. We have to right here. We have to use the median IQR. So we're going to use a box plot, which is going to display all these numbers for us. The box plot is a visual display of your 5-number summary. The box plot is a visual display of your 5-number summary. We should also say a box plot. Let me add 2 notes on it. A box plot is a visual display of your 5-number summary created from a univariate quantitative variable. To repeat, remember, you can always rewind and stuff like that and then click live. A box plot is a visual display of a 5-number summary created by univariate quantitative data. A box plot is a visual display of your 5-number summary created from univariate quantitative data. Thank you so much, Kyle, right there. You have your 20 points, definitely. I love the notes in the chat. That's keynote number 1, visually displays the 5-number summary. Big note number 2 is a box plot is for univariate quantitative data. So those are the 2 things you need to know about box plots. Like, major important right there. Bridget, you got 20 points also. So let's take a look. Like I said, points just getting crazy today. Now, remember Monday, but show up Monday, please show up Monday. And interact the whole time. What do we have right here? What do we got going on? Well, look, the box of the box plot is the literal IQR. The box of the box plot is the IQR. It's like where I drew this box right here. Well, wait a minute. That box right there is the IQR. So that's the IQR. Quick 20 points. What's going on with this line? Whoops. Can I not? Oh, there we go. What's going on with this line in the middle? What is that line? Quick 20 points. Who knows what that line in the middle is? It's in the middle of the IQR. Wait a minute, the 25th to 75th. Median, Tyler, you got those points right there. So, Tyler, you are right. That is the median. That is the median. So we can put some notes beside this just so we know what's going on with this box plot. Here's the 75th percentile. Here's the 25th. Here's the 50th. There are weird scenarios where they overlap. If you don't see it, like, let's say, I think I can adjust this. This happens. Sorry, world, but sometimes box plots aren't so pretty. I can't adjust. Oh, wait, I can. Yep. You can get box plots like this. This is just because you can get even weirder box plots. You can get a box plot. I can't adjust the size. Yeah, look, I can do that. You can get a box plot like, not like that. Oh, there we go. You can get a box plot like that. That can literally be a box plot because every single observation is there. If you were to have a box plot like this, that would mean every observation, there's no variation in your data. Every observation was at like, that says 0.46. Now this data is no longer coherent with this, but this would be your min, your Q1, your median, your Q3, and your max. That could be a box plot. It's just that there's no variation in your data. So you can draw ridiculous box plots. I think I can open up a small Word document in the background here. Let's do a ridiculous box plot. Somebody tell me if this were to be a box plots for test grades. Like, this is a box plot. Oof, went off the screen here. This is going to be a box plot right here. So here's your number line. You can draw a box plot sideways, vertical, horizontal. Here's a box plot. Who likes this box plot? Someone tell me about the class and tell me about this box plot. Someone tell me about the class. Would you like that for our class for the box plot of test grades? That's a box plot. That's a full box plot. That'd be nice. There's no variation in the data. Everyone made 100. But usually you don't see that. Usually you'd see something more like this. Here we'll put 50 right here. And usually you see something closer to this. And we'll put 70 and we'll put 90. And then we'll put that. So someone interpret this right here. 20 points for the first person who interprets this, because this is what we just covered. So someone interpret this right here. I'm going to say it because this is I want to see what you guys say, but I'm going to say it totally. You ready? Well, the IQR right here is 20 because the difference between 70 to 90 is 20. And the middle 50% of students scored between a 70 to 90, which is a range of 20. But the middle 50% of students, or 50% of the class, Ethan said exactly it. 50% of the class made between 70 and 90. That's it, because that's the IQR, the middle 50% of students, 50% of the class. You could say the middle 50%, but it's still 50%. It's just more specific to say middle. I'm totally fine. But 50% of the class scored between a 70 to 90 on the test, which is an IQR of 20. All you do is subtract the numbers to get the IQR. And don't worry about which way you subtract them. Just remember it's positive. You could do 70 minus 90 right there. But it's still, if you get negative 20, it's like still 20. So because it's just a distance between the two numbers. So now people might think, well, the median always has to be like right here. That's not true. The median doesn't have to be right here. Maybe it looks like this, because the median might be closer to 85, which is the 50th percentile of grades was an 85. And then we see this right here. Somebody made up to 100. And then we see something like this right here. And we might see some dots. That should be right. Actually, I'm going to do it perfectly. Okay. And I have a really good speed run of this. I might actually have you guys view the speed run. We're doing okay on time. This is one of our last big topics for this one. But when you look at this right here, you'll notice that I only went down to 40. There's going to be a reason for that in a second. But I want somebody to tell me the lowest grade on the test was very close to what? I'm trying to make it very clear. 20 points first person. The lowest grade on the test was basically a what? A 0. Jared, you got it. Thomas, I'm giving you the points if you don't have them for asking. These are outliers. We're going to go back to the notes here in a second, but these are outliers. So the outliers right here are things that are below this fence. Let's go back and look at this in the notes right here. Let's go back to the notes and do it by the notes. Not chapter 5 yet. No. So we're going to rewind this right here so we can actually see that we have some keynotes we need to understand with this. The biggest things we need to understand here is that the box represents the IQR, and the line in the middle, which is often there. I don't like to throw a lot of tricks, but I just want you to see if it's not there, it's overlapping one of the things, but that represents the median. That is the median. That's the IQR. Okay, so now we need to draw these fences. Here's a huge note. This is probably one of the trickiest things. So here's a big thing that is a big learning objective today. The fences are exactly... Can I not select it? I could last semester. There we go. The fences are exactly one... Oh, no. We don't want that. Okay. Cool. Now now I got it. Cool. Working. That is the length of it. Let's go 1. Oh, I'm back a slide. We don't want that. Oh, cool. Perfect. 1.5, as long as we did these graphics correctly. Yes! And this one right here. Don't like that. It's not visually accurate. That one is visually accurate, I think, just because we can't go off the bottom of the slide there. But when you look at this right here, the fences should be 1.5 IQRs above or below Q3 and Q1. I'm going to show you the formulas in a second for this. But where did Brian calculate his fence to be? Where did Brian calculate his fence to be and why? It's always 1.5 with these graphics. That is correct, Hannah. Great job right there. So our outliers, they would just be unusual observations. That's what an outlier is. It's something far away from the central portion of the data. An outlier is something that's just unusual, and we wouldn't consider it kind of like a normal grade. It's an unusually low grade. And there's no unusually high grade here because there's no outliers on the high grades. So why did Brian, this is the big question, why did Brian put his fence at 40? And the fence happened to be there, and more on that in a moment. But my fence, which is right here, it's invisible. Why is it at 40? Why is the fence? Well, let's wait, think. You got it, Andy. Andy, you got the 20 points right there. So what we calculated first was the IQR. IQR equaled to 20. Since the IQR was equal to 20, we then did 1.5 IQRs below here. So this distance right here is 1.5 IQRs. Everyone tell me what 1.5 IQRs is equal to. 1.5 IQRs is a distance of 30. Do you see how that is 1.5 IQRs? Does that make sense that I went 1.5 IQRs? 1 IQR is 20. A half of it is 10. So it's 1.5 IQRs below. Now, if I were to calculate the upper fence, can anyone tell me, big extra credit right here, 20 points. Can anyone tell me where the upper fence would be? Where would the upper fence be? Can anyone tell me where the upper fence would be on this? Where is Brian's upper fence? Where is the upper fence? 120, Justin. Nice job, Justin. I think you have the points, but you still got them. Kelly got the points also. Kelly, you are correct because we simply go 30 above Q3. So I'm going to write the formulas here in a moment. And you might say, well, why, Brian, why did the whisker, another 20 points, why did the whisker not go all the way up to here? Why did that whisker not go up to there? Why did the whisker not extend up to the fence? Someone's got to explain this to me in the chat because I don't understand. Yep, Claire basically got it. Devin, Claire, you got the points. You are right that there's no grades there. So the whiskers only can go up to the data. So this gap right here means, and you don't usually see the fences, you'll see this in slides, this gap means there's no grades in that range. Now, if all of a sudden someone did have a crazy grade, like let's say someone got 130, they would be a dot right there. You got it. So Samantha James, you've got the points. So Samantha, you got the points. Let's say first names here. So Samantha, you got the points. Great job right there. And if you notice that 130, this right here is a person who made 130. They are now an outlier, which is a bit ridiculous, but you would have this gap. Wait a minute. We're talking about gaps and outliers again. We're talking about unusual features in a box plot. You've got a gap right there leading to an outlier. All this good stuff right here. So that's a cool 130. Exactly. That'd be amazing, but that's a huge, huge outlier. How are we getting the 30? Great question. The 30 is obtained from 1.5 IQRs. The IQR is 20. 1.5 times 20 is 30. So the IQR is going to be calculated from 70 minus 90. That is equal to, let's highlight them as we say it. 70 minus 90 is 20, because that's the range of the middle 50%. And then to figure out where the fences are at, we simply go 1.5 IQRs, which is 30, below Q1 or above Q3. So that's where Q1 and Q3 are, and we go 30 above them or 30 below them. Great questions right there. So would the fence be moved because it's 130? Nope. Because the fence is, great question. Great. Like, I keep asking those questions. Thomas, you definitely got those 20 points. The fences are calculated from where Q1 are at. There's Q1 and there's Q3. And so the fence is calculated from there. So that's where we calculate the fence. Now, you don't usually see the fences. And it just so happened that this represents right here that someone actually made right out of 40. Now, this represents someone made a 100, and then we have the ridiculous 130 right here. But there's this big gap where nobody scored between 100 and 130. Like it. Yep. So that in the yellow right there, the highlighter means no one made between 100 and 130. And then the 130 is an outlier. Somebody scored a 130. The green arrow at the 40 represents someone made a 40, and then all of these dots down here are just outlier low grades. So if the IQR was 30, 1.5 IQRs would be, yes, Morgan, amazing answer. Morgan, you definitely got those 20 points. Great job. I think Monday I'm going to limit myself. I have an idea. Monday is mega extra credit. Friday is crazy extra credit. Monday mega extra credit is 50 points. And we're only going to give out 5 of those, and they'll be given out at like 30 minutes intervals. They could be completely random, but Monday's mega extra credit, Monday's mega, and Friday is crazy extra credit. Like a lot of people will get it on Friday, and Monday's mega. So mega Mondays. So that's it. We're making themes for these. Maybe we'll have more ideas, but we got to make sure people are attending. So Friday Frenzy, Nadai, you definitely got those 20 points. Friday Frenzy and Mega Mondays. You got it. Why is the fence not at 120? Kyle, great question. Remember, how do we calculate the fence? So let's look at the formulas for the fences. The formula for the fences, that's like some alliteration right there. We showed in the notes. I know we do. Did we literally remove it from the notes? You got to be kidding me. Let me write it down. Okay. It's written right here, but let's be very specific. It is going to be Q, so the upper fence, Q3 plus 1.5 IQRs. So that is the formula for the upper fence. And the lower fence is Q1 minus 1.5 IQRs. There we go. So when you look at this right here, we have how to calculate, just like a looking barrel like that. We have how to calculate the fences, because if you notice, I'm actually going 1.5 IQRs above Q3 and 1.5. It's not visually accurate. That just bugs me. But we would go 1.5. Technically, you can't have an average wind speed below 0, so it's kind of ridiculous. So what you'll notice here is when we draw it in, can you explain how you got the 1.5 IQRs from the 20? Great question, Carly. So the 20 wouldn't matter. The 20 is just how we calculate it. The upper fence is always going to be 1.5 times the IQR. So you ready? Here's a review question on this slide. So I hope this makes it a lot more clear. I want someone to calculate the IQR for me. I want someone to calculate the IQR on this slide. 20 points. Use the information over here. Calculate the IQR. I think I have it. And show me the math. Who's got it? Calculate the IQR for me. Calculate the IQR. Who knows where the IQR is at? You got it right there. Zulon, you got those points. So that is how you calculate it, and it's 2.28 minus 2.28 minus 0.46. Great job. Be following along, be solving these things, know how to calculate the IQR. Nice job. People putting the formulas in chat. Love it. So 2.28 minus 0.46. There we go. Nice job, Hannah. So now that we know what the IQR is, it's 1.82. Oops, that's not where that goes. Now that we know what the IQR is, what is Q3? Q3 is 2.28. And I want someone to tell me where the upper fence would be. Where is the upper fence? Where is the upper fence going to be? Where is the upper fence going to be? Now, you can kind of see it visually. I hope this is accurate. I might have to check it. It looks visually accurate. So where will it be? Jack got it right there. Nice job, Jack. 5.01. I'm going to take that as the right answer right there. Nice job, Jack. So we're going to say it's 5.01. And if you look at this visually, that number right there is where the upper fence is. Now, there is a value outside of this, so we're definitely going to see something outside of it. But we have to use this formula to solve it. And if you see visually right here, we are literally going 1.5. Now, I'm sorry the visual down here is wrong. It's not where the lower fence is. The lower fence would even be below that. But you can't have data below 0 average wind speed. So it's almost a moot point here, like of no significance, legal significance technically for moot. But you'll notice when we do the data, you only can extend the whiskers. Here's a key note. The whiskers extend to where the data is inside the fences. The whiskers extend to where the data is inside the fences. You see that in my example over here, where the whisker goes up to 100 because somebody made 100, so the whisker went to it, but there were no grades between here. If there had been like 105, the whisker would go up to that. But then someone made 130, and they're an outlier. Down here, someone made a 40, so it goes up to the fence down here, and then we have low grades down here where someone made a 0, and they are outliers. So the whiskers extend to where the data is inside the fences. So there was a day with a wind speed at 0. There was a day very close to 5.01. It might not be touching it, but it's very close to. And now, all we're going to do is add in the outliers right here. Sometimes a star is used. That'll definitely not be on the test. Let me just put an X on that. Don't worry about that. I don't do that. So, I mean, it's like one of those things you could randomly know, but I don't do that. So we see here that we have the outliers. Nice job right there, Kate. The outliers are things that are outside the fences. So these are outliers right here. There is no, imagine your friend were to say to you, whoa, today was so weird. I don't know why they're talking like that. Today was so weird, man. The wind speed was 0. And you're like, it was not a windy day. They're like, well, that's so weird. You're like, no, that's low, but that's not unusually low. Does that make sense that a day with no wind is low? It's definitely lower than average, but it's not unusual. You got it, Kyle. Fences determine outliers. You got it. So it's not unusually low to have a day where there's no wind. I mean, it's low, but it's not unusual. But what is unusual? When you're getting these gusts of wind, average wind speed above 5 miles per hour. Like the average wind speed for the day was above 5.01 technically. But that's where it starts to get unusual. Like if someone said, whoa, it was 2 mile per hour wind speed on average day, be like, well, that's higher than usual, but it's actually within kind of what we would expect. That's within the kind of middle 50%. So it's kind of like what we would expect. It's within kind of the bound of what we would normally expect. So usual, usual equals, so let me define usual a little bit better. Usual would be things generally within the middle 50%. I would probably say these things are usual. And things that are unusually, let me be very specific. Things that are a little bit high would be within here. These are the little bit highs. These are a little bit low. Things that are unusually high are the outliers. And if there was something below here, they'd be outliers also. So to be very specific again, let me repeat. These are kind of like very common because they're the middle 50%. I wouldn't say these are unusual at all in the box plot. They're kind of what you would expect because they're right around the median. And then these things are a little bit high. They're not unusually high. They're just a little bit high. These things are a little bit low. And anything outside here that would be outliers, the outliers, to be more specific, there we go. The outliers are unusually high, or if they're below, they're unusually low. The interpretation of the upper fence would say it represents 25% of the wind speeds. Be very careful. Great question there, Neeland. Amazing question. And Kyle also said something, answer in 2 seconds. So the wind speed would have to be around negative. You're right, Kyle. That's the thing. There is no unusually low because it would have to be around, maybe around there. You could double check the math. Let me think. Yes, Kyle, you're very correct. You definitely got the 20 points. It's like negative 2 point something, I think. Close to negative 3. You could check the math if you want. And Neelan said, to interpret the upper fence or lower, you would say it represents 25% of the wind speeds. Be very careful. Where is the upper 25%? The upper 25% is above Q3. So here is the upper 25%. Where is the lower 25%? So which of these have more data in it? Does area 1 or area 2 have more data in it? Ooh, this is a great test question, and it'd be so mean right now. The way I said it is so mean. 20 points, who gets it? 20 points, who gets it? It's a very mean. Yes, Ethan, you got it. I think I'm going to have another person who says equal next. The answer's already out there, but who else? Because I think Ethan's got it. And Mary, if you got the points, you can say I got mine, and I'll randomly give it to someone else. Justin right there. Justin's already got it too, though. But yes, they're equal. So they're equal. Why are they equal? Because above Q3 is the top 25% and below Q1. Now, here's where people get confused. I think they say, wait a minute. Q1 is longer. Or above Q3 is longer. Excuse me. That's area 1. But above Q3 is longer. Well, that's because the data is skewed to the what? The data is skewed to the high. It's skewed to the high. It's skewed in what direction? It's pulled out in that direction. So that's why that area is longer, because it's like we took it and we pulled it out right there. Zulan, you're right. It's skewed to the right. So since it's skewed to the right, there's more of a pull to that. If you were to draw the histogram would look something like, we'll draw it this way. It would look something like this. It'd be pulled out. It's not a perfect histogram, but it's going to be pulled out in that direction. So it's skewed to the right. A lot of review concepts, if you can't tell, we're reinforcing the things we know, that right to the high, left to the low, whatever way the tail goes. So you've kind of got the tail going right here. That's a longer tail to it. So very important to know that these are the same amounts of data above Q3 and below Q1. Here's an amazing trick test question. Now this, I say trick, but these are perfectly fine test questions to ask. Which of these areas, area 1 or area 2, have more data in them? Which of these have more data in them, area 1 or area 2? The answer is, which one? 20 points first person. Be careful. I turned it into another trick. Jack is right, and we already get points, Jack. I remember that. Who says it again? I've tricked everyone. Coleman, you got it right there. Coleman, you got it. So it's 2. It is 2, correct. I double-checked myself. This is 25% of the data. This is 25% of the data. This is less than 25%. Does that make sense? Like above Q3 is 25%. That's everything above Q3 is 25%. So this is less than 25%. Does that make sense? It's a very in-depth knowledge of it, that above Q1 would be 25% of the data, but we gave an area that's less than the complete above Q3. Excuse me, I said Q1 because I labeled it 1. But does that make sense? Good. That's what I want to see. It makes sense. That's a super in-depth answer of what's going on right here. If you're understanding it at this level, you're understanding it completely. And I might send you guys out my speed run of this that I've already done because we're not too short on time, but I've got a really great speed run of this whole topic that I'll send you guys out. I'll send out a reminder of it, but we got a really great speed run I did last semester where I did a whole example in like 5 or 6 minutes. Or maybe it was 8, I can't remember. And we determine skewness just by looking at the whiskers. Yeah, whiskers are a very good indication of skewness. Whiskers give a good indication of skewness. Isn't below Q1 25%? Yep. But look at this. This is everything below Q1. And if I do this, that is not everything above Q3. So this area right down here is 25%. But this area up here is less than 25% because it does not include these points inside of here. Because, does that make sense? Because the 25% would be everything above Q3, including the outliers. Including the outliers. That's a key thing a lot of people forget. It would be everything, including the outliers. So the whisker itself, it can be 25%. The whisker can be 25% if there are no outliers. But if there are outliers, the whisker would not be the 25%. It would be less than 25%. These are like super in-depth things with box plots, but just helps to know what you're seeing when you see them. Nice job. Great stuff. We've basically done most of the lecture, I think, because now all we're going to do is erase these fences. You don't usually see the fences. They're just kind of a graphical thing. So once again, you don't usually see them. That's what a box plot looks like. We had some jump data up showing us a box plot, or we did. It's gone now. But I thought we just said their data is equal. They are equal only in the sense they are equal if we talk about everything above Q3 and everything below Q1. But if we don't include the outliers, then we have less than 25% there, and that is 25%. Does that make sense, Tyler? 20 points, Tyler, for asking. Good stuff. Okay. So, good job. Thank you, Tyler. Here's what they usually look like, and I want to point something out. This is not in the notes, but it helps. Does everyone see that this is the mean? And the mean is higher than the median. It's very easy to tell that this is right skew right here because the mean follows the skew. We can see the outliers right here in the data. They trace down to these points right here, so you can see where each of these are at. So you can literally trace down the points and see that they would fill up the respective bins below. You can also see where the median is at in the data. You can see where the middle 50% is at in the data. You can see where the min is at. You can see where the max is at because this displays the 5-number summary. Very, very, very important stuff. And make sure to stay to the end because we're going to start chapter 5, and it's one of the hardest chapters. I know we'll probably make sure you need to hear a little bit of chapter 5 because we're almost done with these slides. So cool. We can compare groups. We're about to see that. Box plots will be used to compare multiple groups. Here you go. So when you think about this box plot here is a lot smaller than this box plot here. But I'm going to ask a question. You can abbreviate it, 20 points. Which of these right here has more data? Fun Friday, I like that. Which of these has more data? The August box plot or the February box plot? You say, how do you know that, Brian? August, you're right, Jack, right there. And Hannah, I'm trying to remember a new name. Christina's already got the points. Coleman's got the points. Who else? Who else is still here who's getting the points? Erica and Hannah right there. If I haven't given you guys the points, you guys got the points. Trying to give as many people the points I can on Friday. That's the goal on Friday. Monday is only 5 people for 50 points, though. Okay, why is it August? Well, this just tells us the range of the data. The length of these box plots is the range because it's the min and the max. So you can literally figure out the range of them because that's the min and the max, the highest observation and the lowest. But why is it August? Because August has more days. We're doing the average daily wind speed. So August has more data in it because there's more days in August. That's the why. Because more days. Christina, you're totally right. I love the answers in the chat. You guys got it. Ethan's right too. You know what's going on. Which of these box plots has the biggest range? There's a very clear winner, and I kind of gave it away. It's one of my favorite questions to ask. Which of these box plots, who's got the ones with the biggest range? What is the one that is the clear winner on biggest range? And this is a mistake people usually make. February, Justin, you are right. It is February. And don't worry, people are making the mistake, and I like seeing the mistake in the chat let's explain why is it not April? Because the outliers are part of the range. If you compare these two right here, and interestingly enough, March has a bigger range than April because you must include the outliers. So the outliers are included in the range because what is the outlier? The outlier can be the maximum, but if there is no outlier, the top of the whisker is the maximum. So outliers are part of the range. Kate, amazing note right there. Kate, you definitely got those 20 points. On the quiz for chapter 4, it's hard to see that some are outliers. Oh, and if there is an issue like that, please tell me. You know, if you guys miss like a small thing, please email me. Some people have emailed me already. Brian, I missed this. Can you correct this? I will correct little tiny things. Just don't like put in a completely wrong answer and be like, Brian, correct this. I'll be like, that's too big for me to correct. So you always include the outliers when you look at the range. Outliers are part of the data set. You should never ignore outliers unless they're incorrect data. Then you would remove them, but don't just remove outliers. Outliers are very important because they are data. But if you were to get that there was a 1,000-mile wind speed day, you'd be like, I think someone misentered the data. Then you would remove it because it's just bad data. And not bad data like you don't like it. It's bad data because it's wrong. If data's wrong, you can remove it. If you don't like data, you can't remove it unless it's wrong. Okay, that's a very important topic. You can't tell how much I was stressing that. You would only remove it if it's wrong. Here's how to do this inside of Jump right here. Can you explain why August was the answer again? August has the most data because August has the most days in it. Even though February has a greater range, February can at most have 29 data points in it because February has 29 days. August, I believe, has 31 days. I say that and this was like, it has 30. It has 32, Brian. I'd be like, can't have 32. So August has 31 days in it, and February only has at most 29 days in it. So August would have more data in it. August just has a smaller range. All that good stuff right there. There we go. Great question right there. Amazing. Ask those questions when you want to know it. And Isaac, you got those 20 points. I think you got them early on. I might have added them to you. No, I remember you were the one I changed the policy. I don't know the days like that. I hopefully do. There's the trick you can do like this where you can do the days. So here's how to do it inside of Jump. If you're looking at how to do those inside of Jump, cool. Here's a kind of time plot of it. This is kind of we're going to do these quickly because they're not that much on the test. Outliers, cool, we do talk about outliers here. It's going to be a much quicker part of the lecture. When we get to outliers right here, outliers always require special attention. So the outliers you're observing, don't just toss them out. You really need to see what's going on because imagine if your friend was so excited, they trade stocks. Stock market's crazy. And they made one day $5,000. That's ridiculous for a day. I mean, you'd be a millionaire in the year for making that much money. Make like 1.6 or 1.7 mil in a year. Whew, talk about your money in mils. That's craziness. So I know. So if your friend were to make $5,000 in a day where they usually make like $80 in a day, do you think they would toss that day out? Or do you think they would try to understand what happened on that day? They'd be like, okay, wait a minute. What did I do that day that earned me that $5,000? They'd be like, let's just ignore that day. Let's just whatever. I made $5,000. Who cares? Let's not pay attention to that day. Let's try to understand it, Thomas says right there. Let's try to understand it. So that's usually, if they lost $5,000, they'd be like, what happened on that day? It'd be a big outlier, but we try to understand what happened. Now, there can be errors. This is about the only time you toss out data. You can remove them when they're just wrong. Imagine if I told you we have in one of our data sets that someone was 6'3", and they also reported that they were 75 pounds. What do you notice weird about someone who's 6'3" and 75 pounds? Now, that is a very weird combination. What's weird about someone who's 6'3" and 75 pounds? Who can solve this riddle? I would probably say it's not healthy. I mean, just because I'm 6'3" and I'm like 185 pounds, so they're 110 pounds. They're way, way below. So that would be... And so, but who can solve the riddle of 6'3", 75? And this is a real data set. I can actually show it to you if you want in a moment. Just so people who don't think someone's like, Brian, you're making this up, but this is a real data set. Let me hop here to the main screen and let me hop. So people are like, someone's like, Brian, you're just telling stories. No, I'm not. I'm not telling stories. There we go. That's what we were doing yesterday. Let's hop in here. I think it's under, we got to do it inside of here. Do I have, there's red class. Data, I think it's survey 10. And let's go to min of survey 10, weight There's the 75 pounds. And let's go here to survey 10. Oh, and then we got to do which. Oh, can we do which min? So now we need to go in the square brackets. Do not worry, you do not need to know this. Which min of survey 10 weight, and we want all the data on them. There we are right here. So here is the one individual. I can do it a much easier way. I can make it look like Excel. Here, let's make it look like Excel. So here we go. Let's just go here. And has anyone solved the riddle yet? Has anyone solved the riddle about this? 6'3" is what? 6'3" is... Oh, and someone basically got it. 1 inch per pound, you're basically getting it. So do you think that this person accurately entered in their data? At this point, it's 75 inches. Yeah, exactly. 6'3" is 75 inches. So this is real data right here. And even better yet, you can see that something weird is going on right here. Just so you can see, we can do height. I can do it a lot easier. Let me do it this. Attach survey 10. I didn't do my thing. There we go. And then I can go plot and height tilde weight. And let's look at it. So here's the plot of it. And this individual is all the way... Is that them? Yeah, there they are right there. They're 75 inches tall and 75 pounds. I might actually reverse it. Let me reverse the X and the Y variable. We just got to reverse this. Weight, height. And we have this right here. And if you notice, they are now down here. So they're up. They're behind my head. There they are down there. They're way away from where they should be. If you imagine a line going through this, I got to get out of this. I'm going to start doing R for the rest of the class. And actually, the last visualization might have been better because it was easier to see them. So they're all the way over here. They're far away. They're an extreme outlier. And this is a bivariate outlier because they'd be far away from the line. Okay, let's mention that one last relationship. This would be a bivariate outlier because they are far away from the bivariate relationship right here. So, and... Okay, cool. Oh, no, I reversed it. Okay, let me reverse it again. Not height B. Okay. I don't have this data set inside of to do it. Wait. Oh, because of this. Haha. Didn't like it. There we go. Okay. If you look, we've got this person over here, and then you've got some outliers over here. Now, when you look at bivariate relationships, which this is bivariate quantitative, you would see the relationship between two variables, and these are the people that follow the trend in the data. So we would expect somebody who is about, you could go over here and to 75 inches tall. You would expect them, expecting pretty high according to this right here. So, and we could use the X, we could flip it, but you would expect somebody who is about 200 pounds in this data set to be about here. So the things that are not outliers in the bivariate relationship are very close to the line, and the further away you are. Like, is it unusual to be 6'3"? Is 6'3" unusual? No, not really. And how could we look at that? To look at if it was unusual, we'd have to make a histogram of height, and we could look at 6'3" on this histogram, and we could see 6'3" is over here behind my head. That's where 6'3" is at, which is high, but it's not super unusual. So we see some outliers down here, and we could even do this in a box plot. And this is why I love using R, because you can just go and change this to box plot. And now we get a box plot where we see 75 is unusually, it's high, but it's not unusually high. It's above, it's in the top 25%. So if you are 6'3", you're in the top 25% of heights. You're not the maximum height, but you are, in the top 25%, which seems to start around 5'11" or so. And this is males and females together. We see some unusually small or unusually low heights down here, which are like 4 foot something. That would be 4'7", and that'd be 4'6", I believe, because that's 54 inches. So these are very unusually low heights. Does that make sense what you're visualizing right here? And this is a univariate relationship where what you saw here is this is univariate again. This is just univariate here. And this right here is a bivariate relationship. Does everyone see we have height and weight making it a bivariate relationship? We're saying some groundwork for the things we'll be learning. This is called a scatter plot. If anyone's wondering, a scatter plot is a bivariate quantitative relationship. Let's hop back to the notes right here. Okay. So you went on a big tangent there just to talk about, I would remove that person who is 75 inches tall and weighs 75 pounds. I would remove them from my data set because I think it's a misentered data point. I'm not removing them because I think that's too low. I think it's so low that it can't happen. If they said they were 10 pounds, I'd be like, that's ridiculous. You can't exist being 6'3", being 10 pounds. You misentered your data. So that's the only time we would remove it. Never ignore them. You can only remove them and then do your output again without them. So you can do that very easily. Just remove them and then redo your output. Whoa, what is going on here? What's going on with all of these outliers? What is going on with all of these outliers? Does anyone in Kentucky Derby expert right here? What is going on? In the Kentucky Derby, they actually changed the time of the Kentucky Derby. They actually changed. They actually have two distributions right here. That they actually changed how long the Kentucky Derby is. And there's an error in the slides, and I'm going to fix it right here. Because we have the Kentucky Derby times posted. And so let me go grab these Kentucky Derby times, and we're going to do it inside of Jump right here. So we're going to show the same thing, but we are going to show the Kentucky Derby times. Where is it at? Kentucky Derby. Kentucky Derby winning times. Here we go. Let me download the data set. Let me hop over to Jump. Open up Jump right here. Open those Kentucky Derby times. Cool. Let me look at what you guys are seeing. Okay. So if we just plotted the winning time right here, there's the winning time, you would see the winning times look like that distribution right there. And I think there's a super cool way. I'm always liking to do new stuff in Jump. I think you can pick. I remembered a while ago. I wanted to do my Mario button when I'm thinking. Like every time I have to think, I just want to click the Mario music. Maybe I dreamt it up. Well, if you want to split these apart, there is a way to split them apart. You don't want war. There is a way to split them apart right here by going to fit y by x. And then we go into winning time. And then we go to, let's go to distance. Now we can put distance right here. And I'm actually we'll go to by distance. That will do it. Should do it. Oh, it doesn't like that. Wow, so do we have to change the variable type? We need to go to distance and change distance to a categorical variable, which this is just going to be nominal. It makes it red right there. Sorry about that. It said, nope, you can't do that. And I say, okay, distance needs to be, let's go by distance. Let's go winning time in seconds. Let's do it. Some required variables are not input. Oh, I know why. Haha. Let me change it back to continuous. Let me go to distribution. Let me go to distance here in the by, and let me go to winning. My brain the coffee wore off. And now we go to here. Okay, cool. We're going to put them on a uniform scale to give them the same axis. And there we go. Here are your visual displays right here that you can see it took longer with the 1.5. Now, my brain started booting back up again, and I remembered if I do the fit y by x, I'll get a different display. And let me go here to distance and change it to nominal. And let's go to analyze, fit y by x. Distance will go in the x. Winning time will go in the y. And here's the display we get over here. Now, this is a totally different thing. Let's go to t-test. And this is a totally different display. And we could even put in the quantiles, which will give us the box plots. So right here, can I get both of them on the screen at the same time? I have to close this. So what you're noticing right here, take a look at the graphics. We've got a lot being displayed. But this is a big note to take. This is like the end-all be-all. This is a huge summary of everything we've just done for this chapter. First person, what are the graphics on the left? You have to say the full thing to get your 20 points. We're still working away. We need to know the graphics on the left are this. There's two words for them. They are this. The graphics on the left are this. What are the graphics on the left? We have a categorical variable and we have a quantitative variable. What are the graphics on the left? They're something S and then H. What are the graphics on the left? What type of graphics are they? So what kind of graphics am I displaying on the left? Kyle, that's very close, Kyle. It is a bivariate display. They are histograms, but there's something on top of each other. Who's going to get it? I might say it in a second here. They are stacked histograms. Stacked histograms are bivariate displays of quantitative variables where we have a category of what we have for the histogram, and then we have the histograms being the quantitative display. Then we have side-by-side box plots. Does everyone see I'm still displaying the same thing right here? Like this is still the distance, which is what we have here, and this is still the winning time. That's why I'm kind of showing you these at the same time, that you can see that we have here stacked histograms, side-by-side box plots. Now, one box plot is quantitative. One histogram is quantitative. You notice how I highlighted this data and it's like, oh, that's the same data over here. If I highlight this data, well, wait a minute, that's the same data right here. Like this point right here, that's the same point over here, just being displayed by its own box plot, which we can also see. Oh, there's the box plot. I don't know why I didn't see it for a second. But you have the box plots here. There's kind of stacked box plots now. I guess you could call them that. Would an outlier be like a record holder? It'd be a really slow... Well, it could be a record holder if the outlier were to be down here. So if the outliers were to be down here, they'd be record holders, where this was like the slowest winning time. So that'd be I think that race had a lot of mud on it or something. So that was the slowest winning time at a distance of 1.5. So over on the right, you have side-by-side box plots, and over on the left, you have stacked histograms. Now, there are box plots here, so I guess it's stacked box plots too, but they both display bivariate categorical data. The bivariate nature of this, I want you to put either QQ, QC, or CC. So, first person 20 points. Would this be QQ, QC, or CC? Who's got it? QQ, QC, or CC? What would it be? QC, Jack, you're right. These are quantitative because they're histograms, and they're categorical because they're doing histograms or box plots because of categories. The Q is because they're histograms or box plots. Histograms and box plots display quantitative data. If you have stacked histograms, you're doing just a category. Each one is a different category. If you have side-by-side box plots, each box plot's a different category. So the quantitative is the winning time, which is what they're displaying, and then we're breaking it apart by category. A mosaic plot right here, mosaic plots, are they QQ, QC, or CC? A mosaic plot is a mosaic plot QQ, QC, or CC. What is a mosaic plot? First person 20 points. Who's got it? What is a mosaic plot? You're right, Hannah. It's CC. Let me think. Hannah, I've given you the points. It is CC. It's two categorical variables. Let's see. Who have I not given points to yet? First person say me, who I haven't given points to, gets their points, because everyone's saying CC. Say me and you get the points. If you haven't gotten points yet. First person only. It's Sophia gets the points. Nice job, Sophia, right there. You're listening in. Mosaic plots are categorical. Last question right here. Not done for the day, but last question on this. A scatter plot, which we haven't gone into detail yet. A scatter plot is a scatter... You know, Keaton, what's up? Is a scatter plot... So, Keaton, you got the 20 points, definitely. Is a scatter plot going to be QQ, QC, or CC? Is a scatter plot QQ, QC, or CC? QQ, you got it. QQ. So, first person to say me now gets the points also, because I'm running out of people. We might have to do this at the end of Friday. Who gets the points here? First person. It's QQ. These are both quantitative variables. Taylor, you get the points right there. Nice job, Taylor. You're listening in. And you should know that a scatter plot is a bivariate relationship of quantitative variables. Keaton, you got the points. Keaton, you've got the points. Remember, you can only get 20 points on Fridays. Monday is what we call it. Mega Mondays. Maybe I'll wear my Mega Man shirt on Monday for Mega Mondays. But Monday is 50 points, and Friday is Frenzy Fridays, where a bunch of people get points. So we have right here that this is a bivariate relationship. You bet some Mega Man right there. I'll try to remember to wear my Mega Man shirts on Monday. So let's go. I can't do my Mario today. Wario. So yes, we learned some stuff right there. Let's hop back to the notes. We are going to do a little chapter 5, and it'll be very important. So let's hop to the notes. Okay, we're back to the notes. Okay, there's the winning times. That graphic's wrong. I corrected it, though, so very sorry about that. Chapter number 5. The last few days, we've only covered one chapter. Today, we have done 2 complete chapters, very strong, very in-depth discussions on them. And now we're going to do a tiny bit with our last 16 minutes. Here's the biggest thing I want people to know. We start on time and we end on time. While we have fun in here, we do stay very focused and get things started. Stat Nation for the win. Elizabeth, you definitely got your 20 points. We start at 9, and we do our little bit of housekeeping to get the class going, and then we go right up until noon. So don't leave until noon, because I could be saying very important test-related stuff up until noon. So don't leave until noon. That's a key thing. Don't leave. And the points might even get more generous as time goes on. You notice now you got to be here as being like, hey, I want those points, Brian, because you're probably listening into what I'm saying. And I'll take that right there. Another person who's listening in right now, say me and you got your points. I'll yell out your name. I'll say your first name. You'll get your points. Who's got those 20 points? Remember to email me that you got your points. That's how you get these 20. Me, William, you got your points. William already gave you points, right? So Brooke, you also got your points. There we go. So remember, I'll say your name. That's when you get the points. You can only get the 20 on the Frenzy Fridays. I need like a title card for that. Yep, you got it. And Sarah, thank you for staying. You're still getting the Streamlab points. You're still getting those Streamlab points. Remember that. You're still getting the Streamlab points. We'll be covering all the information for Quiz 5, Part 1 today. I can do that after class because that's a really tough one. We'll do that in office hours. We'll do that in office hours. So great stuff right there. Good stuff. You guys are staying on track. You ready? Here we go. I'm going to do the most important thing. This is going to be a kind of speed run of the whole, like, chapter 5. This is going to be a speed run of all chapter 5. I'm not going to speed run screen, but we're going to speed run chapter 5. You ready? This is like Cliff Notes version. So this is going to set our stage for Monday when we go through it more slowly. Sometimes we do that. We do the lecture quickly, and I might move the assignments back, which might put multiple assignments due on one day. So there might be multiple assignments. You might have 2 assignments due on a day. So take a look at them and get your mind ready, because we might have multiple assignments due. It's just with the weekend, I can't teach on the weekend. And then on Monday, we're obviously going to cover like chapter 5 completely. So you might have multiple stuff due. And I'll probably put the note-taking quiz for Tuesday. So the note-taking quiz, there is a note-taking quiz due tonight. Make sure to do it. Very quick and very easy. Here we go. Okay, in chapter 5, we're now focusing on normal data. In chapter 4, we were more focusing on skewed data with box plots. But now we're going to use the normal model right here to focus in on people's heights if they're normally distributed. And now we have the mean and the standard deviation. You remember how we said the mean and the standard deviation are used for normal data? Well, now guess what we're doing? We're going to use the mean. Where's the mean at? Wait, average of height of men. Oh, there we go. It says average. I thought it said men instead of mean. And standard deviations. That is the mean right there. It's saying average, which is the mean, and we have standard deviations. So this chapter's main focus is to get your brain ready for Monday, especially. The main focus of this chapter is using the mean and standard deviation for normally distributed data. What do I mean by normally distributed data? Data that looks like this. Normally distributed means it's symmetric and unimodal. So there's your one mode, and there's your symmetry. And what are we going to use? We're going to use the mean, which will be represented by mu, and the standard deviations will be represented by sigma. I'll put the other note in here. You can also represent them by y bar. Technically x bar also. So don't worry. I know it's fine if you use x bar, but I like y bar. And then this could also be s. Another 20 points. What is the difference between mu and y bar and sigma and s? This is a review question now. Sigma and s are both standard deviations. Y bar and mu are both means, but one represents this and the other represents this. What is the key differences between them? Why do we have mu and why do we have y bar? Why do we have sigma and why do we have s? They're different variables. Yep, they definitely are. But why? Sigma is for population. Kyle, you're totally right. The ones I have written in black right now are population parameters. You got it right there, Justin. Perfect answer, Justin. Nice job. And so other people too. That's just like really in depth right there. I like it. No, you're totally right. Mu is for population and y bar is for sample. And so if you see mu, it's population mean. If you see y bar, it's sample mean. If you see sigma, it's population standard deviation. If you see s, it's sample standard deviation. And think about how s and sigma have sigma, s, and they're both standard deviations. And mu kind of sounds like mean, so mu is population mean. And then the bar just means sample mean. So great job. Keep your notation. I usually suggest people to write the notation in the back of their notebook. So if you are looking at this right now, in the back of your notebook, you should have S is sample standard deviation. Sigma is population standard deviation. Mu is population mean. And Y bar is sample mean. I've kind of color-coded them here where these are for samples and these are for populations. These two are for the mean, because whoops, go away. These two are for the means, and these two are for the standard deviations. Can anyone take a wild guess for 20 points? The normal model usually displays plus or minus this many standard deviations. The normal model, there are more, you can go out 5 standard deviations, but the normal model usually shows plus or minus this many standard deviations. 3, Nealon, you're totally right. Say me if you want the points. Who's here still watching? Say me. You get those points because Nealon, you already got them. Amazing work. I love you guys are still getting those Streamlab points. So plus or minus 3, you guys got it. Bridget, I don't think I've given you the points yet. Bridget got those points. So, and Whitley, you got those points. Because I don't think I've called the name yet. So try to make sure. And SpongeBob, you got those points too. So Jared, you got those points too. We're just going to keep trying to give away as many on these Frenzy Fridays. It gets crazier as time goes on. Be here at the start, be here at the end. Maybe I'll do some craziness at the start too. So here's the tallest and shortest people in the world. I think, do we blur? Looks like her face is blurred. That's weird. So it's like, it's one of those like scary movies. Sultan, obviously being very, very tall. Sigma is population standard deviation. So sigma just stands for population standard deviation, like the standard deviation of all people, where S stands for sample standard deviation, the standard deviation for the sample of observations we collected. But sigma would be for every single data point, and S would just be for a smaller sample. So what we have right here is we have the very tallest people in the world. But this is why we use standard deviation. Now, I want you to tell me who is objectively taller. And I am going through this a little bit quickly. Please ask questions still. But who is objectively taller, Sultan or Yao? Sultan or Yao? Who is objectively taller? Who is objectively taller? Sultan. This is facts. So Sultan is taller, but who is more unusual for being male or being female? Who is more unusual? And you might think it, because you can figure it out kind of. You're like, well, wait a minute. Imagine if they were the same height. You'd probably be like, okay, it's got to be Yao, because on average, women are generally shorter than male, on average. Doesn't mean women can't be taller than men. It just means if you take all the women and all the men and you average them together, you would see the average of women being lower than the average of men. So if they were the same height, it would be more unusual for Yao to be that height because she'd be further away. And we do have to look at standard deviations too, but we'll see that right here. Here is the thing we need to look at. Good. I want you guys to tell me. So here's their heights. We'll put this here as Y, which stands for the observation. I want someone to tell me how much taller Sultan is than his height. I mean, than the mean. Sorry, he's not taller than his height. I want the difference. How much taller is Sultan? It's a fun name to say. Oh, yeah, well, the problem is when you're that tall, it doesn't work in your favor. Sorry, Sultan. I mean, sure, he knows it personally, but that is the heights you don't want to be. It's just bodies don't, it's not good to be that height. I'll tell you guys something in a second here, because we only got 8 more minutes. I want to stay as focused as I can. 30. Now look at this formula over here. What did you just do? You just did this. You literally just did this. Does everyone see this right here? You just did this. You just found the difference in your head. Now I want you to tell me 30 is how many standard deviations? First person who gets it, and say I already got it if you got it. Like if you give it to me, if you give me the answer, then say you already got it. Like tell me the answer. 30, you got it, Jack, right there. Who's got it? Laura, I don't think I've given Laura the points yet. So Laura, you got the points. So 30 is 10 standard deviations. So this finds a z-score. Does it make sense that a z-score is literally how many standard deviations an observation is away from the mean? Brian is 75 inches tall. What is Brian's z-score? Brian is 75 inches tall. First person who gets it gets the points. Brian is 75 inches tall. You got it. Jack, and then we got to put down Jack. You've already got the points. Nice job. Keep contributing. If I say you got the point, that's quite all right. I'm going to look for another person who I don't remember calling out. Jared's got points. Cooper's got points. And Devin's got points. There we go. People got those points right there. Brian's Z-score is 2. Now, I want someone to write the interpretation of this Z-score. No, keep responding. You're still getting the Streamlab points. No, keep it up. And then you can say, I'm going to let you tag someone next time, Jack. After you do this, Jack, tag someone right now and be like, so-and-so gets my points. Jack, you're going to make someone very happy right here with all your responses. I want you to keep responding. Don't worry. This is why it's Frenzy Friday. At the end, it's just like crazy. It's like, who doesn't have points? I'm trying to remember. Taylor, you just got some points. Tag someone, Jack, and you've given them points. It might be someone who's already got points. But Jack, go ahead and tag someone and be like, oh, there you go. Aaliyah right there. You got the points. Jack just, boom. Yes, I love that. That is so cool. I'm sure Aaliyah is very happy with that right there. So, yes, keep responding. I want you to. I'm just trying to remember names I haven't said, which is tough. So I'm trying to be Tristam. You got some points right there. I'm trying to remember some names. If you're here at the end, you're responding, I want to give you points. And I will need to say your name to get the points. But you can only get the 20 on Friday. So you see that? You just made someone's day right there. We're a class that works together. We got this. Don't worry. That's why I'm giving out more than the first person, because I'm realizing that. Okay, we got 5 minutes. Someone give me your height. Or make up a height, whatever you want. We're in a public stream. Make up a height. Anyone make up a height. Does not have to be your own. Make up a height. And this is for guys right here. 70. 70 would be slightly below average right here, just making up a height. And this is for guys. This would be, oh no, it's above average still. That would be a Z-score of 0.33. So we see 5'9", 5'9". Oh, what would the Z-score for 5'9" be? And these are just made-up heights. Just put made-up heights. Remember, we are. I will say this: don't put your own height in the chat. You can delete it if you did. You can retract the message, just because I don't want to ask personal information on these streams or anything like that. You can go to the button and delete it. You can click over your thing. Try that real quick. You guys got it. You can retract the message. And remember, you can use different names in the chat if you want. I'm just going to remember not to say that. So you can remove it. 4'3", there we go. Yes, which could, I don't know, could be. So 4'3" would be, which some people are that height. 4'3" would be 51 inches. Oh my gosh, that's very, very below. That's going to have, would 4'3" have a negative or positive Z-score? Would 4'3" have a negative or positive Z-score? Like a 7174. I love it right here. I love all these crazy messages right here. And so if you are wondering, everyone do a quick practice right here so you know it. This is our last little bit of housekeeping. Go ahead and try retracting a message just so people know you can do this. If you ever want to retract a message, you'll hover over your own message and just remove it. So feel free to just type a message and then go over it. That's also how you can remove people's messages if someone comes into our stream and we want to take them out. So if you try that right now with something you typed, just hover over it and people are seeing that option right now. You can use that option right now if you want to retract a message. If we do have someone jump into the stream that starts saying crazy things, we can do it also. You got it. Just knowing how to interact here is super awesome. We understand that this would have a negative Z-score. What does it mean if someone has a Z-score of 0? That person is directly on the what? If someone has a Z-score of 0, that person is directly. So if you ever write something in the chat that you want to go away like that, you can just retract it. So don't worry. These streams are public. So remember that, which is fine. Just, yeah, it's just like being in any kind of social media thing. So that's why I was like, yeah, just make up something. That's what I want you to do. It's right at the mean. You got it. So I got 3 more minutes to be serious. Okay, this is, whew. Can I do it in 3 minutes? Dun, dun, dun. I wish I could play my music. I wish I could have like the turnaround hamster appear right now. This is it. This is the biggest thing. 68, 95, 99.7. These are numbers you should know instantaneously. 68, 95, 99.7. 68, 95, 99.7. Even better yet, to know things like 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. Now, just so you know the craziness, that I have done by teaching this class way too much. Way too much. That sounds bad. This is how we're going to end class, just so you can know why these numbers are so important. Brian is now going to show you that he can guess the percentages on the curve. I do have a thing to help me so that I can see the answers. I'm not going to look at the answers. But I want someone to give me a number on this curve, and I'm going to tell you the area above it. 68, 95, 99.7. You know what's going on. I will give you the 20 points if you... Jared, don't say Rick. You're going to crack me up too much if you put Rick and Modi. -1. -1's too easy. You guys are so easy. That's so nice. If you put 68, 95, 90.7 in the chat, you get the 20 points for today. I might do that at the end. You never know. Okay. So you guys want the area above -1. So the answer will be displayed down here. Here's the area. So the area above -1 is going to be, I might be able to, it's going to be about 84%. So above -1 is about 84%. More specifically, it's going to be, let me just double check my head. So it's going to be, that's how I do it, I just tap my head. I just want to be decimal place accurate. That's what's getting to me. It's, I could round it to 84. That's not fair though. It's, wait, 68 point, is it 6? So it'd be 3. So 34.3. Oh, wait, is my brain breaking? Wait. Why did I say 84? No, that's right. It's 84. I think it's 84 point. Let's go 84 point. Why am I being so decimal accurate? I'm going to go 84.3. Ah, it's 84.1. Dang it. It's 84 point. Oh, you guys, yeah, you might know some. No. So it's 84.1. Now, just so you know, it has to be more than 50%. Because let's do a super easy one. You ready? I want everyone in the chat, if you haven't gotten your 20 points yet, what is the area it's going to tell me right below here? You guys can figure this one out. This one, you got this one. What is the area here? You guys should know this one. We've got, I'm going to do this for 1 more minute. We've basically ended class, but I get 1 minute of this. This is my prize at the end. What's the area here? You got it. That's 50. We should know that. And you know how I said above here is 84%. So what would be below here? If 84% is above here, what would be, we can round it, what would be below here? What would be below there? If 80, you got it, look at that. That's basically 16. And that's using the empirical rule. Because if 68%, remember we said 68? If 68% is between here, which is 68, this gives the exact answers. You're like, wait a minute, that's not exactly 68. It gives the exact answers. If 68% is between there, what would be outside of there? 68% between, what is outside? 68% between, what is outside? 68% between, outside would be what? If 68% is between, 32, you're right, Jared. That'd be 32. That rounds to 32. So if this is 32, then what would half of it be? Do you see how this is now half of 32 right here? Then this would just be 16, because 68% was between here, 32% would be outside of here, and half of that would be 16. We'll be covering this a lot more in depth. But now, just to show you how much I've done this, please give me a number that is not on the empirical rule. And there's some ones you could pick that would be very hard. Who can give me a number not on? This is my last thing. I know I went over by 2 minutes. Very, very sorry. You can leave right now if you want. But pick a number that's not on here. Pick a number that's not very obvious. Oh, 5. Well, if we do above 5, that'd be 0. If you pick that, 5, that'll be 0 because there's no area, or the probability is so small it's not displaying it. -2.8, that's a great one. Above -2.8 is pretty much like 0.999%. Wait. That'll be above that. It's going to be better to do the below because it'll be a very small area. Below this, and there are complements, more on that later. Below that, it's less than 1%. And it's a little bit more than like, I say this is let me double check, 0.005. Gosh, I want to get it right. No, it's going to be 0.004. Ah, it's 0.003 rounded. Dang it. It's 0.003 rounded. That's 0.003 rounded. So I said 0.004. That was my guess in my head. My guess was 0.004, and it's 0.003. Did anyone put another number for me to guess? What's another one? Give me one more. 0.5 is a very tough one because that's towards the middle of the curve. I'll do 2 more. You can leave. So that was my guess, was 0.004, and it's 0.003 rounded. 0.5 is a very tough one because it's towards the middle of the curve. And so we're just literally going to graph below this. Sure. Obviously, wait. Oh, -5. I was trying to do 0.5. So this has to be more than 50%. It has to be less than 84% because below here is 50%, below here is 84%. I'm using the empirical rule numbers. It has to be a little less than 75 because I know a number you guys don't know. I know this one. I believe it's that. That's about 75. You see, that's very close to 75. That's a number I'm telling you that I know right now. So the answer here, if you look at it, if you watch, this has to be less than 75. So this one's a very tough one. If I get close to this one, I'll be very happy, but it has to be between 50 and 75 because below here is 50. And then I showed you I know this one. Is it that? Below here is 75. So the answer has to be somewhere between those. So I'm going to guess 71.2%. Ah, that one's tough. That one's super tough. There's ones I know closer. Yeah, and your guess is not that bad, Jack. So, oh, you got it. Look at it. Zulon, you were the most accurate. Zulon, I'm doing it. I'm breaking the rules of Friday. Zulon, you get another 20 points because you were so close. You beat Brian. You got a better guess than Brian. You get an additional 20 points. Email and say, Brian, I'm the only person who I broke the rules. I got 40 points. You got it just for taking a guess, and that's awesome. Let's do it. Yeah, let's do so we'll do that. We're hopping into office hours right now. So hang around. Let's do this. So once again, you don't have to know these things perfectly. We're going to talk about this more. Yep, email me if you got the 20 points. That's how you get the 20 points. You have to email me. Try to do it on the day of. That's the best way. So that way I don't get like a ton of emails at the end and be like, Brian, I got 200 extra points. Try to email me. Yep. Awesome stuff. Check your points at the end. Great questions. I know I'm sorry we went a tiny bit over. This was a little bit of fun. You are free to leave at noon. I have fun doing this. Like, I really like the guessing game here. There's ones that I know. Like if you guys were to say 1.645 and you want the area below that, I'd be like, yay, thank you. So that one would be 95%. And more specifically, it's that. So that would be 95%. There's 95. If you guys gave this one, if anyone's ever taken stats, they probably know that one. This is going to be 97.5 right there. And then if you guys said this one, 2.3263, that one's going to be 99%. And then 2.5758, that'll be 99.5%. And then 1.2816, or is it 1.2? It's bugging me. Is it? That should be 90%. Oh, is it 1.6? It is 1.6. Gotta rememorize that one. I want to know them all as many decimals as I can. And then I need to review. Let me find out the answer. I can find out the answer to it. The IQR, I think it goes from 0.673. That's the middle 50%. It's 0.674. Why don't show me extra decimals? But it's 0.674 is the IQR. So since I knew the z-score for the IQR, that's when I typed in this right here. I said that 75% would be below that. And there's a decimal we're missing. It looks like it's something like this. So that's I'll try to memorize that better. I try to keep them all in my head. I know them pretty good and pretty well. But that's how I know these answers, because I would know, since this is the IQR, it's the numbers between here is the middle 50%. And there's another decimal we're missing. There we go. So it's that. That's the middle 50%. So below that is 75%. Because you can see here, this is 25%, this is 50, and this is 25. That represents it. This was a very complex thing. I went super crazy at the end right here, but I just want you guys to know that I'm using kind of empirical rule numbers. This all goes back to this slide right here, where you learn the basics of the empirical rule. That within 1 standard deviation is 68, within 2 is 95, within 3 is 99.7. And then Brian knows additional numbers right here that helps him solve these questions when we ask them. Brian knows the z-scores for the middle 50%, the middle 80%, the middle 90%, the middle 95, the middle 98, and the middle 99. 2.5758 is that one right there. If 0 is 50 and 1 is 84, then would 0.5 be? You can't average them. That's a great, Jack. That's an amazing question. So because the curve is not symmetric, you can't average them. Does that make sense? Because, and I'll do my drawing here, which I like to do for this example. So let me zoom in on it. You asked an amazing question that often comes up. Try to remember to ask this again on Monday, because I know we're in office hours right now. So I'm just kind of expanding upon this, and then I know other people had questions too. But you're talking about this area right here. Let's do the two of them. You're talking about area A and area B. So if you look at this, if this is 2 bars of gold, would you rather have bar of gold A? Would you rather have bar of gold B? What would you rather have, bar of gold A or bar of gold B? And this kind of points out why we can't just cut the areas in half. And this deals with, we can do it down the middle of the curve. Yep, you'd want A. I mean, if you like gold. So, and it's like the same gold or not like fake gold or something like that. But the area in A is bigger, so you can't just divide the numbers like you. Don't worry, it's a common question, and it is in the notes somewhere. It talks about you can't just divide the areas between the two of them. Yeah, it is right here. It is. This is exactly what you're saying. It is in the notes. So everything I kind of do is also in the notes, but I like to show the visual representation, lest students are like, he just reads the notes. So Kelly's going with B. No one took B, so Kelly gets B. Everyone else has to fight over A and divide it. Kelly made the smart choice. I'm like, I will take B. No one else is going to take it. So I'll just took it. Boop, got it. We're dividing A up between like 5 people, so Kelly gets the most right there. Yeah. Does that make sense that you can't just average it? Because it is true that below the mean is 50% of the data. That is true. And then below here is 84%, because in between here is 34%, because that's half of this. You can cut it when it's symmetric. If you notice right here, these are 34 each because it is symmetric. If you look at these 2 bars of gold, if I change my drawing now such that I have bar of gold A and bar of gold B, where we have 2 different bars of gold, these are the same, where they're cut down the middle as best as Brian can draw. And we'll do some space pen because space pen is awesome. We have bar of gold A and bar of gold B. That space pen went to the rescue. Now these are symmetric, and we know below the mean is 50%. And now that we're at 1 standard deviation, plus or minus 1 is 68. Cut that in half, you get 34. And yes, and you can break down the whole curve using this. I'll do that on Monday. And you've heard a lot of the lecture. You've probably heard 30-40% of Monday's lecture in like 15-20 minutes. It's a good setting the pace for Monday. Now, how would you know the area below? How would you know the area below 0.5? How could we figure out an exact? Well, we know it has to be somewhere between these numbers. We know it has to be more than 50, and it has to be less than 85. If you look at this, see how it's more than 50? It has to be more than 50, but it has to be less than 84. I think it's 85. It's less than 84. So it's somewhere between 50 and 84. I also narrowed it down further with an additional number I knew that you are not supposed to know in this class. But you go over to here. The curve has a mean of 0 and a standard deviation of 1, and we go to this button because we're going to put in a value. So we want to go below the value of 0.5. There's the visualization. I could remove these just so you're not wondering. They're not being used. Only the one being highlighted is used. We said the area had to be between 84 and 50%, and the area is. This confirms that our estimate done here on this page, that we said it had to be more than 50 and less than 84, because we're talking about from here down. Just to make it very clear what the area is that we're trying to calculate, we could simply do the following. We could say the area we are trying to calculate is this area on the curve. If you understood this example, you are super on track for Monday. Like, you're way ahead of the game. So did this make some sense to people? Like, does this make a little bit of sense right now? Or like, okay, I get what he's doing. He's trying to figure out what percent of the curve that is. He's just trying to say from here down what percent of the curve that is. And the empirical rule allows us to get estimates with known numbers on the curves, numbers that we know, known numbers. That's what's going on. And I think Ben had a question. Great job, Samantha. People getting tons of points. It makes a little bit, and this is what it should. If it makes a little bit of sense now, that's good. Monday, we come back to this. We go way more in depth on Monday. We won't fly through it. But we covered, if you look at where we're at, I even covered how to use the applets. So the applets here, we got all the way, here's the percentages. I'd say we covered 60-70% of the lecture. So if you understood this, the only thing we really didn't cover is this. So we covered like 75% of the lecture. So if you're like, whoa, that's so much, my brain's breaking. Don't worry. On Monday, we're going to take like an hour and a half and do it. On Monday, we'll spend like an hour and a half going through it. So that was a setting of the pace. Ben asked how to get data into Jump. Ben, which quiz question or homework question are you working? But we covered so much of the data. the last part is how do you know if something is normal? And you can do 3 ways of doing that right here. It's normal quantile plots, histograms, or goodness of fit test. That's the last stuff right here. And that's obviously not normal. Don't use the mean and standard deviation. Use the median and IQR. So we will come back and we will do this. We'll talk more through this. Ben, if you can tell me which question you're working, I'll talk about how to get that one into R. So how I could get, yeah, and then are you doing a specific question? Be like, Brian, I am doing quiz this, chapter this, and yeah, let me pull up, I'm going to pull up MyPearson in the background here. Just be like, I'm doing quiz 2 or something. I'll pull it up, and we will do that. Let's see. Quiz 2, question 5. Tell me if I get the right one right here. Okay. So, and this is something, don't worry, you didn't know this. The quizzes don't have the same order to them each time. So I'm going to look through and I'm going to find the one that you're doing. Can you tell me the start of the question for quiz 2? Sorry, like you wouldn't know that I wouldn't be able to tell the order. So can you tell me the very start of the question? Like, is it like a company wants to look at or something like that? Tell me the very start of it and I will find it and I will tell you how to get that data into R. And you are, don't worry if you're not using R, but learning how to use R, which is a very like, it's like if I was like, I'm going to teach you how to water ski, be like, ooh, that's going to be tough. Learning how to use R is a little bit tough, but it's a very important skill. You do not have to know it for Stat 201, but if you want to learn it, I'm going to help you out with it. So, and I'm more than happy to help out during like office hours, and I do like showing a little bit of R in class. I like showing like, hey, here's how we do it in the other classes. So I'm pulling up the quiz right now as we speak. I need my Mario music. All I had to do was restart the Go XLR. But I was about to start the stream and I was like, it could crash things. I don't want to crash. The one that asked for the 5-number summary. Oh my gosh, how many questions are there on this? Let's see. Tell me if I have the right one. Any question in chapter 2 where it gives you a set of numbers? Yeah, okay. So we should have this right here. And please tell me if it gives you a wrong answer. But I have a question on no conditions. Are the types of the variables quantitative, categorical, identifier? Zulon, you are totally right. Thank you for the question. It is quantitative, categorical, and identifier. Those are the 3 types. The 3 types of variables are quantitative, categorical, and identifier. Okay, here's how you get the data into R. It's a little less fun. There's a few ways to do it. I'm gonna do it this way for now, and I might make a video on this. So you can save it to Excel, and then save the Excel file as a CSV. If you have a very long file, you know, we're gonna try something right here. You too, Zulon. Have a great weekend. We're gonna copy it to the clipboard, and I don't know why it doesn't put the commas. MyPearson. What are you doing? It says these are going to be comma delimited, but they're not. It wouldn't? Yeah, if you saved it as a CSV, I'll tell you how to do that. Your issue might be the following. So here we're going to talk a little bit of R for a moment. Please ask questions if you have it. See you guys. So what you need to do is you need to do this. Just call it data and type read.csv. So with read.csv right here, you need to make sure you have your session, set working directory, and choose directory to where you have your data saved. So Ben, I want you to try this right now. Go to session, set working directory, choose working directory, and choose the directory you are using. So make sure you go to session, set working directory, and choose directory, and then choose the directory you're in as your working directory. So make sure you're in your proper working directory. So once you've done that, that's where you will now see your files. So if you click over here to your files, this is the files you'll see, and you should see the Excel file in there. Now, it should have a .csv extension. This is one way to do it, and whatever it's called, like you say question 5 or something like this. Let's say you call it question 5.csv. Now, this is going to give me an error right here because I don't have a file called question 5 CSV. It has to be in quotes like this. It's just saying there's no file. It can't find it because it doesn't exist. But this is what you would do. Tell me if that works, Ben, and then I'm going to show you the other way. And I'm going to try to figure out a quicker way to do this. Like, I'm going to try to teach myself something here. So I'm going to explain this while Ben's giving that a shot. You can also save your data the following way. So I'm going to make a vector of data right here by pasting this. And oh, that's interesting. Whoa, that kind of worked. You have to put commas between all the values. I don't like that it's all spaced out right here. I wonder. Hacker Man or Engineer Man, that's what he's called. He's not Hacker Man. This is not going to work. Yes, I thought it would do. Let me see. I'm going to Google something real quick, Ben, while you're trying this out. Let me Google something real quick because I saw a guy do this on YouTube. That means I can do it. So let's type this in. How to add commas after all values in R. So is there a quick way? Add commas into number for input. No. How to insert commas between numbers. Oh, that's not fun. They're doing it that way. They're doing a paste option. Give me a second. Let's see. Numeric value with thousands separated in... Add comma between numbers. They've got it for Python. Come on, Python. I would be so happy. So let's do here quickly, or let's do here, what is it? Quick command, enter commas between values in R. That's not what we're doing. I'm going to give this another... Keyboard shortcut, that's what I'll call it. Keyboard shortcut, comma. It might be an add-in. Add-ins, it's an add-in or something. I don't have that. Dang. Let me look at chat. I can't... I will give someone another 20 points if you tell me how to do that. Yeah, Python's best. I'm having a rough time making contingency in R right now. You're trying to make a contingency table? I'll explain that in just a second here. It worked. Could you show me how to do it from copying to clipboard? Yeah, if you copy to clipboard, which will work for smaller stuff. So I'm going to show that and then I'm going to answer Isaac's question right here. If you copy to clipboard, then what you will do is you will simply, this is the best way I think, you will declare what you want to save into. So I'm saying I want to store something into data. The C represents here concatenate. Now I could just type values like this, and then those will be stored, just so you can see what I'm storing while I do it. This is now going to create that vector data, which has those values in it. So that just creates the comma separated values. So literally, what do I have? Values separated by commas. And this is actually a function, like the read CSV is a function right here. And then it's taking all the values. Functions are just things that do things for us. Read CSV, reads a CSV file. Concatenates, joins things into a vector. So what we do right here is once you copy it to the clipboard, you could go inside of here and paste it. Now, the problem is, what do you need? You can type it very quickly, Ben. What do you need between all of your values in this concatenate? To register all the different values, what do you need between all the different values in concatenate? Every value in a concatenate must be separated by a what? Every single value in a concatenate must be separated by a... So this is a good idea for smaller data sets. Commas, you got it. So you just go right here and you do comma. Luckily, it auto goes to the end of it. Now, there's not a comma here because that would be the last value. This is kind of a ridiculous way to write it. You could go and do this. Oof, I don't like the way that looks. R reads through spaces. That's so horrible. So I don't like that. You could fix it the following way. You could paste the data. You could go here. Good. Then you don't want a comma there. You could go here. You can put parentheses around it. If you highlight something and do parentheses, I don't know if you know this, Isaac, about R. It might work in Python. You can highlight code and you can do a parentheses. You could then concatenate it. Then you could start deleting and we don't get those horrible spaces. So just if I want to make it look better, I can clean it up. But I wish there was a quicker way that I could... No, that won't do it. There's an auto format in R. Got excited. I was like, wait a minute. There's like the reindent and reformat code, and I thought it might do it. We'll give that a shot. But this code right here runs the same as this, as would this code right here runs the same as this. And so now I've just put, and it will read through it. It will read the whole thing. So if you run this line of code, it'll read to the end of it right there. Does that make a little bit more sense there? So after you run that and then you type summary, yeah, you got it. So now you just go summary of data. It's stored into data. So if you, we'll bring screen just a little bit here. You can run summary of it. You can even run things like IQR. The IQR is going to be 20, no. The IQR is going to be the difference between these two, which is 225. So if I change this to IQR, oh, it's capital IQR. I always forget that. It's capital IQR. It's 225. So we've got all of this right here, and you could calculate that by Q1 and Q3, their distance. Does that make sense? And so you want to do summary of what you stored it into, because this is being stored into data right here. So the data object is in your global environment. So all of these are doing the same thing. Like if I did have something called question 5 saved as a CSV file, would store it. Is that making sense right there, Ben? How you doing on that? I think you're doing pretty well. Great job, Ben. I'm glad that Isaac was here yesterday being like, yeah, do it. Yeah, and if you notice, it's not too bad. Anything you want, you can get instantaneously. Like, what's the range? Boom, there's the range. What's the standard deviation? There's the standard deviation. What's the mean? You can even do a trim on the mean, which we don't do this in the class, but you could trim off 10% on each side. So here is the trimmed mean. If I could type, there's a trimmed mean. I wonder if I do 50% trim. Yeah. Then it's just the median, probably. Yeah, it's the median. Because I trimmed 50% on each side. Is it going to get mad if I put 60? Or is it still reports the median? Because, I don't know, it's still just the median. You can't trim more than every bit of data on each side. We don't talk about trim mean. Don't worry about it. It's just you delete a percent on each side and you get the mean after trimming. So trim mean would account for outliers. You don't need to know that for this class. It doesn't account for them. It removes them from data sets. So if you had outliers, you could do a trim mean of 5% and remove off the most extreme high and low 5%. And that's what we call it a trimmed mean, because it trims off that part of the data and then finds the mean, removing 5% on either side. And if you removed 50% on either side, you would only have the median because it would leave the middle number. I wish it gave an error. It said, warning, you can't trim beyond 50%, because what's the point? Because you'd just be down to the median. But obviously, there's a lot of ways to do stuff. This is also in Jump. You can go here, and you could do the trimmed mean in Jump. Just going here, trimmed mean, and you see right here the percent to trim. There's a 5% trimmed mean, and it'll give you a trimmed mean of 5%. So we're doing the same thing here by doing that line of code. So lower quartile is just Q1 and upper is Q3. You got it. So when you do the summary, and I'm going to do Isaac's question here. When you do the summary, this is Q1. That's the lower quartile. And then the upper quartiles here. You can also do quartiles. You can do quantiles. I hate that it's quantiles. I wish it was, well, quantiles isn't always 25%. You can get you can do data. The first argument is what you want the quantiles of. What will it do? Oh, it gives you, look at that. That's so cool. I rarely run it that way. So it gives you the 5-number summary right here. But let's say there's a quantile you want that it's not displaying. You could do this right here. So you can get a quantile it's not displaying by simply saying, by default, it gives you the 5-number summary for the quantiles. And then if you want a quantile it's not displaying, which the 10th would be between these, if you got a quantile there, you would just input the quantile you want. Like, what is the 10th percentile of the data? Boom, you got it right here. Great question. So if you can't tell, this is why I like coding. And no one has to code in this class. No one has to code. All of these things can be seen in Jump also. Jump will get you it very quickly. If you notice right here, here's the 10th percentile in Jump. This is a different data set, but it's giving me the 10th percentile. And I bet if we go here, the custom summary statistics also does it have quantiles? Oh, you see, this is why code's a little bit better, because you can't get the 4th percentile in here. I don't know if there's a way to edit this. You might be able to get it in Tabulate. But if you wanted the 4th percentile with code here, you could simply go and edit this code and do 4th percentile. So sometimes coding allows for a little bit more options than you can get with just using Jump. Coding is like design your own adventure, which is kind of scary. It's like, do you want to go on a cruise that's planned out for you, or do you just want to like rent a cruise ship and just take it all around the world? That's what coding is. You're like, oh my gosh, you could do so many crazy things. How comfortable should we get using Jump for the class, because I'm not that tech savvy? I have a video, great question right there, on I'm trying to make new videos this summer. And if you want, go to the videos and like them. You don't have to. But you can check out any of the videos I've been making right here lately. They're causing me to lose subscribers because people see all these new videos in their feed and they're like, what channel? Wait, this is that class I took 5 years ago with Brian Stevens. But then sometimes someone hops in, they're like, hey, Brian, glad to see you're still at it. So I'm trying to do the Excel ones will have a green background, but if you look at these right here, bring back up my chat. I'm trying to make new videos on how to do things inside of R or how to do things inside of Jump. These are very, very, very quick videos. I know they're like 1 minute and 5 seconds, 1 minute and 4 seconds, but they're basically 1 minute. I think if I'm only off by a few seconds, that still counts as 1 minute because I'm like, hey, here's what we're going to do. So if you were to move we got 11 people, that's so cool. If you were to move here's what we're doing and here's what we did part of the video, they're all right at a minute. This one I broke the rules a little bit. It was just a lot to go through. That's a very hard topic to do in 1 minute. And I wouldn't say these are like they're obviously not the most in-depth tutorials, but I think people want to know how to do something very quickly. So that's why I like these 1 minute things. If you watch them, they'll show you how to do anything inside of Jump in 1 minute. A lot of people say Jump is not the hardest part of this class. So I'm trying to put out 4 videos a day, and I'm trying to make it related to the topics we're doing. And I'll put them all in playlists, probably like chapter 1 Jump tutorials and stuff like that. So you can see like a tutorial on how to do each thing. So I'll probably be making new playlists. But this is just my project right now, just trying to get these new videos. So don't worry, William, you'll be fine. Did someone want me to do a quiz or things like that? You know what we could do? We could do chapter 3 homework and quiz because that one is coming up. Do you guys think we should do chapter 3 homework and quiz and maybe chapter 4 homework and quiz? Put those in the video here so people have them for the weekend. If you stay, you guys get to vote on what you want to do. You guys are the ones here. You guys get to pick the path. Neelan says, yes, let's do it. Homework or quiz? What would you guys like? Let's get this knocked out. If you're staying, remember, stay for office hours. Get your work knocked out. Best way, if you just work from like 9 a.m. to 2, you should be pretty much done for the day with stats. And then like 3 weeks later, you're done with stat to 1. You got an A. You're like, hey, 3 weeks. Just did some morning work. Got the rest of the day off. Got my weekends off mostly. I mean, you still need to maybe look over your notes a little bit. But this will knock out a lot of your work and it'll make a lot more sense. Okay. So let's get serious here. Let's hop back into Assignment Manager. Let's go to, I guess homework 3 would be a good place to start. Homework number 3. Let's go to preview, homework number 3. Okay. What do we have right here? We have a contingency table. Now, there's something I really, really like about this one. It's better when it's on the quiz. No, maybe it's not the one that gives you the answers. Okay. So, good job. Good to see you, Shady, again. And so now we have a contingency table showing us the bivariate relationship between someone's ethnicity and their admission decision. Now, we'd hope that these would not be contingent. That would not be good. We don't want someone's ethnicity to explain or be associated with their admission decision. That's not a good idea. Now, we got to be careful here. We have the percent of all applicants who were Asian. So now when we look at all applicants, they were 1,233. So that's all the applicants. And then we have to look at what percent were Asian, which is 418. So 418 divided by 1,200. There we go. We'll copy this number and needs to be a percent. So we're going to have some fun with this. This has to be a percent. If you get it wrong because you didn't put percentages, just tell me. Enter. Enter is our magic trick. We can do nice and quick. Kelly, amazing job. Thank you, Kelly. Kelly's right. Work along with me. Practice this. If you're getting the answers, you know how to do it. Now we got to be careful. The percent of students accepted. Can I highlight that? The percent of students accepted. So now we need to go, given someone was accepted. Thank you so much, Carson. Carson, thank you. Thank you. So good to see you. Carson was in here just a while ago. So we've got so much new fun stuff. Carson, that was completely random. You know what's up. You got it. Wolves are cool. So completely random. Love seeing you guys in the chat. Julio said he might drop by. I was like, yes, do it, Julio. No, love you talk a little bit to the class. It might be 36%. Let's check. Let's go. So of the students who were accepted, because the percent of accepted students who were Asian. Oh, wait. I might have messed it up. Wait, the percent of accepted students who were Asian. Okay, yeah. So of the accepted students, given someone was accepted, what's the probability they were Asian? So you got to be I know. So it's very easy to make a mistake on it. But of the accepted students, given someone was accepted, what's probably they're Asian? So we go right here and we go to 71 Asian, 197, and that is it right there. Amazing job. Kelly got it right. And that is the rounded version to a percentage. We got it right. Oof. Hold my breath. Every once in a while I'll make a mistake, but not today. Not today so far. And now we have the percent of Asians who were accepted. So given someone was Asian, now it's not always the first one because I could say what percent of accepted individuals were there for Asian. That is given Asian still. So this one is doing it differently, saying the percent of Asians who were accepted. So given someone was Asian, because now we're looking at within the Asians, what percent were accepted. So we have to go here and do all the Asians and then do of all the Asians, how many were accepted. So there we go right there. You guys, and did you see it? Of all the Asians, which is 418, what percent were accepted? So this is how many were accepted of the 418 total because we're looking within here. So given someone was Asian, what's the probability? Yes, great job, Kelly. It's a little bit tricky, and I have made mistakes on this. I might make a mistake today. You never know. But given someone was Asian, so we're doing conditional distributions if you can't tell. We're saying given. This is now a review of the early part of lecture. Given someone was Asian, what's the probability they were accepted, which would be going this way, conditional distribution. So it's going to be 17% right here, 17%, because I did 71% out of the 418. So 71 out of the 418, which is 17%. Rounded, did I do it right? I get a heart attack every time I hit enter on these. The percent of all students who were accepted. So now we have to say all students is 123, and this is actually just a marginal distribution because it's for all students, and we're just looking at the percent of all students who were accepted. So this is down here. It's a marginal, which is the total. So it'd be weird. This is not the way I would say it, but you could say given the total students, it's a marginal distribution. I would not say it as a conditional because you're not going within the variable. You're just looking at the margin. So all the students who were accepted was 197 out of 1,233. And that's 16% rounded up. So that's very close. Did I get it right? I'm getting scared. I didn't do my enter trick. Hey, we got it. That question's not so bad, but we just got to the hardest question in this topic. This is another contingency table. Great job, Kelly. If you get 5 more times that points, you'll have the super. And if you get like 7 or 8 more times that, you'll have the ultimate. So staying for office hours is probably how people will get to 3,000, but you're on track for the 2,000. Okay. So what do we see right here? We have at the very top a contingency table. I know, I like it. A lot of people are going to get to that 1,000. If you attend class, there's no way you shouldn't get to that 1,000. And I feel bad for people who have like jobs and like I understand. It's just I really believe in attending live, and people can still do well if they watch the videos, take notes, stopping it. I had a student whose name I didn't know one time in my online class, and he said, I watch your videos twice, and class was only an hour and 15 minutes, but he said, I watch your videos twice at 2 times speed, stopping the video when I need to take a note. And so he's like, yeah, I usually spend about 2 hours a day watching the video twice at 2 times speed or whatever. And like, he had like hundreds on the tests. And I was like, he's like, yeah, it really helps. I'm just sitting there very focused. And I was like, I don't know if I could do that, but it worked for him. And hey, you have to figure out how the class works for you. Okay. So we have 2 variables here. We have what actually happened on a day, and we have what the forecast was on the day. I want you guys to tell me, because this is a problem that totally stumps people. On all of these days right here, I want you to tell me what happened. On every day I have highlighted, what happened? You have to say, you can kind of say it. I think I'll know what you're saying. I would need someone in the chat to tell me. On all of these days, what happened? On all of those days, what happened? Who knows? We have to understand what this graphic is telling us to answer the questions. On all of those days Brian has highlighted, it actually what? Here's a hint. It rained. Like it actually rained outside. Great job, Kelly, right there. On all of these days, it actually did not rain. Like you went outside and it actually did not rain. But what's the difference with these days? What's the difference with these days? All the days Brian has highlighted here, and here's the hint. All of these days, what happened? Be careful. Be very specific. On all of these days, and there is an overlap. Don't worry about the overlap yet. On all of these days, what happened? Be thinking it or saying it if you're watching this video. On all of these days, what happened? We're waiting for someone in the chat to tell us what happened on all of those days. It was forecast to rain. And Kelly, that's an amazing answer. Amazing job, Kelly. It was forecasted to rain, and it may or may not have rained. Like on these days, it was forecasted to rain, and it did rain. And on these days, it was forecasted to rain, and it did not rain. Now look at this. On all of these days, it was forecasted to not rain. And what happened here? It actually rained when it was not forecasted. Because you go down on the actual, it actually rained when it was forecasted to not rain. And then what's going on here? It did not rain. It actually did not rain. It actually did not rain. Let's do the right color for it. It actually did not rain when it was forecasted to not rain. Now, Brian did some color coding here. Why did Brian use space pen, which is the awesome color, for rain, rain? Why did Brian use space pen for no rain, no rain? Why did Brian use red, the angry color, for the other ones? Why did Brian use space pen for the two that matched? It's almost like Brian is trying to draw your attention to when they say it's actually going to rain, and it does rain. We can kind of overlap them, because that's where they overlap. Here, let's do it that way. So you can see where they overlap, because, yes, you're right. You guys got it. The forecast was actually accurate. So when you look at it this way, all the forecasts for rain, if it didn't rain, the forecast would be wrong. So these are the accurate predictions. You guys got it. You know what's going on right here. The forecast was correct on those days. That is when the forecast is correct. Remember, when you're reading actual, you're reading down this way. Now, I'm going to use a different color. When you're using actual, you're going down this way. Like, these are the actuals right here. I think this will be a huge help. And this right here are the forecasts. So there we go. Does that make more sense seeing it visually this way, that the forecasts go that way and the actuals go this way? So you want where they line up. Well, I mean, that's a good thing. It's not like you want that, but that's like a good prediction. So hopefully that makes a lot more sense of this graphic. We understand what's going on with the visualization of the data. It's just telling us the count of days right here where we have where no rain was predicted. That's what was forecast, i.e. predicted. And then also it did not actually rain. So you can just go, well, it didn't rain that day and they told us it would not rain. So that's what's going on. Like that right there, Neelan, nice job. Awesome work. And so what do we have going on? We're going to go back. Okay. On what percent of days did it actually rain? Well, this is, does everyone see here? This is 32. So it rained 32. There's 365 days in a year. That's a thing you should know. There's 365. I literally, the first few times I did this problem, I added up all the numbers. I swear I did it like 10 times and I kept getting 365. And I was like, wait a minute. There are 365 days in a year. So don't worry. I try never to like be like, did you not know there's 365 days in a year? Well, apparently I didn't know it either. I had to repeatedly confirm that there's 365 days in a year. So these numbers are all the days in a year. On what percent of days was rain predicted? You have to go across this way. Does everyone see I'm going across this way? That's when forecast. So that's predictions because they predict, they forecast. And so we need 26 plus 66 divided by 365. That's 25.2. We're just going to type this one in. And we get it right there, as long as Brian doesn't mistype an answer. What percent of time was the forecast correct? We identified that rain, rain, and no rain, no rain are correct forecasts. And we have here 26, because that's when we predicted rain, and it actually rained. And then we have here 267, because that's when we predicted no rain, and it actually did not rain, divided by 365. And we get this right here, that's 80.3. We get that right. And then we get to a tougher one. Okay. This one is very interesting to read. I'm going to tell you how to read these bottom graphics so that you understand how to understand what these percentages are. I'm going to tell you how to read the bottom graphics so you know how to find these percentages. This is red right here. I want to see in the chat. Given it rained, what is the probability the forecast was correct? Given it rained, what is the probability the forecast was correct? It kind of says it up here, but I'm saying it more specifically. Given it rained, what is the probability the forecast was correct? Given it rained, what is, see it say in the chat, just remember it. Given it rained, sounds weird. Given that it rained, what is the probability the forecast was correct? So how do we find that? Someone tell me, left to right or up and down? Given that it rained. Is it left to right for given that it rained? We're saying given that it rained, the probability the forecast was correct. Or is it up and down? Is it left to right for given that it rained? You are right, Neeland. Amazing work right there, Neeland. So you did great. You know what? If you are here in chat right now, I'm throwing you another 20 points for staying for office hours. I know it's crazy Fridays. So William, Neeland, Kelly, if you are here, you have to say me if you're not here. If you're still watching, following along, say me, and you get those 20 points. Ben, you got it too. Ben, you got it. So you got 40. So be like, tell me in the email. Like, you've already emailed me, be like, hey, Brian, I also got those 20 extra points. It's like a secret. Who knows? You never know what's going to happen. But I appreciate you guys staying and doing the work. Great job, because this will get you ahead, and I really appreciate you guys staying and doing extra work. It's crazy Fridays. You never know when those points are going to happen. Only up to 40. I know I said only 20, and then, yeah. And you can do these in R just by typing them in. R just works as a calculator. So if you want to do anything in R, you can literally just type in here. That's not the answer, but you can just type it into R and it'll do it. That's kind of why I like it, because you can also see your work. Like when I type something into the calculator here, it does appear, but it's not as big. Like it's a lot smaller. And I like doing the calculations in R, but I'll do it in the calculator because most people are not going to have R on their computer. So, and feel free if you ever see me doing something in R and you're like, Brian, how do I do that in Jump? Ask and I'll get it done. Because usually we will use Jump in this class, and I will try to make videos to show you how to do everything. Okay. So given that it rained, okay, here's the days where it actually rained, and the forecast was correct 26 out of 32. 32 because that's the total. So 26 divided by 32, that confirms that this is 81.3 rounded. That is the right answer. That's the only one we need to check because it is right. Now, I want you to notice, we can kind of make a mosaic plot out of this. Now, you don't have to use Jump. I'll let you do your project in R also. You can do your project in R. You can do everything in R. I'm more than happy for you to learn how to use R. I think we're even talking about transitioning StatTool into using R, but we're going to have like a GUI for it. We're going to have something that makes it easier. We're not going to have everyone learn how to code like code. We want to get an interface before we do it. But there's talks of that. So you're kind of, because we're always trying to make our education as applicable and best as possible. We realize Jump is a program you have to buy, but it's better than Excel, and it's a good program. But after you leave UT, you have to pay for it. So that's the big issue with Jump. If Jump was free, it'd be amazing, and we'd be like, hey. But since Jump is not free, R is free, and that makes it better. But R has a steeper learning curve. Like R is harder to learn. So yeah. But I want you to learn skills in this class. So yeah. Yes. No worry, Erica. Eric, you got it. Let's type in the chat right there. You got it. You got it. Nice job, Erica. Thank you so much. You'll hear that later. Now I want you guys to look at that. If you were to stack these, would these look like they had differences or no differences? Like if you visually put them on top of each other, would they be lining up? Like if I put this bar on top of this one and this bar on top of this one, would they be pretty close to each other or would they be pretty far off? Close or off? What do you guys think? Would they be very close to each other or very off? What do you guys think? Close or off? I don't know. Like, could you put them on top? They'd be pretty close. So is there an association? No, because it's pretty much the same. No. If they were further off, I think we still have notes on that today. That's the notes we did earlier, that they would kind of look like this if you turn them into stacked bar charts right there. If you just stacked them, they'd look more like this. And that's like, they could look like this. It'd be very weak. I have that one highlighted down there at the bottom. It'd probably be somewhere between it. It'd be basically very weak. It's closer to this one. So we'd say it's very, very weak. If it looked very far apart, it'd be a very strong association, and that's not what we're seeing. We're seeing something in this sort of area of weakness. Great job. So if you can't tell, we're obviously talking the same concepts we did throughout lecture today and just seeing it visually here. Okay. We got people taking drugs. Now be very careful if you're taking drugs. This one changes when you do it. Do not think, because I have a lot of people who say, wait a minute, on my quiz it was this, and on my homework it was this. Yes, it will change. So we have people who took the antidepressant, the placebo, which is the sugar pill. We have whether they stayed healthy or had a relapse. So we have a categorical variable here on what happened to them, and we have a categorical variable here on the drug they took. So it's drug by what happened after. Like, I guess this is response, and this is drug. There's your X and your Y. They're both categorical. Okay, we know what's going on right here. You got it. Nice job, Kelly, right there. And so there's a few ways to do this. You know, we might be able to do it in Jump. Okay, let's do it in Jump. So we're going to copy the data. I'm going to copy to clipboard. We're going to take the data. And let's go into Jump, and we're going to open a new data sheet. You can easily open a new data sheet with Control or Command N. That's the same thing as going to File, New Data Table. So Control or Command N is the same thing as going to File, New Data Table. You can see the quick command right there. I use it all the time. So when I want a new data table, I simply go to Control N on a PC, New Data Table. Now also, you can paste with column names with Control Shift V or Command Shift V, I think, on a Mac. I always forget the Mac one. But that's the same thing as going to Edit, Paste with column names. So what you see over there on the side is the column names pasted in. This one's going to be a bit of a longer way to do it inside of Jump. I'm going to show it inside of Jump right now for the moment. But when you paste with column names, it'll look like this. If you don't paste with column names, it'll look like this. The one on the right is done incorrectly because the column names are in the first row. This is basically a long explanation of how to get data into Jump. Be very careful while you're pasting it that if it has column names, you want the column names here to appear. Do not try to fix it. If you break it, don't try to fix it. I know that sounds crazy. Simply start a new datasheet, don't click inside of it, and paste with column names if you're supposed to have them. You won't always have column names. You have to think about it. You have to look at it and be like, oh, wait a minute. I had column names. Oops, that was a mistake. I will restart and paste with column names, and now it's proper. Notice the small, subtle differences where the column names are in the first row, and here, the column names are in the columns. That's why you paste with column names. Okay, now that we've talked about when you paste with column names and when you don't paste with column names, we have our data inside of Jump. Now, this is a more difficult one to get a mosaic plot of because you have to know an additional step. That additional step is to go to Tables and go to Stack. When you go to Tables and Stack, you're going to select your two quantitative columns. This will stack them on top of each other and give you something very similar to an example I did earlier today, which we might still have. Here it is. This is when I was doing the passing and failing of a student, where you can see I have two categorical variables and then the frequency over here. So if you watched earlier in lecture, I made this data earlier just by creating data I wanted to make a mosaic plot of. I had my two categorical variables like I do here. You see how they're red, they're categorical. And then I have the counts, which are now stacked from the previous graphic. Once again, rewind the video, and we'll maybe solve this problem by hand too, but I know this is very tricky. It took me like a semester. I know it's way longer than it should to realize how to do this and do it efficiently in Jump. So I've had teachers ask me, how do you get the data into Jump? Don't worry. It's just you got to make sure you get it in the Jump the right way, or else it won't analyze it. And so now we have our data in here the right way by going to Table Stack, and it should look like this. Make sure you have red, red, blue, because we're actually going to analyze the red variables here, and we need to go to Analyze Fit Y by X. The red variables, we're seeing if somebody's condition after is explained by what they took. If they took the antidepressant or the placebo, that makes it the explanatory variable. And the other one right here, so does somebody's drug label, we could say, explain their condition afterwards? Like, why are they healthy? Why do they relapse? That's the question. The data right here is going to go into the frequency because that's the count of the individuals. We talked about counts earlier. So you can see all the cells right there, and boom, we've got it. Woo, wow, we can see this. Someone tell me, do these look independent or dependent? Do they look independent or dependent? Do they look independent or dependent? Does it look like somebody's condition afterwards depends on the drug they take or is independent of the drug? You got it. Now, here's a super advanced question. There is a difference right here. There is a difference, very small difference. You can hover over these things, which is pretty cool. 75% of these people stayed healthy, and 76% of these people stayed healthy. 76.06, 76.09. But, and you can even pin these if you want. You can pin them. So there's a cool thing you can do in Jump. You can go over it. Give me that graphic. There we go. You can pin them. So these are super duper close to each other. These differences are small. Do you think these differences are likely or unlikely by random chance? Do these differences seem likely or unlikely by random chance? Like, that's a tiny difference. Do you think that difference is probably just by random chance? Like, does that difference look likely or unlikely by random chance? Does that difference look likely? You're saying likely. Now, here's a concept we did earlier. You ready? Since you're saying it's likely, does that mean the probability would be high or low? Does that mean the probability would be high or low? Since you're saying that looks likely by random chance, does that mean a high or low probability? That is likely. Does that sound like a high or low? If you're saying something is likely to happen, like this was likely by random chance. Neeland, you got it. Neeland identified that this p-value right here, p-values are probabilities, the probability of our results or results from our team having by random chance variation, given that the null is true. You got it. Is that making a little more sense that you're like, there is a difference, but that looks so small that it looks likely by random chance. Like, I don't think there really is a difference here. I think these differences are just, sometimes you can get a small difference that just happens due to data. So we don't think there really is a difference here. We think that the difference we observed are probably just due to random chance differences, that both the drugs work about the same, the placebo and the antidepressant. The differences we observed are very likely by random chance because they're super small. Don't always just say because they're small. It's because the p-value is high, which means they're likely. When you have time, could you help me to transform the data in R to a stem and leaf plot? You got it. Hey, Ben, check this out while I'm talking here. I've got a video inside. Ben, come back. You can like hop around. Go to the channel and you will see a video and tell me what you think of it. Tell me if it helped you out because I want to get your review of the video. If you want, throw a like on the video. But go to the stem and leaf video because I show how to do a stem and leaf in R. So look at the channel. You'll see a stem and leaf video in R. Tell me what you think about it when you come back. And if it doesn't work, tell me it didn't work and I'll go through a better example of it. And if it does work, tell me it does work. I want to hear your review of it. So that's really good stuff right there. And keep asking for videos, Ben. Yep. If you have a video you want me to make, say, hey, Brian, can you show me how to do this in R? And I'll make a 1-minute video, or I'm thinking about doing 5-minute videos. Okay. So we got all this right here. No. Go away. I'm going to keep these column percentages and row percentages. The column percentages are of the healthy individuals, what percent relapsed. Of the healthy people, what percent had the antidepressant, what percent had the placebo. To make it even clearer, I'm just going to remove row percentage. But this is columns, so it goes this way. So this is, you notice how 48 and 52 add up to 100 and 50 add up to 100. But you could do the row percentages too. This is why Jump's awesome. Jump's awesome too. We'll give Jump some credit. Now these are the row percentages, like of the people on the antidepressants. And we can see, here's the antidepressants. 75% stayed healthy and 25% relapsed. So you can get the answers to these questions using Jump right here. It gives you tons of stuff. Let's hop back, and answer our question. There is no evidence because they pretty much line up. The relapse rate for the antidepressant was, so given someone took the antidepressant, we can solve it ourselves. Given someone took the antidepressant, that the relapse rate, I think this is our 25%. There's the 25%. So once again, this is 11 out of 44 relapsed on the antidepressant. And then the relapse rate was 11 out of 46. That's 23.9, 1 decimal. And you can get these also in the Jump output. Just show again, where's my Jump output? The Jump output right here has 23.9 because we're looking at the placebo had a relapse rate of 23.9. It actually had a lower relapse rate, but once again, these differences are likely by random chance. Got it right. And that's how we do that question. You can do it inside a Jump, but it's just as easy to solve it by hand. I can do a different version of it. Don't show me completed problem. Sure. This one came out that, yes, there is a difference. How would we calculate this 18.5? To calculate the 18.5, we're trying to see the relapse rate for the antidepressant. So the antidepressant had 10 out of 54 relapse. There's the 18.5. And the placebo had 15 out of 45. And the placebo had a higher relapse rate. Now, these differences right here are pretty large enough that the plot would be pretty far apart. Just so we can see this and you can see it can be done quickly when you know how to do it. We're going to copy the data. We're going to go to Jump. We're going to open a new one. We're going to paste the data. I did not paste with column names. There was a mistake, not on purpose. They happen. And now we're going to go to tables. We're going to go to stack. We're going to double click the blue columns. We got the blue columns double clicked. I do this slower a moment ago. So if you're like, this is way too quick, don't worry. I did it earlier. And then we go to fit y by x. We take the condition of somebody from the label of their drug. I think that's the way we did it. We might have to flip it, but I think that's right. We go right here and what do we see? A very different looking mosaic plot. So if you look right here, this Mosaic plot has a much different, show me the thing. Toggle. There we go. Cool. Takes a moment. Here we go. There's this one. I'll probably make it bigger here in a second. There goes this one. So if you look right here, and it's asking about relapse rate, but these are the people who stayed healthy. So you can see a difference that looks unlikely by random chance. So this p-value will be very low. Not too low. Actually, that's what the bummer about this. This p-value is not actually statistically significant, but it is lower than this one. These differences are unlikely by less likely, I should say. But be very careful here. These differences are less likely by random chance than these. These differences are very small. These ones are less likely, but that's why I sometimes have qualms with MyPearson, because these differences are not statistically significant. They're close, but they're not. So if you see a big difference between these numbers, here's the quick trick for this one. I'd say if you see a difference of more than 10%, say that there is a difference. So if you're watching this video right now, if you see a difference of more than 10%, say that you have evidence of a difference. If you see a difference of very close, like I'll show you another version of it. In this version right here, the differences are about 1%, and then that's such a small difference, it's probably due to random chance. We're not doing p-values right now, but it helps to kind of see it in the background. An article found that's 166. Oh, this is the one that gives you the answers at the end, I think. The relative frequency of accepted students is what? Okay, so this one's kind of a review question from chapter 2. It wants relative frequency, which is a percent. The accepted students were 880 out of 1. I don't think anyone ever gets this one wrong. So that's 5, 2, that's that. It likes that. This one right here is 247 out of 164. That's that. And then this one right here, is it turned away? So who were turned away? And then 537 were turned away. I need to raise the screen up so it's higher. Is that right? I hope I didn't type something wrong. I think that's right. That looks to be 100%. Looks to be. Is it 100%? It is. And awesome video, super simple. I'm starting to like R a lot. Yes! Yep, that's what we use, Neeland. Thank you so much. And Ben, email me if you want, Ben, for videos. Be like, hey, Brian, can you show how to do this? I'm glad that video helped and was super quick. That's my goal. And what I want is when people are learning R to use those videos. Could you imagine if that video got like 10,000 views? From what I understand, 1,000 YouTube views is worth about $10. So if you did watch an ad, you made the video 1 penny. So if you had to, I'm sorry, if you had to watch like a 15-second ad, you can skip ads. Don't worry. If you want to throw likes on videos, that really helps the channel too, especially when they're public videos like that. But if those videos started to get like 1 million views, I think 1 million views would be like a couple $1,000s. So imagine if everybody started using those videos as quick tutorials on how to learn stuff. If we start pulling in ridiculous money, this money is going to go to students. So my goal is to make us kind of the hub for how to learn things quick and easy. If we become that hub, like we're the ones putting out videos, then we get the views, we get the monetization on them, and then we just give that money back to the students. I'd love it if we had like a Stat Tool 1 scholarship. That'd be awesome, like the Stat Tool 1 channel scholarship. But we have to build that up over time, and that happens for every like, every comment, all that good stuff. I know, it'd be so cool. And pizza parties. We keep talking about pizza parties. We've earned like $35 so far. But we've earned that in like a little less than a month. $35 a month? Not so bad. Like that, over a year, we could get a big pizza party. Or over a year, we could do like a $500 scholarship. So we're looking for some big things on this. So stay tuned. The more you like it, those are just the numbers I put. This question gives it away, basically. Gives it away. And once again, I won't put ads on videos of lectures, and I don't put it on review videos that are like specifically designed for like test reviews and stuff like that. I think chapter reviews, I do have it because those are public videos that people could watch all across the internet. But when there's like a test review question, I don't have it on test review questions. So you only see monetized videos that are meant to be like general purpose, like anyone on the internet should be like watching this video to learn. And so we're trying to like be like, oh, you want to check out our videos? Oh, we're going to make some pennies off of you. And so, yeah, we love pizza and scholarships. You got it. It's like, you know what? Like if we eventually get to that pizza party, like a year from now, maybe, you know, like I could do that. Like I could tell everyone, I could announce to like all former and current Stat 1 students, we could put out a thing like, hey, we're having a pizza party at this time. We'll take how many people are coming, you know, and then like, we'll do it up to like 500 people. Who knows? Cause like that'd be a lot of money. As long as people vote on it, we'll do voting and stuff. Okay. So we have right here, we have a pie chart. Pie charts are displays of univariate categorical data. Is this an appropriate display for the genres? This is a weird question. I've never really liked this question a lot. Obviously I have questions I love from MyPearson, questions I'm like, no, those questions are okay. They're all broken into different groups right here. So yes, They're saying you can't have a movie like 21 Jump Street. You can't have a comedy action movie. It's going to fall into one category. At least that's the way they plotted it. What genre was the least common? Sometimes it's hard to see, but drama takes up the least portion. They should really put counts or frequencies on these, making it a frequency pie chart or relative frequencies. But comedy, nope, it's drama. I can't wait. It is drama. Drama's yellow. Drama's yellow, so that's the right answer, and we should use our enter trick to remember. Oh, that was easy. Well, this one's better right here because it's got a bar chart on it. So with this bar chart right here, we can see that comedy is the highest and drama is the lowest. A lot of these are very hard to tell the differences between until you look at the bar charts. Which genre was the most common? Pretty easy to see. Comedy's higher. It's really trying to draw your attention that the bar chart in a lot of ways can be better than the pie. I thought that was it. Is it easier to read on the bar or the pie? Much easier to read on the bar. Got the hiccups now. Yeah, it's the bar chart. Yeah. I will say this, it's kind of preference. Did people get hundreds on the homework for 3? Who got hundreds on the homework for 3? You're done. You're getting way ahead of schedule right now. We should have some hundreds for homework 3. Hundreds on homework 3. Nice job nailing right there. Nice job. Let's see here. I'm going to send a quick text to my boss. How does 2 sound? Gonna have a Zoom meeting. Yes. Cool. So, oh no, maybe I should turn my ringer off. I don't know. There's, I'll answer certain calls and stuff like that. But yeah. So meeting at 2. So I will be ending at 2 at least. We can go to 2. We got this. Let's do the quiz. Nice job right there, Niland. Getting the assignments done. So let's go here to quiz 3. Replace the questions. Quiz 3, replace the question. Oh, wait. Should we replace questions? I'm going to skip a question if we did it. I think some of these are repeats. So if I am skipping a question right now, it's because we did it. I can Zoom you. I can call or Zoom you then. Let's do Zoom works great. Get to see each other then. Zoom works great. See you then. See you then. It's like, okay, cool. Okay. So we did this one just a moment ago. So if you are stuck on this, please rewind the video. And this one is a bit tricky. Do you do cool effects? I do some. I do some. Like I'll put I've got a nice like like lake background. You know what? Yeah, I think I would never want a beach house. This is Brian's quick like 1 minute break. I would never want a beach house. I'm sorry, I'm just not that big fan of a beach because I'm so fair skinned, pale that I just burn so easily. And I've never liked getting like you get sand in your ear like a day later. You're like, oh, there's still sand. Like, oh, I can't. You try to get. You're just like, oh, I've still got sand. You scratch your scalp a day later. You're like, oh, there's still sand in my scalp. I don't like that. I don't like. But if I was on like a lake, and it was like if I went somewhere that like lake house for sure. Like that'd be awesome. Like and the lake is like in like a valley or something like there. Yeah, I hate sharks too. Then you don't gotta worry about sharks. You could like make sure there's no sharks in your lake. But imagine this lake is in like a cove, like a deep cove, and like you can literally see the walls of like the cove, and like there's light that like shines down into it during the day, heating it up. And so at night it's like a nice like 75. I don't know if 75 is like a great lake temperature, but you get like a 75, 80 degree lake. And so you get like, this like amazing lake that really nice, and you get like some really good moonlight. Oh, that'd be so awesome, so cool. Yeah, that's like if I could like just build a place somewhere, that'd be it. So that's kind of what I chose. Mountains are cool too. I like mountains, but like if I had a cabin on the side of a mountain, that'd be amazing too. Chelsea and I get that. Lake house, no, I couldn't do it. Can't do lake house. Rain, no rain. We did this one earlier too. Woohoo! We're 2 for 2 on the questions we've done. If you're watching this video now and you're completely stuck, please review the rain, no rain problem we did just a moment ago. We've got 2 of these knocked out. Antidepressant relapse one. We did this one too. Woo! We're so happy. Yes, this one is the one that, here's a trick. This one gives you the answers. It literally gives you the answers right here. It gives you the answers. Yes, I want to do it. Uh-oh. We didn't do this question. Dun, dun, dun. Okay. So now we have to find out the answers to the conditional distributions for male and female, whether someone was liberal, moderate, or conservative. So we need to find out the conditional distributions for female. So someone tell me the mathematics in the chat right now, and I can take a guess of this. I'm guessing that this is about 44.6%. No, that's off. 47.2%. Is that about right? I think that's about right. 47.2%. How would I find out the percent of females who are liberal? And I'm going to say 47.2. That's my guess. Let's see how close Brian was. Brian's going to guess all these numbers for fun, because those have to be the same, if you see what trick I'm doing. And that leaves a remainder of 2.8 times that, so 5.6. That looks close. I could figure it out more accurately in my head. Let me do my tricks here. So that would be... No, it's going to be closer to 6. Yeah, that's... Oh, was I that close? No! I knew it was closer to 6%. I started to figure out that the last one was closer to 6%. So this would be... It's the remainder. So we are... I'm going to trust Nalen's answers right here. But if you notice, these both would be identical. The mathematics we just did. If you're wondering how did we do this, it's 40 divided by this. And there's the answer right there. It does round up. Let's be careful and double check this one. That rounds up. Oof. That looks... that's super confusing because this rounds up and these round down. It looks like it's not a proper distribution because these should equal to 100%. But when you round to one decimal, we'll see if there's a leeway in these. I am wondering about that. I'm going to put in what could be the wrong answer. This is accurate for what the distribution should be. It should add up to 100%. But because we're rounding to one decimal, you get that these rounded down, just to show you again, those round up, but then they have a remainder. And then, so it is 47.1. And then 40 divided by 85 again is this. And that rounds up. And then 5 divided by 85 rounds to 5.9. It's just due to the weird remainders on stuff. So I would just round it. Let's go safe. I mean, that's going to be the answer if it wants us to round. I just don't like the way it looks because that should add up to 100. So now we take, for the males, 52 out of 52 out of 113 is 46.0. And then we have 41 right here out of 113. 41 out of 113 is 36.3. And then 20 divided by, because this is of the males, 17.9. There we go. So how should this look? They're just going to put the bars beside each other. So this is super confusing. But what do we notice? That females are going to be even for their 2. So when we look at the females, we should see the even bars, and the males should have more liberals. The males do have more liberals, slightly less moderates, and then way less conservatives. And the females are mostly just liberal and moderate. So this is the proper display of the graphic right here. They're doing side-by-side bar charts. Not my favorite. I like the Mosaic plots, but these exist. Unless I've looked at it incorrectly, you notice that you can kind of see here, there's the same amount of females. I got lucky because that's an easier one to read. Do the variables of sex and political party indicate a difference? Yeah, males do look to be more conservative than females. Does everyone see this jump right here? There's a jump where males look to be more conservative than females, and males look to be less moderate than females. This could also be displayed in a mosaic. This might be a harder one. Good. Okay. I'm going to display this in a mosaic plot just so we can review. I'm going to do it very quickly. You're not required to do this. Just to show you that if you do know how to use these softwares, this is the same process I did earlier. So rewind the tape if you want to see how I'm doing this. So we did it a lot earlier. Does somebody's sex explain their political label? And then we go right here and close all. Oh, no. I wanted to close as that one. I made it and then I broke it. Does somebody's sex explain their political label? Go over here. And if you notice, there is a pretty big difference where we see males are more likely to be conservative than females. And it is actually statistically significant. And these are the same graphic you see over here in the background. So we're just stacking these on top of each other. Like this bar and this bar right here are these two bars. They're the same size. Where the male liberal is this bar right here. That's male liberal. And the male moderate is this bar right here. I know they're different colors. Sorry about that. The male conservative is this bar right here. We're just stacking them on top of each other to make the mosaic plot. Those are side-by-side or stacked or segmented bar charts. I don't like them. Do the variables sex and politics appear to be independent? They do not appear to be independent because the conditional distribution of politics is significantly different for at least one group. If they are independent, they'd be roughly the same. They could be exact, and they'd definitely be independent, but there's a significant difference for at least one group. Oh no, they do not appear. That's right. What did I click wrong? Oh, did it not like this? You got to be kidding me. Okay, it liked that. Where did I mistype my answer? We had to get one wrong today. That's what we do. We're going to start changing answers so we figure out which... That one is the one I got wrong? That seems to be. Well, so what did I mistype? 20 divided by... I typed 17.9. Someone in the chat tell me the right answer. Rewind the tape and see me make the typo. I would change this answer for you. If you're watching this right now and you make the same sort of typo, I would think that you're like, hey, Brian, I just mistyped. I'm just made a mistake. Who knows what the answer is? 17.7, yep. And that makes sense if you look at this. And so it accepts that. There we go. I was like, what did I get wrong? Would it have accepted this? It would have accepted this. So there is like a plus or minus 0.1. I wanted to put this originally, and it would have accepted that. So there is a plus or minus 0.1. So, man, look at this. It would have accepted this, and it would not accept this. So I literally looked at the number the wrong way. I'm glad I guessed that was the one I got wrong. I just randomly was like, let me check this number. You guys can't check answers like I can, but we all make typos. I think when I looked at this, I read 17, and then I saw this 9, or I don't know. When you round that, that's 17.7. You look at things wrong, you enter it wrong, and oops, make a little typo. If it's obvious typo like that, please email me like, hey, Brian, I got it wrong, and then I'll fix it for you. Good stuff right there. Let's see what's going on. Let's try to do homework 4. You guys want to do homework 4? Get that in the video. It'll be there all weekend. We got enough time. I got 45 minutes or 40, a tiny bit early. So who's here in chat hanging out right now? Assignment manager. Well, if assignment manager won't load, then we can't do it. Course home. Oh, it's working now. Course tools. Who's here in the chat right now? You are. Good to have you here, Neeland. Good to have you here. Let's do homework 4, which is due, and quiz 4. These are due on the weekend right now, too. These are due on the weekend. So we're going to get all the weekend stuff done right here. Let's get homework done. So we'll have all the weekend work done. These are easier ones, I generally think. So we'll see how quickly we do it. Okay. So here we are in homework number 4. Okay. Crowd management strategies monitor accents at rock concerts. That's a fun data set. In their database, they list the names and other variables of victims whose deaths were attributed to crowd crush at rock concerts. Here are the histogram and box plots of the victims' ages for data from a recent 1-year period. Complete parts A through D. So let's go ahead and take the data. Oh, cool. It shows it to us. I thought we were going to have to display this. So we've got the data right here, right now. We're good to go on it. Is this data skewed or is it normal? It's the first thing I'm going to ask. The shape of it. Remember, shape, center, spread. Is it skewed or is it normal? There's a hint. It is definitely. I would say it is skewed. You're right. Kneeling is skewed to the right to the high, left to the low, whatever way that tail goes. Remember, when I ask questions, don't worry. If you're watching this video later or if you're doing the work along with me, don't always have to answer. But it helps when you're like, wait a minute, and you pause and you say, skewed to the right. So since it's skewed to the right, what are we going to do? Well, very skewed, the symmetric, and very slightly skewed to the right with 2 high outliers. Let's see where those outliers are at. They're at in their 30s, 36, and about 40-something. So 36, 48. So we've narrowed it down to these answers. Most victim ages are between this and this. So let's see right here. Where are most victims' ages? They're in here. So most victims have ages between like 18 and 22. Oh, it looks like this is the answer. Yep, it's going to be this one, I believe. Do we get it? Yeah, got it. They trick you because you see, like, where does it repeat? Where is it different? Why did I say most people have ages between 16 and 24? Because that is the what? Pause the video, think. 16, which looks to be about here, to 24 is where the most common ages are. That is the IQR. You can also look over here and you can see that the kind of peak, the mode of it, kind of the most common area of it is in the like upper teens, lower 20s. If you look from 24 to 30, which is the other answer, 24 to 30 is going to start here and go to here. Like this is 24 to 30, and that's a very small portion of the data. It's not most people. The most common area is the modal area, which it might be easier to see over here. Also, that is the same area in this. So it's kind of connecting the histogram and the box plot, which are both univariate displays of quantitative data. What feature of the distribution can be seen in the histogram that can't be seen in the box plot? The shape. So histograms show us shapes better than box plots. So the skewness right here is easier to see. So I'd say the shape of it. Anything say shape? We can see the outliers in both of them. The median is not seen in the histogram. The median is here in the box plot, so that's wrong. The IQR is not seen in the histogram. The IQR is here in the box plot, so that's wrong. So it has to be the last one. The slight increase, and that's shape. It may be a second mode. It's very small, but you see kind of this increase right here. That's why we kind of use words like it could be, it might be in statistics. So you can see the shape here. You can't see the bump right here. There's no indication of the second possible modal area. I still said it's unimodal, but as it said, it could be a second mode. It's like a slight increase, so we're good on that. What summary statistics should be chosen? We said it is skewed. We said it is skewed. Since we said it is skewed, it must be the median. And since we're using the median, so the median would be the most appropriate measure of center because it's not symmetric. It's skewed, and it has outliers. So to go back to this question just a tiny bit right here, this is an amazing question. Like sometimes I'm like, MyPearson, not the best of questions. These are great. The median is used when data is skewed for a measure of center. So if you look, center is either going to be median or mean. The only two plausible answers right here is median because it is skewed or mean because it's symmetric. So when you look at the next question, the only plausible answers would be standard deviation because it's symmetric or median because it is skewed. The only two plausible answers right here are standard deviation for a measure of spread because it is symmetric or IQR because it is skewed. And since it's skewed, the right answer is IQR. Those are the only two plausible answers for us to use. So the other two answers can't be used because if it's skewed, you use the IQR. And I usually just say normal for symmetric. It's just that we really want things to be the normal model. And also it shouldn't have extreme outliers because it can be symmetric with outliers. So I usually just say the normal model is when we use the mean and standard deviation. I kind of abbreviate it to that. They'll sometimes say symmetric, and that kind of means it's more normally distributed. This one does not look normal. And this one has a lot going on with it. So what's going on with the data right here? The data right here has adults and children's cereals, and we're looking at the percent of sugar. Anyone got a favorite cereal in chat? Who's got a favorite cereal? Tell me your favorite cereal in chat. What do we got for favorite cereals? I would say mine is Rice Krispie Treats. I used to like Frosted Flakes. And then like Oops All Berries. And you got some like Honeycomb. And there's so many good cereals. Now I just want to eat cereal, but I can't after my oral surgery. So what do we have right here? We have the percent of sugar in the cereal. And we see right here that children's cereals have this range. And adult cereal has this range. Now they're kind of similar in some respects. Like a very sugary adult cereal would have like 30 grams of sugar in it. That's about where the top is for that. And a very sugary children's cereal would have 65. Now, how are they similar? They both have about the same ranges. Adults have a bigger IQR, which means there's a bigger spread to the middle 50% of their cereals. The range of the values of the sugar in their cereals, which is also another measure of spread. Range is something you use, but it also encompasses extreme values. I don't know if that box plots is 100% accurate because I don't know about the whiskers. I'm like visually going in. You know what I'm going to do? Oop. Let's see here. 2 seconds. Be right back, everybody. Be right back. I'm back. So, what is the range of sugar contents of these cereals? The range of sugar contents for all cereals tested goes from the minimum to the maximum. Boop. There we go. We got it. Describe the shape of the distribution. Well, look, we got 2 peaks. That makes it bimodal. Always try to think of the answers before you put them in. That's a great way with MyPearson to make sure you know it, is look at it and be like, 2 peaks, bimodal. What aspect of breakfast cereals might account for this shape? Well, we've got children's versus adult cereals. So when we go right here, sugar contents vary among different cereals. Cereals tend to be either very sugary or healthy low sugar cereals. Is there not a D? It's really the adult and children's cereals. Now I'm worried. Sugar contents vary among different cereals. But it's asking about the shape. I almost think this is true because it's asking about the bimodality of it. This kind of deals with the range of the data. Like there's a big range to it, but since it's asking about the shape, I think there's like a bimodal thing going on. Oh, I hope this is right. I'm so sorry. Yes, we got it. Because it's asking about the bimodality of it. Like, why is it bimodal? It's like because you've got your healthy cereals and you've got your very sugary cereals. So it makes a bimodal distribution. Like there's a cluster of very healthy, there's a cluster of sugar. So the lower one up there is the cluster of very healthy, and the higher one would be this direction, is the very sugary cereals. So you've got these bimodal areas. Are all children's cereals higher than adults? I think it is, if we look at it. You go into this graphic right here, and this is the lowest children's cereal. That's the highest adult cereal. And we got it right there. That is right. Which group of cereals varies more in their content? The ranges do appear to be similar. You've got down here the children up to the highest children cereal of sugar content and there. But there's a difference. Although the ranges appear to be comparable, the IQRs is larger for the adults. And that's got it right there. We pointed this out earlier that the IQR for the adult, which I was just hovering over, is larger. The IQR for the adults is larger than the IQR for the children. And we got this one right here. Here's a back-to-back stem and leaf. Tricky stuff right here. Okay, so when we do this question right here, let's take a look. This one is super tricky. Now, we want to turn this into a box plot. I can't even say box plot right now. We want to turn this into a box plot. How are we going to do that? Well, there's a few tricks you can do. If you look at these, you've got major differences between these right here on distribution 1 and like just looking at it. These look like this. These look like this. The highest number in distribution 1 was 12. So let's take a look. I think this will open it. That goes way above 12. Do you see how 12 is the highest number? That goes way above. So that graphic is wrong, and I think this one is also wrong. That's going to like 18. So that's not 12. That's not the highest number in distribution 1. Let's look at this one. It should go to about 12. That goes to about 12. And then this one down here, which you'll now be able to see, that also goes to about 12. So we now have maybe another thing we need to look at. So we got to figure out the last way to differentiate between these. I'm looking at the distributions. I think this whisker is too long. If you look at this whisker, it's 2 IQRs. So I've probably given away the answer here, but looking at this whisker, it can only go 1.5 IQRs above. So this data point up here, which is represented by the 61, that's where 61 would be, should be an outlier since it's this far above Q3. So we don't actually have to graph these. We can realize that you can only go, if you look at the distance of the IQR, because this is the IQR, you can only go 1.5, and this is more. And if you look, the IQR, wow, it's about 20. So you could only go 20.5. Ooh, now it's close. Now I'm thinking about it. Did I do my math correctly? It's a little less than 20. It's super close. I'm a little worried now. But I think, I'm trying to see if there's other differences. It should be this one. Is it this one? We got it. We got the answer. We could graph it and then we'd know for certain. Let me see if I see another key difference between these. I'm trying to look for key differences between the plots. What's another reason this one is wrong? I want another strong reason. This one's symmetric. Is this one symmetric here? Okay, so I don't think they changed that one. I think it's just the whisker length. That one is there. I think it is. That's tricky. Yeah, because that's just barely more than 1.5 IQRs. That's a tricky one. You could graph it out, but I think this basically gives it away. But just make sure you know, here's the key learning objectives, that this right here represents 12% in region 1. So we need to see that you would have 12% in region 1 as the maximum. This right here is 1%. Why is it 1%? Because that's 0, 1. You can look at the key just barely behind it. This is in region 1, 1% right here. This is 61, which is right here, the outlier in region 2. And this number right here is the 41, which is the whisker right there. And that's, yeah, that won't give it away, but that's the 41. This right here is where Q3 is at, the 75th percentile, which looks to be, it might be right at 29. That looks to be 29. Hard to tell. And then this looks to be about 10. It could be 10. We could do the data on this and find out, but we're good. So let's continue on right here. I will say this. Let me do it. Let's copy it to clipboard. If you want to do this in jump, slow down the video. If you've solved it, you're good. But if you want to do this in jump, you can start a new data sheet. So that's File, New Data Sheet. And then you will go and paste your data with column names, edit, paste with column names, and you'll get it in here like this. You'll go to Tables and stack your columns. And then, we're making side-by-side box plots. Now that you have your data stacked, you'll go to Graph Builder. You'll put the label on the x-axis, because that's the categorical. You put the data in the quantitative, and now you'll go to this, and that confirms the answer for us. So now that we have this right here, we could confirm our answer. Please slow down the video if you want, but this is not required, so I did it a little bit quickly, but you can get the answer this way. You can also figure it out. I do support actually, I probably support it more, kind of figuring it out intuitively by looking through and thinking what's going on right here, where the points would be in the graphic. So realizing that this right here represents 12, so that's where the maximum would be, and this is a little more than 1.5 IQRs. It's just barely an outlier, which is probably the hardest part to identify about it, but I think that's usually an outlier in the plot. I think, yeah, that one's usually, I've done this question a lot if you can't tell. So it was really a choice between these last two behind my head. That was the tricky part. Describe the differences in the growth rates for the two regions. Region 1 is more tightly clustered. Region 1 is definitely unimodal. That's got one mode, unimodal. Region 2 is bimodal around all modes. The distributions are, and I think they're going to be skewed to the right to the high, left to the low, and region 2 has an outlier. Okay, let's double check. I think they're skewed to the right. That's the only tricky part. Oh, I knew it. Is this, you gotta be kidding me. Is it saying fairly symmetric? I hate that question. Well, you've seen it in the video, just so you can see. You know what I wish? Let me go look at the data. Let me see which way it's skewed. See, this is modality. This is just a review now. This looks unimodal now. This is region 2. This right here, just so you can see side by side. This right here is region 2. You say, well, why does it look like that? Bin widths. The bin widths here are very different. I can change the bin widths, and we should be able to change it to 5 right here. I think that'll change it. Will that change it? There we go. Now you can see what they're calling bimodal. So bin widths can change how the modality looks. So you can change the bin widths, and it'll look different. Like that just looks right skew now. Right skew unimodal. So the bin widths changes the way it looks. So is it really bimodal? It's hard to say. Like it's kind of I'd say it's bimodal. Like this is not doing it justice, especially that you don't want such small bin widths. So now to kind of, I know it's going to come out positive, just so I can see it for my own thing, because I said it was right skew. It told me I was wrong. I'll give you the points back on that one if you got it wrong too. If you got that one thing wrong, just tell me. I'll fix it. Yeah, it's obviously right skew. That positive number right there indicates that it is right skew. I guess someone could say it's fairly symmetric around these. I'm still saying it's right skew. You can see the mean is above the median. That indicates the nature of the skewness. So these questions right here become a little subjective. It's definitely not left skew. Like, that's the one thing that's for certain. It's definitely not left skew. No way is it left skew. Okay, doke. We got that one done. That's where I'm like, come on, MyPearson. We got this. Baseball teams in League A play their games. So we can do this one also in Jump. We're going to do the same thing right here. We're going to copy our data. And this one gives you so much data. So I'm just copying it. I'm going to do this one a lot more slowly because this one's going to be a lot easier if we're doing Jump. I'm going to go to File, New, Data Table. I'm going to edit, paste with column names. Now make sure you paste with column names or they'll come out red because the column names will go into the first column. So paste with column names. So now that we have it pasted with column names, we want to look at the average runs for League A and the average runs for League B. So I'm going to do something here. I'm going to put in, whoops, oh, I can do that. We're going to put in A, and then we're going to put right here B. You don't have to do this, but it'll make it easier to read. So now we're going to go to Tables. We're going to go to Stack. We're going to double-click this. We're going to double-click this. Now we actually get the data for League A and League B, and it has here League A, and it has here League B, and the data for the different variables. We can ignore these columns. They're not important to us. I don't know why it put it in this way, but data's not always perfect. We've stacked it. Now we're going to go to Graph Builder. The label is going to go down here. That's going to put the two groups. The data is going to go right here. And then we're going to turn it into box plots. And we've now clicked done, and we've got our answer. There are no outliers, which is going to be a key feature. And then we can look at it right here. Since we know there are no outliers, that eliminates all. Really? Really? I think my A and B are reversed. But if there's no outliers, see, A is over here. So is this accurate? It does look to be the same. B is mostly symmetric. A has a higher median. And there are no outliers. So, yep, there's no outliers. That looks, yep, that's got it. Which writes sentences about them. This is always the fun part to answer. The distribution of runs scored in per game is League A has a little bit. Or they want to say skewed on that? Okay. League B is definitely symmetric. These are the questions I hate. There's questions I don't like. I like the so League B is definitely symmetric. It's roughly symmetric. They're going to call the whisker here probably the skewness to it. If you notice, let me zoom in on this really big. The whisker on A is longer, pulling it in this direction. So I think they're going to call it skewed to the high because the whisker is going that direction. I'm going to do one last thing to confirm my answer here. I'm in this data frame right now. So I'm going to go to Analyze, Distribution. I'm going to go to By Label and analyze the data. I'm going to go here. I'm going to stack my data. This is what I would actually do. I'm going to click here, Customize Summary Statistics. And then I'm going to go to Skewness. Where's my Skewness? I always forget that's on. And they're both a little bit skewed to the right. They're both skewed to the high. A is more symmetric. Really, A is more symmetric? No, let me see. Well, that's interesting, especially when they're going to tell me that it's not. But they're both a little skewed to the right. I mean, yeah. So they're skewed to the right, and B is a little more, they're going to say symmetric by the shape, because they don't expect you to find that skewness value. So if you're like, what's going on? They don't expect you to do that. So we're going to say that this one is skewed to the right because of the whisker. Whiskers can be a decent indication of skewness because it's being pulled in this direction, especially if you had outliers right here. That would be an even stronger skew in that direction because it's going to pull up the mean. So that probably is going to be skewed to the right. We're going to cross our fingers on that one. The takeable runs scored per League A is, well, that's going to be higher. So higher than B, while the variation in runs scored in League A is the box plots, the IQR is bigger. So I think they're going for the IQRs. I wish this question was more specific. I'm going to explain. Good. That one, I will say that had me worried. Let me explain why they're saying it's greater. Because they're comparing the IQRs. So when they said typical right here, they're talking about the median. So they're saying, all they're asking right here is the median is higher for A than B, and that's true. Then right here, when they go to variation, they're using IQR. because the ranges are similar, but the IQR for A is bigger than the IQR for B. So that's what they're asking specifically. I wish it just said IQR, which is the box. It's very easy to see if it's at IQR. The two teams playing World Championships, League A and League B, both were at the top of their respective leagues. Did either team score an unusual amount? Nope, they're not outliers. So this team and this team right here are not outliers. That's not unusual. Both teams neither team scored an unusually large because they're both not outliers. That should be right because they're not outliers. Woo, we got data just like from earlier. We got all the months. So let's do this right here. Last question, and we'll pretty much head off. Great job if you're still here, following along, getting all these assignments done. Ozone levels were reported at sites in New Jersey between 1926 and 1971. Here are box plots of the data for each month, over 46 years, lined up January, da-da-da-da. In one month was the highest ozone ever recorded. Really? It's very hard to see, but it looks like month 4, which is January, February, March, April. February, March. A month all of a sudden got, oh my gosh. It looks to be April, and I think they're trying to do a trick right here that we did in class where some people will forget to look at the outlier. I wish they made that higher so it was a little bit more obvious. We'll zoom in on it here, and it does look like that's the highest observation for the whole data frame. So we'll check our answer. Is it April? Yes, and they are throwing the trick that the whisker is not always the highest point. The outlier can be the maximum, and that is what month has the largest IQR? I really like this question. I mean, I chose it, but I'm liking it. The month with the largest IQR is going to be February because it has the biggest box. The box is the IQR, so that's February. That's a lot of answers. Unless I was like, did I misread? Good. What month has the smallest range? Now you have to be very careful. And I wish it wouldn't zoom this way because it's very hard to see. The month, well, let's do this. Let's make it easier to see. And we're going to do some comparisons here. When you do the smallest range, you must do the following. The smallest range must include outliers. So please, please, please include outliers. Is it August? August is month 8. I think you're right. I think you got it. But wait, isn't month 6, June, close to that? This is the wrong way of doing it. Nice job right there. That's the wrong way of doing it right there because that does not include outliers. So it does look to be August, and this is the range of this month, which you can see is way larger. So the smallest range does look to be August, which is month 8. So, yep, definitely. So thanks for taking time to go through this. You're welcome. Yeah, eat some lunch. Go enjoy. You're welcome. And these are all in the video for people who want them. So it's August. Nice work. You're welcome. I hope you got some hundreds there. Read a brief comparison of ozone levels. They kind of follow a time series pattern. They kind of dip. The median ozone level in June was slightly higher than the median ozone level. No. June is slightly lower. And the IQR was significantly smaller. I think so. Yeah. So from June to January, June is slightly, let me think. June has a lower median, which is this month. Wait. The median ozone level in June, January, February, March, April, May, June. Oh, they're similar. Wait a minute. Am I losing my mind? Write a brief comparison of the ozone levels in January and June. So June is actually a little bit higher, I think. Are they so close? You're welcome, Nayland. You're welcome. So June to January. Okay, so let's go back to our graphic. So all these written responses are the hard ones. So we're comparing this month. We're saying January, February, March, April, May, June. So June is a tiny bit higher. June is a tiny bit higher to January. But its IQR is smaller. Its IQR is smaller. Its median, let's do the median in the median right here. We're going to do them in black lines. The median of June is higher than the median of January. You're welcome. Great job. Great job, William, right there. Excellent work. Thank you guys for staying. And the IQR for June is smaller. So it's going to have a smaller IQR, and it's going to have a higher median. It's tricky. So the median for June was slightly higher, but the IQR was significantly smaller. Yeah, that makes sense. So once again, the median was slightly higher, but the IQR is significantly smaller, and that's the IQR right there. The IQR is the box plot. Review from today. Cool, we got it. Reports, write a report on the annual percentage you see they drop over the course of the year, implying that the ozone low. No, it follows a pattern. It probably follow. We say sinusoidal. That means like an S-shaped pattern. Awesome that this word is in here. It reaches a maximum in the spring. I think that's right. They're not consistent. Consistent would mean flat, and they're not going to go to 0, but they're going to follow this like S-shaped, this kind of wavy pattern. That's sinusoidal. Sinusoidal, for those wondering, means a pattern that is an S shape. And I know that this S looks like this, but it's an S-shaped pattern. So you see this a lot in statistics, like a sinusoidal S-shaped pattern. So you see this in a logistic regression. For those who ever want to do logistic regression, where we'll break some of the rules of regression, we'll do it with a categorical variable. Don't pretend you didn't hear that. But sinusoidal is, you see it a lot in time series data. We're just kind of expanding upon these topics. But it should be, there's a sinusoidal pattern, and you see it right there at the flowy pattern above my head. It has like an S. Just could you imagine, just so you can see what does that S shape look like if we draw an S on it? The S-shaped pattern should look something like this. There's your S. So you wouldn't really graph it this way, but you should within this see like an S-shaped pattern. So you've kind of got this S shape right here, and that's what sinusoidal means. So always like to expand upon a word if we haven't mentioned it, but sinusoidal just means S shape. Enough on that. Oh, no. Reaching a maximum in the spring. Oh, that's the spring, and a minimum in the fall. Oops. Whoops. It's sinusoidal still. We got the 100. The maximum is in the spring because these are the spring months, and the minimum is in the fall because September and all these months are fall, and things like February or March and April are in the spring. So the maximum is in the spring, and the minimum is in the fall. And that's what the question says right here. It is still sinusoidal. We got it. We're good to go. Thank you, everybody, for all the hard work. We usually try to go until 2 p.m. today. So you've done all this hard work. Great job. I will see you on Monday. The quiz will be very similar to this. So you should have this quiz and this homework done this weekend. So remember to do it. Goodbye, everybody. Say bye if you're still here. We'll end with a randomness. Now let's end with a rainbow. So here's our rainbow for the day. We got it. Turn it black at the end. Let's do this. And of course, we're going to end with a little bit of randomness. Bye, everybody. I will see you on Monday.